And now we're on to question 2. So question 2 says 2.1. The first term of an arithmetic sequence is -1 and the seventh term is 35. Determine the common difference of the sequence. Okay, so they told us that it is arithmetic and they're telling us certain things. If the first term is -1, notice that since they're speaking about terms, we're going to use the Tn formula of an arithmetic pattern, which is a plus n minus 1, and then multiply by d. So the first term is -1. The first term is always your a value. So they're already telling us what a is. A is -1. And then they said the seventh term is 35. So seventh term, 35. We can call that T7 is equal to 35. And this is definitely more than enough to find the value of D. So first of all, you can say Tn is equal to, and in place of A was saying, oh, I said 1, -1, sorry. So -1, then plus n minus 1 times D. We still don't know what that is. Then we can substitute term 7 into this. So in place of n, you see like Tn, you see that 7 is sitting in place of n. So in place of n, I'm going to put 7. So T7 is equal to -1 plus 7 minus 1 times D. Then we know the value of T7, it's 35. So in place of T7, say 35 is equal to -1 plus 7 minus 1 is 6. So we have times 6 and then times D, of course. So when they multiply, that just gives you 6D. Then we can take the -1 over. It'll become a positive. So giving you 35 plus 1, which is 36, is equal to 6D. And then if you divide both sides of the equation by 6 to solve for D, D would be equal to, what is 36 divided by 6? That would be 6, because 6 times 6 is 36. So that's the value of D. Okay, moving on to the next question. The next question wants us to determine the number of terms in the sequence if the last term of the sequence is 473. Okay, so the last term. So it just means that you have your certain terms here, T1, T2, T3, and it keeps going. Then the last term, T, we don't know, so we call that Tn. That term is 473. So you can already see now we're going to replace, in place of Tn, we're going to put 473. So what is our formula? So we can put Tn into this. Our formula, since we have D, is Tn is equal to A. So A is -1. So we already know that -1 plus, then we say n minus 1, and then of course multiply by D, which we know now is 6. So multiply by 6. Then in place of Tn, we're going to just put 473. So 473 is equal to -1 plus, I'm going to rewrite this like this. You see, this is one term, it's being multiplied by two terms. You can just put the 6 in front and then n minus 1. Okay, so we can go ahead and take this -1 over first of all. So that's 473 plus 1, which is 474, is equal to 6 multiplied by n minus 1. I'm not going to multiply this in. Rather, I'm going to get rid of the 6 by dividing both hand sides by 6. And so 474, I'm just going to do it on my calculator, divided by 6. It's going to be 79. Okay, so 79 is equal to n minus 1. And then, of course, we're just going to take that -1 over, and we have 79 plus 1, which will be n, and so n is equal to 80. So it means that there are 80 terms in this sequence, so 80 terms. Okay, next question. Okay, so the next question, 2.1.3, we have we have to determine the sum of the first 40 terms in the sequence. Okay, so since we have to determine the sum, we have to just use the sum formula of an arithmetic sequence, since this is an arithmetic sequence. So remember, there are two formulas. There is this one, or you could use this one. Sn is equal to n over 2 bracket a plus l. Now, honestly, in this situation, you can use any one, and I would actually rather go with this one because it will be quicker. With this one, you need to know the last term as well. So I'm just going to go with this first formula. So we are saying the sum of 40 terms, meaning S of 40 is equal to, and we're saying in place of n, that is 40 over 2 multiplied by 2 bracket a. So in place of a, we know what a is. It's -1. So -1, then of course plus n minus 1. N is 40. So 40 minus 1. And then multiplied by d. D is 6. So we already found that, 6. And let's go ahead and see what this gives. So you can just punch this all into the calculator. And let's see what the sum of 40 terms is going to give us. And when I put that onto the calculator, I get 4,640. Okay, so just make sure you put it in just like that. There needs to be bracket around that 6 because the 6 needs to multiply to that. If not, the calculator won't understand that it needs to multiply. Okay, so that's done. Moving on to the next question. Okay, 2.2, this is the next question. We have 75, 53, 35, and 21 is a quadratic number pattern. The first question we have is that we have to write down the fifth term, okay, of this pattern. So notice they've given you 1, 2, 3, 4. So the fifth term, this is a typical question that they ask with quadratic patterns. Okay, so when we have this type of question, first of all, to find this term over here, because it is a quadratic pattern, okay, we're going to have to do these. First, we have to find the first difference. So the first difference will be found by saying the next term minus the previous term. So 21 minus 35. So that's going to be a negative number. It's like saying 35 minus 21, which is going to be 14. Okay, so negative 14. And then we have 35 minus this number. I'm just going to start using the calculator from here. Okay, so then 35 minus 53 would give you negative 18. And then lastly, you need to say 53 minus 75. And that will give us a negative 22. So this is the first difference, which is, of course, a linear pattern or arithmetic pattern. Then we have to find the second difference. So the second difference, negative 14 minus negative 18. So that's saying negative 14 minus negative 18. You see a negative and a negative give you a positive. So it's negative 14 plus 18. That's like saying 18, positive 18, and then minus 14, which will give you a 4. And then again, to get the other one, I know it's going to be constant. So you will see that it will also be 4. So negative 18 minus negative 22. That gives you a positive negative 18 plus 22, which is really just 22 minus 18, which is 4. Okay, so we have the first and second difference. And now in order to find that fifth term, all you will do is this. From the second difference, you know the second difference is constant. And so we know that after this, we would also have another 4. And in order to get the next term in the arithmetic pattern, you would simply say this negative 14 plus the 4. And it's really just plus because the 4 is positive. So plus 4, which will give you a negative 10. Then to get the next term over here, you would take this term, this 21, and you really just add it to this. So it's like 21 plus negative 10, which is really just 21 minus 10, which would give you an 11. Okay, so 21 minus 10, 11. So that is T5. So T5 is equal to 11. Okay, so moving on to the next question. Then the next question is determine the nth term of the number pattern. Okay, so this will already help us find all of that. The nth term of the number pattern, we're just going to circle the first terms in each of these patterns, the quadratic, the first difference, and the second difference. And so we're going to make the first one. That is going to be, or we can start from here. So we'll make 2a equal to this. And then this one, the first term here, we make that equal to 3a plus b. And then this term, we make that equal to a plus b plus c. So to solve for that, okay, to solve for a, we'll say the 2a being equal to the 4. And solve for a, we'll divide both sides by 2. And so we have a is equal to 2. Now that we have a, we're going to find b by saying 3a plus b is equal to negative 22. So 3a plus b equals negative 22. But we already know what a is. So we can say 3 bracket in place of that 2. Okay, so I'm saying that b is equal to, we have negative 22. 3 times 2 is 6, positive 6. And so when we take this over, it becomes a negative 6. So b is equal to negative 22 minus 6, which is negative 28. Okay, so we have b now. Now to find c. Okay, so to find c, we're going to take this a plus b plus c and make it equal to 75. So it's just a plus b plus c equals to 75. But we know what a is, it's 2. And we know what b is, it's negative 28. So plus c equals that. So 2 minus 28, that is going to be negative 26. Plus c equals 75. C is equal to 75. Then taking that over becomes a positive 26. And c is equal to... Okay, so when I put that on the calculator, I get 101. So this is the value of a, b, and c. And remember, the n term or the general term for a quadratic number pattern is really just Tn is equal to an squared plus bn plus c. But since we know what a is 2. So 2n squared. And bn, so that is the b is negative 28 minus 28n. And the c is 101, so plus 101. And this is our Tn pattern, or the n term of the number pattern. Okay, moving on to the next question. Then the last question in question 2 says, determine the maximum value of the following number pattern. Okay, now at this point at the end of the question, it's weird that they're introducing a brand new pattern. So it's likely that it's not a new pattern. It probably has something to do with the previous pattern. Also notice the mark allocation for this. This is 4 marks. There's no way they would ask you for 4 marks to find the maximum value. So you still have to first of all find the Tn pattern of this. Then go ahead and find the maximum value of it. Where they're clearly here rewarding you 4 marks just for finding the pattern on its own, the Tn formula of this pattern. So let's just see the similarity between this new pattern and the pattern that we have. Okay, so here is the pattern that we have. I'm just going to write it down below. Okay, so this is our old pattern. And look at the new pattern. So if you look at those two, you're going to notice that, look at this. We have 53 here, we have 53 here. We have 21 here, we have 21 here. The only difference is we have a negative 5. So this is a case where they're taking the old pattern and we're dividing that old pattern by negative 5. So if you're dividing the old pattern by negative 5, this is what's going on. So you see the 75, you say 75 divided by negative 5, it will give you that negative 15. So you can also just go ahead and verify this on your calculator. And again, if you take this 53 and you divide it by negative 5, it's going to give you that because 53 and 5 have nothing in common. So you see that they're taking the old pattern and they're dividing it by negative 5 to form a new pattern. So if you wanted to find the maximum value of this, instead of you going ahead and finding the formula of this pattern, all you have to do is take the formula of the old pattern and divide it by negative 5. Since each term in the pattern is being divided by negative 5. So I'm taking this pattern, Tn is equal to the 2n squared minus 28n plus 101, and I'm going to divide it by negative 5. And let's see what we get now. So our new pattern Tn is now equal to, we have this divided by negative 5. That's just going to be negative 2 over 5n squared. And then negative 28n divided by negative 5 is negative, no, it's positive, sorry, 28 over 5n. And I'm just simplifying it like that because they clearly have nothing in common. And 101 divided by negative 5 is negative 101 over 5. Okay, this is the new pattern, divided by negative 5. So now all we have to do is find the maximum value of this pattern. Okay, so remember this pattern as a graph, it's really a parabola. And if you look at this parabola, imagine this was x and that was x. If we have this as a parabola, you see that the coefficient of n squared or x squared is negative. So it means that your parabola looks like that. And it makes sense that it looks like that. That's why they're asking for the maximum value. Okay, because this type of parabola, you see that at the turning point, this will be the highest value it will have, the highest y value. That will be your maximum. So we have to find that y value. So it's really like looking at it like this. It's like this is the graph and we have to find that y value. But in order to find the y value, we need to find the x value first belonging to that. And in order to find that, you can either use calculus, or if maybe you're watching this video at a point where you guys have not really been taught calculus, you can also use this formula. So you can say x is equal to negative b over 2a. Okay, so we're going to use this and we're going to substitute this into here. So negative b, just remember it is still in the form of an squared plus bn plus c. So the value of b in this case would be this positive 28 over n, because that is the coefficient of n. And then the a, of course, would be the coefficient of a, which is negative 2 over 5. So let's go ahead and substitute that. So I'm saying, in this case, it's not really x, but yeah, I'll leave it like that. I could have said n is equal to, but it's okay. So negative and 28 over 5. And then we have over 2 bracket negative 2 over 5. Okay, so you can just put that into the calculator. So I'm going to pull up the calculator just so that I can also just give a little guide on that. Okay, so when we're putting this on the calculator, first of all, for this entire fraction, you can just put a fraction button. Okay, then while you're on the numerator, we can go ahead and say negative and then open a bracket. So open a bracket. Then we have the 28 over 5. So over 5. Come out of there and then close that bracket. Then go on the bottom using your middle buttons there. Then we have 2 bracket, we have negative 2 over 5. Okay, and as you can see, the calculator is already going ahead and simplifying that to 7, even if you don't close that. So it's 7. That is what our n value is. I know I said x is equal to, but it's really just n is equal to, because it's speaking about a term number belonging to that maximum. So n is equal to 7. Okay, now that we have the n value of 7, that belongs to the x-axis. We're going to have to still find the y value, which is literally the maximum value. Okay, so let's go ahead and find that, and we'll just do that by taking this 7, this n is equal to 7, and substituting it into that original equation, that formula of your pattern. So T7 is now equal to, and then we have negative 2 over 5 multiplied by something squared. So we have a 7 squared. 7 all squared. Then, of course, the plus 28 over 5 multiplied by 7. And then minus 101 over 5. And you can just put that all into your calculator. And when I put that into the calculator, I get negative 3 over 5. So T7 is equal to negative 3 over 5. So it really just means that this pattern is actually like that. Okay, but the n value is still the same. So that is the maximum value. You can go ahead and conclude for them. The maximum value is negative 3 over 5. Okay, so moving on to the next question. And that's actually the end of question 2. So we move on to question 3 now. So we have question 3, and 3.1 says, consider the following geometric sequence. And this is where we have 3 terms, and we have to calculate the 10th term of the sequence. Okay, you do not have to find the Tn formula necessarily. You just have to find the 10th term. So you can find it by doing this. You want the 10th term. The Tn formula is Tn is equal to a r to the power of n minus 1. And all you're going to do is you're saying T10. Okay, you want the 10th term is equal to a. What is the value of a? It's the first term, which is 1024. So 1024 multiplied by r. Okay, to find your r, you're just going to say next term minus previous term. So you can also just say T2 divided by T1, but that looks simpler. So 64 divided by 256, and that is going to give us, and then we just see, and that gives us 1 over 4. So it's just 1 over 4 raised to the power of n minus 1, and n is 10. So 10 minus 1. So if you put this onto the calculator, you're going to get your T10, which is, of course, 1 over 256. Okay, so that is the 10th term of the sequence. Moving on to the next question. Okay, then the next question, we have 3.2. For 4 marks, we have to calculate the sum of a pattern with this formula from p being equal to 0 till 8. Okay, so when you're calculating the sum of series, you're going to have to think about the following. You need to know what A is, you need to know what R is, and you need to know what N is. Okay, so in order to actually just do this for this pattern, it looks a lot like the previous pattern. To do this for this pattern, just expand this to at least 2 terms. That's really all you need. That will help you with A and N. It's definitely geometric because you see on the exponent, you have a variable. Okay, so the first term, we're just going to take, if we take 256, multiply by 4 to the power of 1 minus, and they are starting where p is equal to 0. So if you put 0 there, what do we get? And you see, you get the same thing as the previous one. The first term is 1024. And so, of course, the next term you can already expect is going to be that. You can also go ahead and try. So after p being equal to 0, p will be equal to 1. Which, of course, you see the second term is 256. So you can see everything is really the same. It was just put in a different way. It was simplified differently. So everything is the same. It means that R, of course, will also be 1 over 4. And so A is also 1024 as the first term. Now, the only thing to actually think about is when you're calculating the value of N. So to find the value of N, N is going to be, you need to say the top minus the bottom plus 1. That is the rule for N always. And so if we do that, you see that's going to be 8 minus 0 plus 1. Okay, top minus bottom plus 1. And that is equal to 8 minus 0 is 8 plus 1, which is 9. You have to do that because if not, you're going to ignore the fact that p is equal to 0 is a term. So you have 0, 1, 2, 3, all the way to 8. This is also a term. So they're not 8 terms, they're actually 9 terms, including p equals 0. Okay, so now this is enough information to actually find what we need. So I'm going to use this formula, Sn is equal to, and we have A multiplied by 1 minus R to the power of N over 1 minus R. You can use the other formula. I just like to use this when I say that the R value is less than 1. So we have is equal to, and we have A, which is 1024, 1 minus our ratio is the 1 over 4. So we have 1 over 4 raised to the power of how many terms? 9 terms. All over 1 minus, and then we have 1 over 4. Okay, so you can go ahead and just sub that into your calculator. This will tell you S of 9 terms. Okay, so the sum of this is this 87,381 over 64. Okay, which as a decimal is this. So S of 9 is 136.5 point, and then if you round off to 2 decimals, 33. Okay, so that is our final answer over there. Moving on to the next question. Okay, so then the last question in question 3 says, the first 2 terms of a geometric sequence are, we have this negative t squared minus 6t minus 9, and then this, as we can see, is a cubic function, and over 2. And we have to determine the values of t for which the sequence will converge. Okay, values of t for which the sequence will converge. For a sequence to converge, your ratio needs to be greater than -1, but less than 1. So the next thing we'll have to do is really just find this ratio so that we can go ahead and say it's greater than -1, but less than 1, and solve for that inequality. So how do we find the ratio? If this is, they said this is the first term, the first 2 terms, first term, and this is the second term. The only way to get the ratio is to say T2 divided by T1. That's what we'll have to do. But if you look at T2 and T1, they look weird right now. So we're going to have to simplify those two so that we can actually properly divide them. Okay, let's start with T1. So T1 is equal to this, negative T squared minus 6T minus 9. How do we simplify this? It is a quadratic expression, and since it's a quadratic expression, we can factorize it. But in order to factorize this, we can start off by taking out a negative as a common factor, just so that this t squared can be positive. So we can have negative out as a common factor. It's kind of like taking out -1. Open a bracket, and so let's say negative t squared divided by the negative will give you a positive t squared. Remember, it's like saying, what do I multiply to this -1 to get back to negative t squared? And you multiply that by t squared. Okay, but I like to divide. It just makes it look easier. Then negative 6t divided by that negative 1 will give you a positive 6t. And then negative 9 divided by that negative will give you a positive 9. Okay, so now that it looks like this, that looks so much better. We have the negative and we can factorize that now. So that is t multiplied by t, which gives you the t squared. So we need factors of 9 that can give us 6, and everything is positive. So that can be positive 3 and positive 3. Because if you say 3 plus 3, it gives you 6. But if you say 3 times 3, it gives you 9. Okay, so you see we have that. That can actually go a bit further. It can be simplified further. You see, because you have the same bracket being multiplied by the same bracket, you can rewrite it like this. We have the negative first, then t plus 3 all squared. There we go. There's the t1 simplified. Okay, let's also go ahead and simplify that second term. So we have t2 is equal to, and t2 was equal to this. Let me just rewrite that. Okay, now that we have this, okay, to simplify this, we need to factorize this cubic function, which takes long. Okay, so let's factorize it. In order to factorize it, remember, I'm not really bothered about the 2 right now. I'm really bothered about that top. Okay, so I'm only factorizing that top. Now, in order to factorize this first, we need to look at the last term, which is the constant, and we're going to take factors of the constant. So let's think about factors of 27. Factors of 27 are, so this is factorizing a cubic function. Factors of 27, 1 and negative 1, 3 and negative 3, 9 and negative 9, 27 and negative 27. And now we're going to have to start taking each of these and substituting it into this expression. And the one that gives you 0 is your solution. So you can go ahead and do that. But let's just take a lucky guess. Okay, and it's probably going to be this. Remember, we still have to say t2 divided by t1. So definitely this one has something to do with that. Maybe t plus 3 is also a factor here. Okay, so if t plus 3 is a factor, it would mean that the factor, the number that would work here, okay, these are really like solutions. The number that will work here is if you say t plus 3 is equal to 0 and you took 3 over, okay, t being equal to negative 3. Let's try negative 3. If we substitute negative 3 to this and it gives us 0, then it would mean that t plus 3 really is a factor. Okay, so I substituted this negative 3 into this equation and I got 0. Okay, so it means that this is one of the solutions. And so that will really just mean that as a factor, what we have as a factor is t plus 3. Okay, so if negative 3 worked, it just means that this is one of your solutions for t when you make y equal to 0. Okay, so it's like taking that negative 3 over, that positive 3, over the equal to sign. So t is equal to negative 3 over here. But as a factor of this cubic function, we have t plus 3. Okay, so if this is a factor, let's just factorize the rest of this and see what this is going to give us. Okay, how we factorize this, you're going to draw an L, the letter L, backwards. So like that. And now that we have that, over here, you're going to put the roots that worked, which was the negative 3. So negative 3 goes here. And then inside here, you're going to put the coefficient of your cubic function. So here, where we had t cubed, the coefficient of t cubed was an invisible 1. So we have 1 here. And then the coefficient of t squared is the positive 9. So we have a positive 9 here. Coefficient of t is the positive 27. We have a positive 27. And lastly, the coefficient, well, the constant is just 27. So positive 27. Then to factorize this, you're going to drag down the 1. And now you're going to say this 1 multiplied by negative 3, which gives you negative 3. We put that up here. The negative 3 plus 9, which gives you positive 6. So positive 6 over here. Then 6 multiplied by negative 3, which gives you negative 18. Then negative 18 plus 27. So if you say 27 minus 18, that gives you 9, positive 9. Then this positive 9 multiplied by negative 3, which gives you negative 27. And negative 27 plus 27 gives you 0. You should always end with 0 here. If you don't end with 0, then it means something must have went wrong with your calculations. Okay, so this is what we're going to have. Remember that t plus 3 is already a factor in this term too. T plus 3. Then the other factors, okay, of this cubic function when it's factorized is going to look like this. So we're going to have these numbers here. These are your solutions. They would be the coefficient of t squared, t, and your constant. So this is really just going to be 1t squared in this bracket, but we can just call that t squared. And then we have a positive 6t, so positive 6t, and then the constant is just a positive 9. If you simplify this further, we have t plus 3. If we factorize that, that's going to just be, again, as you can see, we already had that. We factorized this at the beginning, and you saw that it gave us t plus 3 and t plus 3. So that's really what it gives you, t plus 3, t plus 3. Okay, so we have 3 factors being multiplied, and they're all the same. You can simplify this to t plus 3 all cubed. Okay, so that's what that simplifies to. So it means that term 2, remember, is still being divided by 2. So term 2 is really just term 2 is equal to all of that factorized t plus 3 all cubed over 2. That's what term 2 is. Okay. Now that we have term 1 and term 2, so this is term 1, that's term 2. The whole goal of this was to find out the values of t for which the sequence will converge, and so we needed to find r. So to find r, remember we say t2 divided by t1, and that's what we're going to continue with. So term 2 divided by term 1 to find the ratio. Term 2 is of course this, so we're saying t plus 3 all cubed over 2. Okay, and now since we have to divide it by something, I'm not going to now say over, since this is already a fraction. So I'm going to say divided by, and we're dividing it by this. So negative bracket t plus 3 squared. Okay, so just a bit of simplifying. We have t plus 3 all cubed over 2. When you are dividing, there's a rule called tip and times. So you're going to look at the second term, and that is really a fraction. You need to make it a fraction. Since it's not a fraction, we're going to put it over 1. What you're going to do is you're going to tip this one, meaning swap the numerator and the denominator. So now this becomes 1 over this negative bracket t plus 3 or squared. And then you're going to change this division to a times. That's why it's called tip and times. And if we simplify this, this is what we're going to have. Remember that if things are common diagonally, you can cancel them. So over here, look at this. This and this, what's common? Okay, I noticed that I said 2. Sorry, this should be 3. Okay, so we're looking at this and this. What's common? You see that we have t plus 3 to the power of 3. Here we have a t plus 3 to the power of 2. A t plus 3 to the power of 2 can cancel here, and one of it can cancel here. The 2 to the power of 2 can cancel here. So it means you're going to only have t plus 3 to the power of 1 left, because it has been cancelled across now. So this will be equal to, the ratio is really just, we have the t plus 3 to the power of 1 being multiplied by 1. Anything times 1 stays the same. So we just have t plus 3 over, here we have a 2, and then we still have a negative outside that bracket. This has already been cancelled. So remember, in front of every bracket, there's actually an invisible 1. So that is 2 times negative 1, which is negative 2. This is our ratio. And now that we have the ratio, to find out the values for which it will converge, we just have to make the ratio greater than negative 1 but less than 1. So we are saying r, which is this, so it's the t plus 3 over negative 2, needs to just be greater than negative 1 but smaller than 1. Okay, let's solve for this. To solve for t, we first have to get rid of this negative 2. So to get rid of this negative 2 as a denominator, you can multiply both hand sides by negative 2. But remember, when you divide or multiply by a negative number in inequalities, it will cause the sign to change. So negative 2 times negative 1 is positive 2. Then the sign changes and faces the other direction. Then this negative 2 is gone. So t plus 3, that sign changes because you're multiplying by negative. That becomes negative 2. Okay, so we will fix the inequality. It's not facing the right direction right now. Then we have a plus 3. So we're taking that over. But remember, this is really two inequalities. What you do on the one side, you do on the other side. So we're going to take that over, really. It's like on both sides. So we're saying the t here, the 2, sorry. Then we have positive 3 coming over, becoming a negative 3. And we have t in the middle now. And then that sign, negative 2, the positive 3 comes over and becomes a negative 3. Okay, so finally we have t. 2 minus 3, we have that sign is negative 1. And then again, negative 2 minus 3 is negative 5. Now you just have to write it correctly because the inequalities do not look like that. They don't face that way. They always face the other way. And so you do this by putting t in the middle. The smaller term should be here, the smaller value, which is negative 5. And the bigger one should be here, which is 1. And so now when you look at the negative 5 versus the t, negative 5 versus the t, the mouth is facing the t. So you have to draw it in the same way the mouth is facing the t. And when you look at the t versus the negative 1, the mouth needs to face the negative 1. So the mouth needs to face the negative 1. Sorry about that again. Okay, so that is your answer. It means that t is greater than negative 5 but less than negative 1. That would be the values of t for which that sequence or series will converge. Okay, so that is it for question 3. That's the last question. Hey grade 12s, and welcome to this video. In this video, we're going to be working on question 2 of Gauteng's 2022 June paper 1. So let's begin. So question 2.1, we are given the geometric sequence 9 over 2, 9, 18, and then this continues all the way to 2304. 2.1.1, we have to determine the value of R, the common ratio. So to find the common ratio or the constant ratio, all you have to do is always say the next term divided by the previous term. So this can be the term 2 divided by term 1, or you could say term 3 divided by term 2. And I'm going to go with term 3 divided by term 2 because these have numbers and not fractions, and that's just easier to work with. So that is 18 divided by 9, which is really just equal to 2. So moving on to the next question. And then the next question, 2.1.2, we are asked how many terms are there in the sequence. So in the sequence, you can see that the terms end at 2304. That's the last value that we have. So to find out how many terms that would be, we have to find out what term exactly is that. And because we're speaking about what term exactly that is, we're going to use the Tn formula. Okay, so the Tn formula of a geometric sequence or series is Tn is equal to A multiplied by R to the power of n minus 1. And so we know what the last term is already. So we know this is our last term. It's also going to be our Tn. So you can also just see it as we're using Tn because we're just trying to find out what n is. So that is the term value. So in place of Tn, I'm saying that number 2304 is equal to, and our A is our first term, which is 9 over 2. So 9 over 2 multiplied by our R, which we know now as 2, multiplied by 2 to the power of n minus 1. And so we're just trying to solve for n. In order to solve for n, we just have to get n on its own. The first thing that is disrupting us from finding n would be this 9 over 2. If we can get rid of this number, then we'll get closer to this 2 to the power of n minus 1. So we can divide both sides of the equation by 9 over 2. And so that is, to find this, we're just going to say 2304 divided by 9 over 2, and we get 512. So 512 is equal to, that cancels, and we're left with 2 raised to the power of n minus 1. Okay. Now we have an exponential equation where n is still missing. So to find n, we're going to have to make the bases the same so that we can equate the exponents. So how can 512 be put as a base of 2? Well, you can simply on your calculator just press 512 is equal to, then press shift and the fact button. You're going to notice that on your calculator, that button is going to look like a degrees and 3 commas. Okay. then it's 2 to the power of 9. So 2 to the power of 9 is equal to 2 raised to the power of n minus 1. Now that the bases are the same, we can go ahead and just equate the exponents. So we're saying, therefore, 9 is equal to n minus 1. Then we're taking the negative 1 over, and so that will become a positive 1. So 9 plus 1, that is 10. And so we know now that n is equal to 10. Okay, so that is how many terms there would be in the sequence. You can conclude there are 10 terms in this sequence. Okay, so I'm just saying there are 10 terms. So moving on to the next question. So the next question, 2.2, we are given sigma. So that is the sum. The sum from k is equal to 1 to infinity of this pattern, or with this formula, 6 multiplied by m to the power of k minus 1 is equal to 12. We have to determine the value of m. Okay, so notice that we're starting at 1, we're ending at infinity. So this is the sum to infinity. Then they give us the formula, or the Tn pattern for this, or the, in this case, Tk pattern for this series. And they also tell us it's equal to 12. So we know what the value of the sum to infinity is. But with this pattern, I also want you to just notice this. The general formula of your Tn pattern is Tn is equal to a bracket r to the power of n minus 1. And as you can see, this one is taking the same form. It's taking the same form. So as you can see, we have a here. That is going to refer to our a. The m is really our r. And as you can see, we have k minus 1, but here n minus 1. Okay, so to find the sum to infinity, the sum to infinity is equal to a over 1 minus r. So you can see that all we need here is the value of a and the value of r. So let's just search for that in here. Our value of a is going to be, as you can see, it matches that perfectly. So it's 6. The value of a is 6, and the value of r is m. Okay, so that is our value of r. And we also know what the sum to infinity is. The sum to infinity, they told us that all of this, the sum from k being equal to 1 to infinity is 12. So the sum to infinity is 12. So all we have to do here is substitute this in and solve for m. So sum to infinity, in place of that, I'm going to put 12, is equal to our a, which is 6, over 1 minus r, which is m. And let me just put m in a different color, so m. So we just have to solve for m. To solve for m, because we have a fraction, a number, and an equal to in between them, we can cross multiply. So first of all, put this 12 over 1 to make it a fraction. And then we're going to cross multiply 12 multiplied by this. You can rewrite this as 12 multiplied by 1 minus m, because the 12 has to multiply into the 1 and the m. So the 12 is not just going to multiply into one of the terms here. Then again, we have 6, 1 times 6, which is going to just give you a 6. And now we just have to solve for m. So you could have done it in a way of multiplying this 12 in, but I can see an easier way of doing this. We can just get rid of the 12 by dividing both sides of the equation by 12. And so now here we just have a 1 minus m, which is equal to 6 over 12, which is just a half, so a half. And then now we just have to take this m, I'm going to take it over since it's negative. So if you take the m over, here's our equal to, m is now positive, and then over here we still have the 1. Then we can take this 12 instead over, and that becomes minus 12. So 1 minus 12 is a half, and so it means that m is just equal to a half. Okay, so that is that question 2.2. Moving on to the next question. Okay, so 2.3 says the third term of a geometric series is 18 and the fifth term is 162. Determine the sum of the first 7 terms where r is less than 0. Okay, so we're going to look at the information they've given us. First of all, they told us the third term, T3, of this geometric series is 18. And then they told us that T5 is 162. But then after we have worked that out, we're going to have to determine the sum of the first 7 terms where r is smaller than 0. So to determine the sum of terms, you're going to need the value of a and you're going to need the value of r. So that's why they're giving you that information to find A and R. So this is how we can use the information they've given us. So since they're giving us terms, we can use the term formula of geometric patterns. So that is Tn is equal to A multiplied by R to the power of n minus 1. Remember they told us T3. So we know that term 3, that is equal to 18. And we also know that term 5 is equal to 162. We're going to take this information and substitute it into the Tn formula. So instead of Tn, we know what n is. T3 is equal to A, we don't have A yet, multiplied by R, we also don't have R yet, to the power of n minus 1. We know what n is, so it's 3 minus 1. So it means that T3 is just going to be equal to A multiplied by R to the power of 3 minus 1 is 2, so R squared, that is T3. So now that we have this, you also have to remember that we know the value of T3 is. Term 3 is equal to 18. So in place of T3, we can say 18 is equal to, now it's just AR to the power of 2. Okay, and this is really our first equation. So I'm going to substitute. In place of this, I'm saying T5 is equal to A, we don't know what A is, multiplied by R to the power of n minus 1, so that's 5 minus 1. And so T5 is equal to AR to the power of 4. But we know what T5 is. T5 is 162. So 162 is equal to AR to the power of 4. Okay, so see this like this. You can see this as your first equation and that as your second equation. So this is one way of doing this. You can also, there's also an alternative way of finding this. So because this is a geometric pattern, you can't say equation 2 divided by equation 1. And if we do this, this is what we're going to have. So remember, since we are dividing these equations, also remember that the equations have two hand sides. They have a left-hand side and a right-hand side. So the left-hand side must be divided by the left-hand side. So that is the 162 being divided by the 18, and that is going to be equal to, because they all have equal to, we also have to say the right hand side, which is AR to the power of 4 divided by the right hand side of equation 1, so that's AR to the power of 2. Okay, so this is what we have so long. And so here you can see that A and A would cancel, and then you would just be left with 162 divided by 18. That gives us 9. So we have 9 is equal to R to the power of 4 divided by R to the power of 2. Remember, the bases are the same and we're dividing, so you need to subtract the exponents. So the base will stay the same, it will stay an R, but 4 minus 2 is 2. So this is what we have so long. And to solve for R, we're just going to go ahead and square root both sides of the equation. But remember, in front of the number, we're always going to say plus, minus, because not only the positive of this would work, the negative would work as well. So R really is just going to be equal to a positive or a negative 3, because the square root of 9 is 3. So R is either equal to positive 3 or R is equal to negative 3. So also just remember, it's because this is saying R squared is equal to 9. So something squared is equal to 9. Even if you said 3 squared, it will give you 9. But if you said negative 3 squared as well, it would also give you 9. And that's why we include the plus minus. So let's go ahead and check back in the information and see which one we can accept. Remember they said where R is less than 0. So R needs to be less than 0, meaning we cannot take 3 because 3 is not less than 0. So we can cancel 3 and take only this one. So R is equal to negative 3. So this is a way that we can do this. But also just remember, if it was the case that they gave you an arithmetic formula instead, what you're going to have to do is, instead of saying equation 2 divided by equation 1, you could instead say equation 2 minus equation 1. Okay, so we have R. And now we just have to find A. Okay, so we have R as negative 3. Let's find A. A we're going to find by basically substituting R into one of these formulas, into equation 1 or equation 2. Always take the easy one. Equation 1 looks so much more simple. So we're going to take 18 is equal to AR squared, and in place of R, we're going to just substitute negative 3. So A multiplied by negative 3 raised to the power of 2. Okay, so to solve for a, we're going to have to just divide both sides by this. So we just have 18 is equal to a, and that is a 9. That becomes 9. So negative 3 squared. And so divide both sides by 9, and we're going to get a. If we divide 18 divided by 9, that is going to give you 2. So a is equal to 2. So now that we have a and r, we can go ahead and find the sum of the first 7 terms. Okay, so to the sum of the first 7 terms, we need the SN formula. So here r is smaller than 1, so I'm just going to use the formula Sn is equal to a bracket 1 minus r to the power of n over 1 minus r. Honestly, it doesn't matter. If you use the other one, it would still work. So if you use this one, it would still work. So we want the sum of 7 terms. So we're saying the sum of 7 terms is equal to a is 2. So 2 multiplied by 1 minus r being negative 3. So we have negative 3 raised to the power of 7 in place of n. And then all over 1 minus, again, we have negative 3. And I'm just going to put that in brackets. So let's put this all onto the calculator and see what we get. And as you can see on the calculator, we get that the sum of 7 terms is equal to 1094. Okay, so that is our answer there. So done with 2.3, and we're moving on to the next question. Now 2.4 says, the general term of a quadratic number pattern is Tn is equal to an squared plus bn plus c, and its first term is 8. So that is the first term of the quadratic number pattern. Okay, so quadratic, I'm just going to put those in blue, that's 8. Then they say the general term of the first differences of the pattern is tk is equal to 4k minus 2. So of the first differences, the pattern is this, the formula of the pattern. And what they want us to do is to determine the next 2 terms of the quadratic number pattern, Tn. So they want us to find the next 2 terms of that pattern, not the first difference, of the quadratic. Okay, so in order to do this, you need to be able to see the big picture in it. Since this is a quadratic pattern, you know that you're first supposed to have your quadratic pattern here, and then the first differences, and then the second differences. So let's put that down first. What do we have in the quadratic pattern? Well, they told us that the first term is 8. So we at least know that. We don't know what the second term is, but we know that. Then what do we have in the first differences? They told us that the general term of the first difference is this. We have the formula of the first difference, and this is more than enough to actually find everything, really. So if we have this, we have tk is equal to 4k minus 2. Okay, in order to find the first term in the first difference, we can just, in place of k, substitute 1 to find the first term. So it means that t1, our first term in our first difference, which is, remember, which is formed by saying term 2 in the quadratic pattern minus term 1 in the quadratic pattern. That gives you your T1 of your first difference. That's going to give us that. So let me just move these down. So that is going to give us this over here when we do this. Okay, so I'm also just going to label these ones as, since they call the quadratic number pattern Tn with a capital letter T. So I'm going to call this is T1 belonging to the quadratic pattern, T2, and of course it will keep going to T3 and so on. Okay, so let's find T1 first. So we're going to substitute in place of k. Let's put in 1. So we're saying 4 multiplied by 1 and then minus 2. Since this belongs to the first difference, it's the formula for it. So we have, this is equal to, that's going to be 4. 4 times 1 is 4 minus 2, which is equal to 2. So now we know that T1 is equal to 2. So we have that. That is 2. Okay, so now let's see, focus on exactly what they're asking you to do. They want you to find the next 2 terms of the quadratic number pattern. To find the next 2 terms of the quadratic number pattern, you can see that to find term 2, for example, you have to say term 1 here, this 8, plus this 2, and that will give you that term. And that is, of course, because if you had term 2, you would have said term 2 minus term 1 to give you this 2. Okay, so we're going to say 8 plus this. That gives you 10. So that's how we find term 2. So you can actually put that down. We're saying that term 2 would be equal to, we're going to take the 8, which is term 1, plus the 2. And it's only plus because this 2 is positive. So plus the 2, and so term 2 is really just equal to 10. So we have term 2 now as 10. So we can put that in here, 10. Okay, so now that we have term 2, notice that in order to find term 3, we're going to have to say term 2 plus whatever term 2 of the arithmetic pattern, the first difference is, whatever that is, to get term 3. So we're going to have to look for T2 in the arithmetic pattern now. So T2 would be term 2 is equal to, we're going to say 4, and in place of K, we'll put in 2, then minus 2. 4 times 2 is 8. 8 minus 2 is 6. So that is 6. So we have this now as 6. So it means in order to get term 3, we're going to say term 3 is going to be equal to, we're going to take the 10 plus 6. So 10, and it's a positive, that's why we're adding, plus 6 is going to give you term 3 as 16. Okay, so that is our term 3, 16. And that's how we get the next terms in this pattern. You see, so this was enough to help you. They just needed to give you this and at least the first term. You would have been able to find the other terms that come after it. Okay, so you can just conclude and tell them that this is your answer. Term 2 and term 3. That would be the next two terms. Okay, so moving on to the next question, 2.4.2. Then the next question, 2.4.2 says, hence or otherwise, show that the general term of the quadratic number pattern is given by Tn is equal to this. Okay, so to find the general term, you can see that this is basically complete. We have the quadratic pattern, the first difference. We just need to find the second difference. The second difference is found by saying term 2 minus term 1 of the first difference, and we're going to get 6 minus 2, which is just 4. So now it's complete. We can find everything we need. Also, another way to find this easily without even doing any calculation would be in your arithmetic pattern, the formula for it, it would be the coefficient of k or whatever variable they put here. So that is your difference. Okay, so to find the general pattern, we're going to use the first term of the quadratic, the first difference, and the second difference. And we're going to say, first of all, the second difference will equate it to 2a. And then the first difference will equate it to 3a plus b. And then the first term of the quadratic, we equate it to a plus b plus c. And so we can just find it now by saying 2a is equal to 4. So 2a being equal to 4, solve for a, we divide both sides by 2. And so a is equal to 2. Then to find b, 3a plus b will be equal to 2. And so in place of a, we're going to substitute 2. So 3 times 2 plus b is equal to 2. So plus b being equal to 2. And I'm going to now say b is equal to, I'm still going to leave the 2 here. And so I know that 3 times 2 is 6. And that's a positive 6. So we take it over and becomes a negative 6. So b is equal to 2 minus 6, which is equal to negative 4. And then lastly, to find c, a plus b plus c must be equal to 8. So that is just 2 plus, okay, not going to be a plus, it's a minus because of the negative 4. Remember, it's just like plus negative 4. And so if that multiplies in, it just becomes a minus 4. So we're saying 2 minus 4, and then we have plus c is equal to 8. So I'm just going to say c is equal to, and I'm dropping the 8 down. So 2 minus 4 is negative 2. You're taking the negative 2 over and becomes a positive 2. So we have c being equal to 10. And there we go. So it means that therefore Tn is equal to our an squared. 2 is a, so 2n squared plus bn. B is negative 4, so negative 4n plus c, which is a positive 10, so plus 10. And that is our final answer here. And then we have the last question in question 2. 2.4.3, which term of the quadratic number pattern will be equal to 3050? So remember, they are asking you which term So here they're just asking you, since they're talking about term, they're speaking about n. We don't know what n is. Which term of the quadratic pattern will be equal to this number? Okay, so when we're trying to find out what the term belonging to a specific term value is, then this is going to be our Tn value, because that's our term value. And because n is missing, it's going to help us to find n. So the Tn formula of this, as we can see, is this. So in place of Tn, we will replace it with 3050. So we really just say 3050 is equal to, and then we have 2n squared minus 4n plus 10. Okay, so we just have to solve for n. To solve for n, this is a quadratic equation the minute you see n squared. So it's best to take the constant over that number without a variable. So we have 0 here is equal to 2n squared minus 4n. Then we have a plus 10. And when this comes over, it's going to become negative. So see it as it's a positive 10 minus 3050, because that becomes negative. So here we just have negative 3040. Okay, now that we have this, I want you to notice that in each term on this right hand side, notice that everything can be divided by 2. So let's make this equation look simpler by dividing both sides by 2. So we have now 0 divided by 2, which is 0, is equal to this 2n squared divided by 2. 2 would cancel. You'll be left with n squared. Then negative 4n divided by 2, negative 2n. And then this number, negative 3040 divided by 2. So if I divide that by 2, you get negative 1520. So minus 1520. Okay. And then we have to factorize this. Well, you don't actually have to factorize it. So this is what you can do to pretend you factorized it. You can say 0 is equal to, open up 2 brackets. And this is easier when you have just n squared and not a 2n squared or anything here. So you're going to use the quadratic formula, but you're just not going to show them that you use the quadratic formula. You're going to put it in like this. So put a fraction, we're saying negative b. So negative, and we know that b here is negative 2. Okay, so that's just our value of b. Let me just put these in red. This is our value of b. Our value of c is this negative 1520. And then our value of a, as you can see in front of the n squared, there's an invisible 1 because there's nothing here. So a is just that 1. So let's just put this into the quadratic formula. We're saying negative b. So negative bracket negative 2 plus minus, but I'll start with a minus. So minus the square root of b squared. So we have negative 2 squared minus 4ac. So minus 4 times a, which is 1, times c, which is negative 1520. Close bracket. All over 2a, but 2 times 1. You don't even have to put the 1 because it's just going to become 2 either ways. We get a negative 38. So this is how to work this out. This is telling you the solution for n. It's not telling you the factor. In here, in these brackets, you're first going to have an n times an n so that you can get your n squared. This is telling you the answer. It's telling you that n is equal to negative 38. So if you think about it, what was in here so that we got an answer of n being equal to negative 38? It must have been n plus 38, because you would have said n plus 38 is equal to 0, then taken the 38 over, and it will be n is equal to negative 38. So that's something you can do. And then we have, again, the last one being or. Let's just change that into a plus now. So because of that plus minus. So that becomes a plus. And we get an answer of n being equal to 40. So it means your factor must have been n minus 40, so that you could have gotten that answer. So this is another way to just do it and it will look like you factorized, but you didn't really, because it's quicker like this. You know, you're trying to save time during your exam. So I noticed that in the video, I didn't conclude on this. So when you're choosing which one is the right answer, you cannot take the one that is negative, because your terms are never negative. Your terms are always positive. So it means that n is equal to 40. So the term that will be equal to this will be term 40, that will be equal to 3050. Okay, so that's it for question 2, and then we move on to question 3. Okay, so now we're on question 3, and question 3 says, the figure below represents a pattern of shaded triangles placed on a white rectangular board. The triangles all have equal bases of 4 units, so each of these have 4 units in length. Then the height of the first triangle is 1 unit, okay? So the height of this first triangle is just 1 unit. And then they also tell us that each of the triangles' height thereafter is 1 unit more than the previous one. So this one would be 2 units, and the next one would be 3 units, and so on. But remember that each of the triangles have a base of 4 units, all of them. And this is what they're asking us. They say in 3.1, determine the area of the first triangle. Okay, so to find the area of a triangle is equal to a half multiplied by its base multiplied by its height. So we're saying a half multiplied by the base being 4 units and multiplied by the height, remember, of the first triangle. The height of the first triangle is just 1 unit. So if we calculate this, a half times 4 is just like saying half of 4, which is 2, multiplied by 1, which is just still 2. So the area of the first one would be 2 units squared, okay, because it's in area. Okay, so that's the first question. Moving on to the second question, and you can see it's just for 1 mark. And then now the second question, 3.2 says, determine the area of the 26th triangle. Okay, so let's just see the pattern being formed here. Remember that all these triangles, regardless of what triangle it is, triangle 4, whatever it is, it will always have a base of 4 units. The only thing that is changing in the triangles are the heights. So the first triangle, the units is really just 1 unit. The second triangle has a height of 2 units. Third, 3 units. So you can already expect the 26th triangle would have a height of 26 units. So the first thing we know about this triangle, we know its height, 26. And then we also know that its base is never going to change. They're all going to be 4 units because they told us that. So we also know the base is equal to 4. So we can find the area of this triangle, again using the area formula. So A is equal to a half times the base times the height, but it's already there, so I'm just going to fill in. So a half multiplied by 4 multiplied by the height, which is 26. So we can see this as a half times 4, which is 2, and then 2 multiplied by 26, which is 52. So the area of this triangle is 52 units squared because it's in units. Okay, and then moving on to the last question, 3.3. So now 3.3 says, the triangles are placed on a rectangular board with a length of 104 units as shown above. So all these triangles are placed on this rectangular board and the length is that 104 units. Okay, then they say, as shown above, determine the area of the unshaded parts of the white triangular board. That is the area of the part not covered by shaded triangles. So when we're looking at this board, this is what they want. They want the unshaded part, the parts that is not including the triangles. So all of this white parts, that's what they want. So if you think about it as a physical piece of paper that you can see, when you're trying to find the area of the unshaded part, it's kind of like taking this full board as it is and just cutting out all the triangles from it, removing every triangle, and just removing everything that is a triangle from it. And of course, these triangles will keep going, keep going, and keep going. So in other words, we have to find out we can take the sum of each of the areas of the triangles, all those spaces. We can get the sum of everything and then get the area of the full board and subtract the sum of the area of the triangles from it. That will give us that unshaded part. Okay, but from what I just mentioned, remember I said we would have to find this whole area first, then remove the shaded triangles from that area. So the first thing to do is let's find the area of this entire board. So the area of the entire board, this is a rectangle. So we're just going to use length times breadth. The length, we know that. We know that the length of this is 104 units. But then the breadth, what is that? So how would we know what would be the breadth? Well, the breadth of it, or in other words, the height of it, would be, you have to think about what is the last triangle that we have? What is the height of the last triangle that we have? That would be the exact same thing as your breadth. So if we can find that, what is the last triangle that we're going to have and what is its height? Now, they've also given you another clue to figure this out. The fact that they said that each triangle is going to keep having 4 units as a base. So think about it like this. We know how long this rectangle is. And all of these, we're going to have triangles with a base of 4 units. So imagine it's like 4 plus 4 plus 4, and it keeps going up till 104 units. So up until 104 units, we're just going to keep on counting the 4s, and it's all going to give us that. So to find out how many triangles there would be, it's like trying to find out how many 4s do we keep adding together. And so to find out how many 4s do we keep adding together, in order to get the full length of 104 units, you can just say 104 divided by 4. That will tell you how many 4s you keep adding. Okay, so I'm going to call this the number of triangles. Okay, that will be the 104 divided by 4. And if you say 104 divided by 4, we get 26. Okay, so there's 26 triangles. Now that we know the number of triangles, this is what we can do. We know that there are 26 triangles, or 26 bases as well. Remember that the first triangle had a height of 1 unit. The second triangle had a height of 2 units. The third triangle will have a height of 3 units. So if there are 26 triangles, the last triangle is the 26th triangle. And so it will have a height of 26 units. If the height of this triangle is 26 units, that is also the breadth of the triangle. So that's another thing we're concluding. We found now the breadth of the triangle. So I can go ahead and say breadth is equal to 26 units. That's what I found from that. Okay, now that that is done, we know what the length of this rectangle is. We know what the breadth of the rectangle is. We can find the area of the rectangle. When we find the area, we're going to take that and subtract from it the areas of all the 26 triangles. So let's find the area of the rectangle first. So the one thing you must always do is make sure you're naming, or you're naming all the equations that you have, so that you don't confuse yourself. So the area of rectangle, so not that unshaded part, and that is going to be equal to length times breadth. And we already know the length. The length they gave us was 104 units. So that's 104 multiplied by the breadth, which we found to be 26 units. So 104 multiplied by 26, that gives us 2,704 units squared. That is the area of our rectangle. Okay, so we hold on to that. Now that we know the area of the rectangle, we have to subtract from that area the sum of the areas of all our triangles. So now we have to find out what is the sum of all the areas of these triangles. The areas of these triangles are also going to create a pattern. So let's actually look at the pattern it creates. We saw that the first triangle was just 2 units squared, right? So the area of that triangle. So the first triangle, or I'll say that as term 1, first triangle, or triangle 1. Okay, the first triangle was just 2 units squared. The second triangle, look at what's going to change. Only the height is changing. So it's the same thing as saying a half multiplied by, the 4 still stays the same. It's a base. It doesn't change. The height changes. From the first triangle to the second triangle, the height is 2. So we can see now the second triangle will have an area. So triangle 2 will have an area of 4 units squared. So let me just remove the unit squared for now, just to remove confusion. Then the third triangle, triangle 3, will have the height being 3 units instead. So we change that 2 to 3. And so we can see, okay, that's 6. So as you can see, this pattern, this is an arithmetic pattern. But remember also in this pattern, we also know the last one. The last triangle is the triangle 26 because we found that there were 26 triangles, which makes sense that they were asking us here for the area of the 26th triangle. Okay, so if the area of the 26th triangle is 52 units squared, so I'm going to just take that and put that at the end. Triangle 26 has an area of 52 units squared. So this is the pattern for the area of all the triangles. We just have to find out the sum of all the areas of the triangle so we can find out how much space is being covered by all these shaded triangles. Okay, so to find the sum of these shaded triangles, this is an arithmetic pattern. And the good thing about this arithmetic pattern is we can see the first term, we can also see the last term, and we know how many terms there are. There are 26 terms because there are 26 triangles. So we can use this formula instead. You can use the formula that says Sn is equal to n over 2 multiplied by a plus l. So let's use that. We're going to say the sum of 26 terms is equal to 26 over 2 multiplied by a, which is just the 2, plus our last term, which is the 26th term, is 52. You can go ahead and put this onto the calculator and let's see what we get. And so now we find that the sum, okay, of the 26 triangles, the areas of them is 702 units squared. Okay, let's actually just conclude this. This is the area of the shaded triangles. That is equal to 702 units squared. Okay, now that we have that, we have all that we need to find the unshaded part. So the unshaded part, we simply just find that by saying the area of the entire rectangle minus the area of all these triangles being summed up. So the area of the entire rectangle was that area of rectangle. That's why it's important to label everything. So area of unshaded part will be equal to the area of the rectangle, which is the 2,704 units squared, minus the area of the shaded triangles, which is the 702 units squared. So let's see what the answer will give us. Okay, just looking at this, you can see it's going to give you 2,000, and because now 700 minus 704 minus 702, that's just going to be 2,002 units squared. Okay, so that is the area of the unshaded part. So moving on to question 2, we have given the quadratic sequence and we've been given this. So we first have to determine an expression for the nth term of the pattern in the form of Tn is equal to an squared plus bn plus c. Okay, so finding the formula of this. So it's 4 marks. So this is really places that you can't score marks. So we're going to first of all find the first differences. So we can go ahead and just say 14 minus 10, that's going to give you 4. Then 10 minus 12, that's going to give you a negative 2. And then 12 minus 20, which is negative 8. Okay, so that's our first difference. Then we have to find the second difference, and we'll just say 4 minus negative 2. So it's like saying 4 minus negative 2. So that will become a plus. So it's 4 plus 2, which is 6. And then negative 2 minus negative 8. It's like saying negative 2 plus 8. And you can rewrite this as 8 minus 2, which is 6. Okay, so we have our first difference and our second constant difference. Then we take the first terms in each of these patterns, the quadratic first difference and second difference, and we're going to equate it to the following. So the second difference, we make that equal to 2a. Then first difference, we make that equal to 3a plus b. And then this one, it's a plus b plus c. Okay, so if 2a is equal to 6, then just divide both sides by 2, and so a is equal to 3. Then we have to find b now. So 3a, but I know what a is, it's 3, so 3 bracket 3 plus b is equal to negative 8. And so 3 times 3 is 9, and we have b is equal to negative 8. Since this becomes 9, take it over and becomes a negative 9. B is equal to negative 8 minus 9. Negative 8 minus 8 is negative 16, so negative 17. And then, so we have B, and now we have to find C. So A is 3, then we have B, which is, so plus B, but since this is negative 17, you can just say minus 17, plus C is equal to 20, okay? So I'm going to just say C is equal to 20 and figure out what this is. 3 minus 17 is negative 14. If you take it over, it becomes positive 14. So C is equal to 34. Okay, so we have A, B, and C, and so it means that Tn is equal to 3n squared minus 17n plus 34. Okay, and that is 4 marks. Moving on to the next question. So the next question says, the first differences form an arithmetic sequence, okay, like it always does. Determine between which successive terms, so successive, they come after each other. In the quadratic sequence, the first difference will be 148. Okay, let's take on that question. Okay, so in this question, let's look at the pattern so that this can just make more sense. Okay, so let's try to understand what the question exactly, what are they asking for? So they're saying the first difference of an arithmetic sequence, the first differences, form an arithmetic sequence. So this is our arithmetic sequence. And they ask us to determine between which two successive or terms that come after each other, which two terms that come after each other in the quadratic sequence will there be a first difference, okay, of 148. So in this arithmetic pattern, where do we want to find out between which two terms in the quadratic pattern will you have a first difference of 148. Okay, so to understand this, first find out which term exactly in the arithmetic pattern is equal to 148. And when we find that, we'll be able to figure out between which two terms in the quadratic pattern this is speaking about. So to find out which term in this arithmetic pattern will have the value of 148, we need to find the Tn formula of this. Okay, so actually we don't really need to find the Tn formula, we just need the general formula of it, which is Tn is equal to A plus n minus 1 times D. So Tn is equal to, our first term is the negative 8 plus n minus 1, and our D, our constant difference, is the 6. So we have to find out which term belongs to this 148, first of all, in the arithmetic pattern. So to find out that, in place of Tn, we're going to put 148 is equal to negative 8 plus the n minus 1 and then times 6. Okay. And so here, what we can do is just take the negative 8 over instead. So we have 148 plus 8, so 148 plus 8, that will give you 156. 156 is equal to, and now because these two have been multiplied, I'm just going to put the 6 in front, then n minus 1. Okay, we want to find n, so we can just get rid of the 6 by dividing both sides of the equation by 6. Okay, so what is this 156 divided by 6? It's 26. So that gives us 26 is equal to n minus 1. And if you take the negative 1 over, you get 27 being equal to n. So it means in the arithmetic pattern, this is the 27th term. This is T27. This is not the question. The question is, between which two terms in the quadratic pattern would this belong to? So if we know in the arithmetic pattern is the 27th term, then to find out which two terms in the quadratic pattern, you could think about it in this direction. So T2 in the arithmetic pattern, which is equal to negative 2, is found between these two terms in the quadratic pattern. And these two terms, as you can see, this is the second and the third term in the quadratic pattern. So if this is T2 and T3, And another example of this, we can also just look at this one over here. This is term 3 of the arithmetic pattern, and it is found between term 3 of the quadratic pattern and term 4 of the quadratic pattern. So it means that term 27 must be found between term 27 of the quadratic pattern and term 28 of the quadratic pattern. So that's what they're just doing there. So that is your answer. You need to answer them in terms of the quadratic pattern. See? So the successive terms in the quadratic sequence. So our final answer, we have to tell them this is in term, or this will be found between, depending on how they ask, between which two successive. So you can say between term 27 and term 28. Moving on to the next question. Okay, so the next question, 2.1.3. Determine the smallest value of n for which Sn is greater than 10,140 in the arithmetic sequence. Okay, so in that first difference of this pattern. So we're only using the arithmetic sequence in this case. So this part, -8, -2, and 4. So I'm going to put that down. We have -8, -2, and 4. This is our arithmetic sequence. Now we have to find this Sn of this, the sum of the terms. And when we're trying to find the sum of the terms, just focus on the things that you would need. When we're speaking about sum of terms in an arithmetic pattern, there's two formulas you can use. You can either use this first one. Now, in this one, you need to know that last term. Or you could use this second formula. So, deciding which one we should use is based on what we have. So, because we don't know what the last term is, we have to use this one. So we have to find out where the sum of these terms are greater than 10,140. So in place of Sn, I'm just going to put this formula. Okay, so now that we have this, and we have to say that this is greater than this 10,140. So since we have this formula, you can see the things we need. We obviously cannot find n right now. We need to solve for n for this inequality. But we have to have a and we have to have d. So let's see what a is. A is the first term, which is 8. So we can see that. And d, remember we knew what d was already. It's the constant difference, which is 6. So we can go ahead and just fill in. So we just have n over 2 and then 2a. So 2 brackets, we're going to put in -8 as our a. And then we're going to have plus the n minus 1. Again, we don't know n. And then in place of d, that is 6. Okay. And that needs to be greater than 10,140. Okay, so this is just algebra, just solving this part so that we can get to our final answer. So with this inequality, we can start with this bracket. Multiply these first. So we're going to have the n over 2 and then open a bracket. This is going to become -16. Then this, I'm going to multiply it like this. The 6 is multiplying to the n, and the 6 is also multiplying to the -1. So we have a plus 6n and then a -6 being greater than 10,140. And then we have n over 2. And then, of course, I'm just going to write the 6n first since it's positive. This one, -16 minus 6, is going to give us -22. So -22 being greater than 10,140. Okay, then I can just multiply these into here. So I'm multiplying this into this. To multiply it easily, make this a fraction by putting it over 1. So it's just the numerator times the numerator, which would be 6n squared, denominator times denominator over 2. Then again, this multiplied by the -22, numerator times numerator, -22n over denominator. And then we can also put a denominator here over 1 because it's a whole number, then over 2. Then that is greater than 10,140. Okay, then 6n squared divided by 2, that's just going to give you a 3n squared. Then we have -22n divided by 2, which is -11n. And then we can take this over, so bringing it as negative 10,140 being greater than 0. Okay, now at this point, I will just use the quadratic formula here. So I'm going to substitute this into the quadratic formula as A, B, and C. And as you can see, when I substitute it into the formula, the quadratic formula, when I'm putting a minus first for n, right? I'm not saying n is equal to this because this is an inequality. But the first value I get is negative 169 over 3, which is definitely not your answer because it's already negative. So we cannot get that as the answer. So you can just focus on the second one. If you change that to a positive, we get 60. So n and 60. So I'm not saying n is equal to 60. We still have to solve for this. So we got our critical values. And since this is a quadratic expression or inequality, it's going to form a parabola. But you just have to remember what type of parabola it's going to form. Is it going to be concave up or down? Because n squared, okay, the coefficient of n squared is positive, it's going to be a concave up parabola. So it's going to just concave up like that. Then remember, you just need an x-axis. You don't necessarily need a y-axis. I only put a y-axis in the previous one just to explain the concept. Remember, every part of the graph that is above the x-axis, this being the x-axis, those are the parts of the graph that have y values greater than 0. And then below has y values less than 0. But remember, okay, now we have to put our x-intercept here. Here, as the first x-intercept is a negative 169 over 3, but I'm not even going to focus on that. And then the 60, I'm going to focus on that because it's a positive value. So remember, we just want the part of the graph that is greater, okay, than 0. The y values must be greater than 0. And that would be, since I'm only concentrating on the 60, I cannot take anything below here. Those are y values smaller than 0. I have to take all of that. So now line these values down to the x-axis so that you can see their relation with this number 60. So these are the values that you have. You see, these are values that are greater than 60. They're moving towards that direction. So here we are saying n is greater than 60. So I'm only focusing on that 60. I'm saying therefore n is greater than 60. But now let's go back to the question and just make sure we are answering the questions. So they said, determine the smallest value of n, okay, for which this is greater than that. Okay, so the fact that they're asking for the smallest value of n, this is what they're actually saying. And this is how you can understand these types of questions that they always put in. Okay, so focus on your solution. Your solution is saying that n is greater than 60. Remember, these are patterns, so we are taking things like the first term, the second term, not really the 5.2 term. So we're going to be looking at integer values or whole numbers. But for this solution, since they said n needs to be greater than 60, let's think about n values. Let's think about answers that are greater than 60. So our solution, or the things that would work for this inequality, is things like this, where n is, it has to be greater than 60. So where n is 61, where n is equal to 62, where n is equal to 63. Remember, I'm only showing you this so that you can understand what they mean by the smallest value of n. So if they want, what is the smallest value of n? Looking at all these solutions and all the things that n can also be equal to 64. These values will help you to make this expression, this over here, to be greater than 10,140. So these are all values of n. These are all the right answers for n. But remember, they want specifically the smallest value. So if these answers had to continue, which one will be the smallest value of n that will make that expression to be greater than that 10,140? The smallest solution of n that you have would be this one, where n is equal to 61. So that's how you can think about it. We're looking at all the values of n, all our answers, and we want the smallest answer. So Therefore, because they ask for the smallest value, they're not asking for an inequality, a range of answers. They're asking for one specific answer, n is equal to 61. Okay, so that is 2.1.3 done. We're moving on to the next question. So our next question, 2.2, if we have the sum of r plus b is equal to 10a, so they're already telling us what that sum is equal to, starting where r is equal to 1 and ending where r is equal to 5, we have to determine b in terms of a. Okay, so let's go ahead and find this. First of all, since it's speaking about sigma or the sum, we're going to have to use the sum formula, but we have to know what type of pattern is this. Because you have r plus b, it's already arithmetic. No guessing about that. So we can either have it as arithmetic or geometric, but we can see here in this case, it is arithmetic, except for in those other special cases where they give you some formulas where the patterns just really repeat themselves. It's just the same thing over and over. Okay, but in this one, it's clear that this is an arithmetic pattern. So we're going to be using the arithmetic formula. Remember, there are two formulas you can use. You can either use this one or you can use this one. But for this one, I would rather use this because it's easier. And in this case, we have L. We can find L. We may not have it, but we can actually find it. So let's go ahead and focus on the things we need to find since we know we are using this formula. If you're using this formula, you're going to have to find the following. First, you're going to have to find n, of course, so knowing how many terms there are, but n will be very easy to find. So we're saying n is equal to, the number of terms is equal to, you always say the top number minus the bottom number and then plus 1. Okay, you only say this because sometimes r may start, or the starting point may not be at 1. Okay, so you need to count each and every term. So in this case, it's just 5 minus 1 plus 1. And so that will cancel, and it's just equal to 5 terms. Then we have a, so we have to find a. To find the first term, just substitute that r is equal to 1. That will give you the first term. So a would be equal to, we're going to say the r plus b, but in place of r, we're going to put 1. So as our first term plus b. So this is our a. And then we have to find in this formula, the things we have to find lastly is L. So L is the last term. They told us where this pattern or the series is going to end. It's going to end where n is equal to, or r is equal to 5. So in place of r, we're going to put 5. So L would be equal to the 5 plus b. Okay, so we have everything that we need now in this. We have our n, we have our a, and our L. So let's just put this in the formula, and we know what Sn, the sum of these amount of terms, these 5 terms, it's going to be equal to your 10a. Okay, so we're saying that Sn is equal to, I'm actually just going to copy from here. So we're just using this. So S of how many terms? We have S of 5 terms. S of 5 is equal to, n is 5 over 2, and then a is this, 1 plus b. So 1 plus b plus L is 5 plus b. Because it's a plus, you don't need any brackets. So 5 plus b. And then we know that S5 is actually, or the sum of the terms. They told us here that the sum of these amount of terms gives you 10a. So we replace 10a over here. So 10a is equal to, we still have the 5, sorry, I said 1a. 10a is equal to 5 over 2. And then let's add these. So we have b plus b, which is 2b. And then 1 plus 5, which is positive 6. Also, just remember, they said you need to determine b in terms of a. So it needs to read as b is equal to something something, and a needs to be part of your answer. So that's all we're going to do. Try to make b the subject, and naturally a will just be part of what it's equal to. So let's go ahead and make b the subject. Okay, so to make b the subject, I'm actually just going to try and get rid of this. It's easier to get rid of that first. So we can go ahead and just divide both sides of the equation by 5 over 2, 5 over 2, and then we're going to get this. So this is 10. I know it's 10a, but 10a divided by 5 over 2. So 10 divided by 5 over 2. And that gives you 4. So 4 is equal to, and then these will just cancel. And then you're left with the 2b plus, 4a. I forgot about the a, plus 6. And now we just have to make b the subject. Okay, so take 6 over. We have 4a minus 6 is equal to 2b. And then divide both sides by 2. And so we can therefore say that b is equal to 4a divided by 2, that's 2a, negative 6 divided by 2, that's minus 3. And there we go, that's our answer. We have made b the subject, determined b in terms of a. Okay, next question. Okay, so that is it for question 2. Then we're going to move on to question 3. So now we're on question 3, and this is what we have been given. They say, given the following geometric sequence, and we have 24 over x plus 12 plus 6x plus 3x squared plus, and it keeps on going. It's actually a series, by the way. 3.1 says, calculate the sum to infinity of the series. So to find the sum to infinity, the formula of sum to infinity is basically a over 1 minus r. So just looking at the formula, we can already see the things that we will need for this. We can see that a is missing, so we're going to need a. We're also going to need r. So you just have to find a and r. Okay, so a is quite simple. A is always just the first term in the series, which is the 24 over x. So we know that a is 24 over the x. And then r, to find r, you can basically just say the second term divided by the first term, or you could say the third term divided by the second term. And that's what I'm going to do because that looks much more simpler than working with fractions like that. So I'm saying the second term, 6x divided by 12. So 6x divided by 12, and this is what we have. Then we just have to simplify this. 6 and 12 have 6 in common. So 6 will cancel on top. 6 will cancel on the bottom, and on the bottom you'll be left with a 2. So our r is really just, we have the x on the top over the 2 on the denominator. So we have a as that and r as that. So let's find the sum to infinity. The sum to infinity is equal to a, which is 24 over x, over 1 minus our r, which is x over 2. So immediately you have it like this. It won't be so nice to work with it like this. What you can do is just split it up by writing this. We're just going to write that 24 over x. And instead of using that, we're going to just use the division. So divided by this 1 minus x over 2. Okay, so let's sort this part out. So we still have the 24 over x being divided by the 1. Since we have to subtract it by this, when you have to subtract or add, your denominators need to be the same. So I can just call the 1 2 over 2 instead. That will still be 1, but the denominator is now the same as that. Minus x over 2. And then we have the 24 over x, and then divided by, I don't need the brackets anymore. I'm going to keep the denominator the same, and the numerator is now 2 minus x. Okay, so when you're dividing, there's a rule called tip and times, where you tip the second number and you change the division to a times, to a multiplication sign. So I'm going to do that. That's 24 over x, and then that becomes multiplied by, and this now tips over. Now we have a 2 over 2 minus x. And then we're going to multiply the numerators and the denominators. So 24 times 2, that is 48, over, and we have the x being multiplied by 2 minus x. So finally, the sum to infinity, we just have the 48 over, the x is going to multiply. So we have that multiplying, and we get 2x, and that multiplying, and we get negative x squared. Okay, so that's our sum to infinity. The series itself had x's in it. So of course, your sum to infinity will also be in terms of x. Okay, moving on to the next question. The next question says 3.2, write down the values of x for which the series converges. I keep saying series because it's not a sequence. Series converges. Okay, so for the series to converge. Okay, so the values for which the series converges. So we know that if a series has to converge, it's going to converge as long as r is greater than -1 but smaller than 1. And really, this just means that when a series or geometric series converges, it really just moves closer and closer to a specific value. When you look at the terms that come after, you will notice that these terms are getting closer and closer to a specific value. And in the case of a geometric series, the terms will basically move closer and closer to the number 0. You're going to start noticing that about these terms. Okay, but this is all we need to know to be able to answer this question. Okay, so what is the value of r that we had? If you scroll up, remember we had this as r, x over 2. So I'm just going to put that in here. I'm saying now that x over 2 needs to just be greater than -1, but smaller than 1. And this is an inequality, we just have to solve for x. Since we have to solve for x, we have to get rid of what is disturbing us from solving for x. And in this case, it's this divided by 2. So to get rid of a divided by 2, you're going to have to multiply by 2. But because this is an inequality that has two sides, we're going to multiply by 2 on both sides. So we're saying times 2 and times 2. So we're multiplying by 2 on both sides, and that will get rid of this 2 now. So we just have in the middle an x in the middle. Then we have that x is greater than 2 times -1, which is -2, but less than 1 times 2, which is 2. So that's our answer. This will be the values for which this series, this geometric series, will converge, meaning each term, we're looking at the terms, these terms that follow, all of these terms are going to be getting, so the next term is going to be closer to the number 0. Next term will even get even closer to the number 0, and it's going to keep on happening like that. Okay, so let's move on to the next question now. The next question, 3.3, for which values of x will the series increase? Okay, so for this question, most of the time in maths, and you will notice this throughout maths, the previous question usually has a lot to do with the next question. So notice that when that pattern converges, it's going to get closer and closer to 0. When a pattern is getting closer and closer to 0, it doesn't necessarily mean that it's decreasing. And the reason I'm saying so is because we could have the number 0 here, and let's just look at a pattern. It's not going to be geometric, but I'm just showing you a pattern. A pattern moving closer and closer to 0 doesn't necessarily mean that it's decreasing, because you could have situation like this. Let's say you had -4, -3, -2, this is moving towards 0, but it's increasing. Okay, so that's what I just meant by that. Now, to answer this question, for which values will it increase? You're going to have to look at this. You're going to have to look at these parameters for which it's going to converge and see what is this actually doing to the pattern. So this is the pattern. Let me actually just write down the pattern that we have. So this is the pattern that we have. These are the values for which it's going to converge. Notice that we have where x is greater than -2, right? So let's look for values greater than -2 but smaller than 2. So in this, I don't want to use a lot of numbers. Remember, I'm only doing this just so that it can make sense and you understand what was actually going on here. So for something greater than -2, we can try -1, right? And for something smaller than 2, let's try 1. So I just want to show you what's going to happen, because when x is negative, you're going to see it's going to do something to the pattern, and you're going to just notice how this pattern acts. So let's substitute -1 into this and see what we get. So I'm going to just substitute -1. You can also do that on your calculator, and I'm going to show you what we have here. So I've substituted -1, and these are now the answers that I get from this. So if you look at the values that you get, you will notice these numbers: -24, +12, -6, +3. They are alternating between negative and positive numbers. So when I look at this pattern, I can't really say it's increasing or decreasing. It's neither increasing nor decreasing. And that's of course because of the negative. Now, see what happens when we try 1 instead. So the reason I'm trying to let you see why we're going to focus on this part. So when I substitute 1, you see what this pattern is now doing. This pattern is getting smaller and smaller. It's decreasing. Okay. So you see now that if this case, when x is smaller than 2, then the pattern starts to decrease. So if you think about how will x increase if x decreased for where x was smaller than 2. Okay, I'm not considering negatives because the negatives make it just alternate. When x was smaller than 2, it made it decrease. So it means that to make it increase, you just need to make x greater than 2. Okay, so if you put this answer, you probably still get it right. Another way of looking at this was through the ratio, the constant ratio. We know that when a geometric, specifically a geometric series, converges, what it does is that it moves closer and closer to 0. And so in this case, we will also consider this one, the one where when r is smaller than 1, that pattern is actually going to start decreasing. And so to make this particular series increase, you just basically have to make r to instead be greater than 1. And then, of course, substitute the value of r, which was x over 2, and make that greater than 1. Then, to solve for x, you would have to get rid of this 2 by multiplying both hand sides by 2. And so that will give you that x needs to be greater than 2. You can therefore say that it's going to increase when x is greater than 2. And of course, this is because you saw that it was decreasing for where x was less than 2. Okay, so that is question 3.3, and then we're moving on now to 3.4. And now we have 3.4. If x is equal to 4, determine the sum of the sequence to 15 terms. Okay, so this is just determine the sum of the sequence to 15 terms. So as you can see now, because they're saying that in the previous question, x is now greater than 2, and of course 4 is greater than 2. Notice now that this series does not converge anymore. It's now diverging. Okay, but to find the sum to 15 terms, we're just basically going to have to use the sum formula. So now when using the sum formula, you know that in the sum formula, you need to know what n is, the number of terms, and they already told us that was 15. We also need to know what a is, so we're just going to take our a and substitute 4 back into that. So the value of a before was the 24 over x. That was the first term that we had. So we can go ahead and just put that 24 over, but instead of x, we're going to put 24 over 4 because we know what x is now. So 24 divided by 4, a is just going to be equal to 6. And then lastly, to find the sum, we need the ratio, we need r. So r is going to be equal to, let's just find out what the ratio was before. The ratio was x over 2, and we know what x is now. So since the ratio was x over 2, and we know x is 4, this is just 4 over 2, which is equal to 2. So we know what our ratio is. Okay, so our ratio is 2, and you know, there's a formula that you use when r is greater than 1. So I'm going to use the formula Sn is equal to a bracket r to the power of n minus 1 over r minus 1. And so S of 15 is equal to a, which is 6, open bracket. We have now our r, which is the 2. So I'm just going to say 2 to the power of 15 minus 1 over 2 minus 1. And then you can go ahead and just put that onto the calculator and see what you get. And so when we substitute that, we get 196,602. So that is the final answer. Okay, and that's it for 3.4. And that is it also for question 3. Okay, now we move on to question 2, and question 2 says, in 2.1 we have the first term of a geometric series is 14 and the sixth term is 448. We have to calculate the value of the constant ratio. Okay, so look at the information they've given us. They gave us the first term and they gave us the sixth term. Okay, whenever they give you the first term, and it is a geometric or an arithmetic series or sequence, just note that they're trying to give you the value of a, because the first term, we call that a. So it means that the value of a in this geometric series is 14. Then they're telling us about the sixth term. So they're telling us that the sixth term, T6, is 448. And we have to use this information to find the constant ratio. Because they're giving us a term value, this implies that we're going to have to use the Tn formula to actually find the value of r. So the Tn formula of a geometric series or sequence is Tn is equal to a multiplied by r raised to the power of n minus 1. And we're just going to substitute everything we have. We have the value of a, we have T6 as well. So I'm saying term 6 is going to be equal to, and then a is 14. We have that 14 multiplied by r, which we don't have, and we're looking for that, to the power of n minus 1. So the n value is 6 because we are substituting, you see, 6 in place of n. That is term 6. So that is 6 minus 1. And then now we're going to this is going to become an equation. So what is the value of T6? The value of T6 is 448. So that is 448 is equal to, and we have 14 multiplied by r raised to the power of 5. Okay, this is all we have. We just have to solve for r. So how do we get r on its own? Well, the first thing stopping us from getting to r would be the 14. Not really the 5. The 5 is attached to the r. So we need to first get rid of the 14. So we can divide both sides by 14, seeing that 14 is being multiplied by this r. And let's see what we get. 448 divided by 14. And we get 32. So 32 is equal to r raised to the power of 5. Okay, now focus, you're just trying to find the value of r. And what is stopping us from reaching r is this 5, this to the power of 5. So to get rid of a to the power of 5, you would have to root both sides. So the fifth root of both sides, that would be the inverse of this. Okay, and so this is going to be r is equal to, what is the fifth root of 32? I think that is 2. 2. Okay, so that is 2. So there is the value of r. Okay, moving on to the next question. So 2.2, we have determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of this. Okay, so we're going to have to break down this question. They want us to determine the number of consecutive terms. So consecutive means they come right after each other. And we have to find out how many terms, so really just the number of terms that come right after each other, that must be added to the first 6 terms, okay, of the series in order to get this sum. Okay, so we're trying to find out how many terms, okay, needs to be added to the first 6 terms. We're taking the first 6 terms and we're adding a specific number of terms. We don't know how many they are. That's what we're really just trying to find out. And then the sum of everything ends up being equal to this number. Okay, because we have to actually obtain this number. So 114674. That's really what they're saying. Okay, so let's see how we can break this down. First of all, since we know that we have the sum of the first 6 terms, remember the sum of the first 6 terms is made up of term 1 plus term 2 plus term 3, of course, all the way to term 6. Then we have specific terms that are being added and they come right after each other. Okay, so because they're consecutive, we're going to have to assume that after the 6th term, we're going to have the 7th term, then the 8th term, then the 9th term. But the thing is, we don't know how many of them are added to the first 6 terms in order to get this number. So we're really saying, this is the part we're trying to find out. We have plus T7, plus T8, plus T9, all the way, and we don't really know how many those are, but then they equal this. So they equal this number, right? Okay, so really what we're just trying to find out is this part. How many terms here are added to these ones in order to find this? The good thing about this, we can actually find the first 6 terms, but let's just see if it's necessary to find it or not. Because we know how many terms, first of all, is going to be added to these unknown number of terms. So how about, and we know that they eventually all sum up to this. How about we find out in this sequence, what are the total number of terms that sum up to this number, right? Then when we find that total number of terms that sum up to this number, we're going to subtract the first 6 terms for it, and that will tell us the number of terms that must be added to the first 6 terms. Okay, so we can do that. So let's go ahead and find how many terms exactly was added in order to get this number. Okay, so what kind of pattern is, okay, it's still continuing from this. So it's still the geometric pattern, and we know the value of R. We also know the value of A, so we can use that. So we're going to use the sum formula, and as you can see, R is 2, so we're going to use this formula. So Sn is equal to A multiplied by R to the power of n minus 1 all over R minus 1. Okay, so the sum of how many terms, that's the one that we don't know. We don't know how many terms, so we're trying to find out the total amount of terms that it must be added in order to reach this amount. So S of n is equal to the value of A. We know that that's 14 and R is 2. So 14 multiplied by 2 raised to the power of, we also don't know what n is still, minus 1 all over R minus 1, which is 2 minus 1. Now the value of Sn, the sum of these terms, it's this amount, right? The total amount of terms. It's 114,674, which is equal to, and we can just go ahead and simplify this as 2 minus 1 is 1. And anything over 1 really just stays the same because it's all of this being divided by 1. So I'm just going to keep this as 14 multiplied by 2 to the power of n minus 1. Okay, so since that is like that, we can just go ahead and get rid of the 14 first of all, so that we can get closer to this 2 to the power of n. Okay, so we can divide both hand sides by 14, and let's see what we get here. So we have, and that gives us 8,191, so 8191, and then we say this is equal to, and we have 2 to the power of n minus 1. Okay, so 2 to the power of n minus 1, we can take the 1 over. That will be 8,100 and becomes a plus 1, 92, is equal to 2 to the power of n. Okay, we have a nice exponential equation. We know it's exponential because the variable is on the exponent. So we just need to make the bases the same. So 8,192 is equal to, and then shift fact. Okay, so that's 2 to the power of 13. 2 to the power of 13 is equal to 2 to the power of n. And now we can solve for n. So therefore, it means that n is actually equal to 13. Okay, so now we finally know how many terms exactly are added in total. There are 13 terms in total, but we just have to find out how many terms exactly is added to the first 6 terms in order to get this. So we're just trying to find out how many terms is added here. In order to find out how many more terms was added, we're just going to say 13 minus the 6 terms. That will tell us how many more terms was added in order to get that. So 13 minus 6, that's all we're just going to say. So if we say 13 minus 6, that is equal to 7. So it means that 7 more terms, okay, were added to the first 6 terms in order to get that number. Okay, there. So 7 more terms were added to those first 6 terms in order to obtain that number. Okay, and that is 2.1.2. Moving on to the next question. Okay, then 2.1.3 says, if the first term of another series is this. So again, they're giving us the first term of another series, so it doesn't have anything to do with the previous one. Okay, so of the another series is equal to 448, and the 6th term is 14. Okay, so the 6th term is 14. Calculate the sum to infinity of the new series. Okay, this sounds a lot like the first question they asked us. They're giving us the first term, they're giving us a term number and its value as well, and they just want us to find the sum to infinity. Okay, if we write the sum to infinity formula down, let's look at what it looks like. It says a over 1 minus r. From this already, because we know they just want us to find the sum to infinity of this series, we know all we need is the value of a and the value of r. So it means the information they've given us is enough to find the value of a and the value of r. With a, simple, we already know that. So let me actually put this one on the side because we're not really using this part yet. Okay, so with a, they told us the value of a was 448. So we know a is equal to 448, no problem. Now we need to find r. it's the same situation. They gave us a, they gave us a term value. So we're just going to use that same method. We're using Tn is equal to a multiplied by r raised to the power of n minus 1. And they gave us T6. So T6 is equal to, again, 448 multiplied by r, which is, we don't know actually, to the power of n minus 1, which is 6 minus 1. Then term 6 is actually equal to 14. So 14 is equal to, we have 448 multiplied by r raised to the power of 5. This looks familiar. Okay, so I find it interesting that in the other one, a was 14 and the term value was this. Okay, but we're still getting somewhere, so we can go ahead and just continue. This is for 3 marks though. Okay, then we divide both sides by 448, and now we get 14 over 448. What does that give us? So 14 over 448 is, okay, I'll put it as a fraction, 1 over 32. So that is 1 over 32, and this is equal to r to the power of 5. Okay, so we just have to make the bases the same. Just remember with these, no, we don't have to make the bases the same. We just have to solve for r. We need to get rid of the 5. So to get to the r, let's get rid of the 5 by fifth rooting both sides, fifth root and the fifth root. And this is just going to be r is equal to, because we know the fifth root of 32 is 2, so the fifth root of 1 over 32 must be 1 over 2. Okay, so that is r. So it actually does have a lot to do with the first one. This is like a reverse of the first one. The first series was kind of increasing. Yes, it was increasing because r was 2. So every time each term kept multiplying by 2, right? But with this one, it's like they just went backwards. So now each term is now multiplying by a half, or in other words, dividing by 2. And I guess somebody would have been able to see that and wouldn't need all of these calculations, because now that I look at it, it seems quite unnecessary, seeing that the first term here was 14 and then the sixth term was this. Okay, so if the first term, we were just supposed to reverse it, but it's okay. We already went through the trouble of finding the answer. Okay, so this is really what I mean. In the previous one, the first term was 14, the sixth term was 448. And we were multiplying by 2 on each term. Okay, that was the ratio, 2. That's why it was increasing. But now in this current one, the first term is 448, the last term is 14. So this just shows that we're doing the reverse. Because when we started here, we're ending here. But now since r here was 2, here r would be a half. Okay, so here it was doubling it, now it's halving it. So you could have found r easily like that without all of this calculation. Okay, but anyways, we just have to find the sum to infinity, and now we can just use that formula. So the sum to infinity is equal to, the a value here is 448 over 1 minus the r value is a half, and let's just see what this gives us. Remember, 1 minus our half is a half. So this is the same thing as saying 448 divided by a half. So I'm just going to say that 448 divided by a half is equal to 896. Okay, so 896. Okay, moving on to the next question. The second thing I want us to look at is this. Before starting to expand and all of that, let's just figure out what type of pattern this is, okay? First of all, if you looked at it straight away, what type of pattern would you think it is? Okay, it is not geometric. It's actually arithmetic. You have to think about it like this. With geometric, you're always going to have an exponent that is a variable. Okay, an exponent of like p, for example, or r. But here we don't have any exponent. We just have this. So this definitely cannot be geometric. And the reason it is arithmetic is because arithmetic equations, they will either look like this, for example. But if you simplify this type of equation, you could end up with something like this. See, if we say 2 and then we multiply that in, that's going to be positive 3n minus 3. Which is really 3n, and then if we say 2 minus 3, you get minus 1. You see how this looks? This is a simplified version of what this one would have looked like. So it's not always going to look like this. But when it looks like this, you just need to know what is going on here. Remember, here, this was in the form of a plus n minus 1 times d, meaning 3 was d. As you can see, d is here. The difference is always going to be next to n. Okay, it's going to be the coefficient of n when it is put in its simplified form. So this is in the form of dn plus c. So this already tells us the value of d, first of all. So now looking at this, what type of equation is that? What kind of pattern does this belong to? That would be arithmetic, okay? Because it's in the form of dn plus c. Here's a number, here's a variable, here's d right in front of the p, okay? Which is the coefficient of it. So now we already know from this that the difference here is 1 over 3. Okay, so I'm only trying to focus on what you need to find so that you just don't go and expand and waste time in it, but you don't have to do all of that. Okay, so focusing on the things that we need. We know that we're going to use the sum formula because this is the sigma. This is sigma. So we're going to be using, we can say Sn is equal to, now we have d. So you can just go ahead and use the formula, the arithmetic sum formula that has d. So that's n over 2, open bracket 2a plus n minus 1, and then times d. From this, you would see that the only things you need is, first of all, you need a, you need d. So let's go ahead and find a. A would just be your first term. But here you need to be careful. First term doesn't mean T1. It is T1, but it's not where you substitute in place of P1. You substitute in place of P0 because this is where this sum says it is starting from. So we're going to do that to find term 1. So term 1, or our a value, we would just go ahead and say 1 over 3 multiplied by our starting point is 0. So 0 in place of P plus 1 over 6. Okay, so as you can see, that will become 0. Our a value is just 1 over 6. So there we have a. We know what d is. D is 1 over 3 as the difference. And we also, well, we don't know how many terms must be added yet. Okay, but we do know the sum of it. So we have Sn. We have Sn. And we just have to find n. Okay, so Sn is 20 and 1 over 6, which we can, of course, put as an improper fraction, which is, you can't do that on the calculator, but 20 times 6 is 120, plus 1 is 121 over 6. So we can also just do this as well. Okay, so now we're actually ready to find that we have a, we have d, and we have Sn. So we need to find n. Now, there is a reason I left this here. N, right, in the sum formula will always stand for the number of terms. Remember the story I just gave here with you have to actually check where it starts and where it ends. We know where it starts, where p is equal to 0, okay? And it ends at k. So please be careful. K, whatever the value of k is not the number of terms, okay? That's just where it ends. That doesn't tell you how many terms they are. Just like here, 5 is not the number of terms. It just tells us where we end because we found that there are actually 6 terms in this. Okay. But now remember, we are specifically trying to find the value of k, meaning we're not trying to find the sum of the number of terms. We're not trying to find out how many terms exactly was added in order to get this number. We're just trying to find out where this ends at k. Okay. So because of that, I'm already going to say this. The number of terms, right? This n over here. We find that by saying, we're going to say top minus bottom plus 1. Okay, which is going to be k minus 0 plus 1. So the number of terms specifically is k plus 1. It's not just k. And I'm going to keep that on the side, and that's going to be useful at the end to find the value of k. Let's just be careful. We know that this n here means the number of terms, but k is just telling us where we're ending at. Okay, so let's use the Sn formula. We know the sum of the terms is really this number. So we're saying 121 over 6 is equal to n over 2. Well, we don't know what n is, so n over 2, open bracket, 2 multiplied by a, which is 1 over 6, plus n minus 1 multiplied by 1 over 3 as D. Okay, so we're just looking for the value of n. So to find the value of n, let's go ahead and just simplify. We're just trying to make n the subject. So we can start simplifying from inside the equation there. So 121 over 6 is equal to n over 2, open bracket. So 2 multiplied by 1 over 6, you can also just use a calculator. That would be 1 over 3. And then plus, we could just FOIL out, I guess. So we can just multiply that in. So plus 1 over 3n minus 1 over 3. And now we have inside this 1 over 3 and 1 over 3 would cancel. And you're left with 121 over 6 is equal to n over 2 being multiplied by 1 over 3n. Okay, so 1 over 3n can be rewritten as n over 3. And this is the reason why, because 1 over 3 and n is next to each other. When things are next to each other, they're being multiplied by each other. So since they're being multiplied by each other, this n is on the numerator. Its denominator is 1. It's like multiply the numerators, which would give you n, 1 times n, and 3 times 1, which would give you 3. So it's n over 3. So I'm just going to rewrite that as n over 3 instead. And now when we multiply here, the numerator will multiply by the numerator and the denominator times the denominator. So I just have 121 over 6 is equal to, that would be n squared over 6. And now we just have to solve for n. Okay, so n squared. Now, whenever the denominators are the same, they're equivalent fractions, you can drop the denominators. The reason we drop the denominators, it's really like you're getting rid of the 6 by multiplying both sides by 6. And so that cancels. And now we just have 121 is equal to n squared. And we can solve for n by square rooting both sides. But this is, of course, going to be the plus minus. But this is n, so it's always going to be positive. So n is equal to positive or negative 11. But obviously, n would be equal to just positive 11. So we found the value of n. Now remember, n is the number of terms in the series. It's not the value of k. It's just the amount of terms, like with this explanation here. Okay, n tells you how many terms there are. We found out that there were 6 terms here, not 5. Okay, so you have to think about it like this. Because we started at 0, k would not be 11. It would be 1 less term. Like I explained here, I said n is going to be the total number of terms. We will find that by saying k plus 1. Okay, top minus bottom plus 1. So if you use that, you'll be able to find out exactly what k is. Okay, so that's going to be n is equal to k plus 1, which is really just, we know n is 11, which is k plus 1. And we're taking the 1 over 11 minus 1 is equal to k. So it means that k is equal to 10. Okay, so that's what I meant by k is going to be 1 less term, because that is what we are ending. But the total number of terms, okay, would be 1 more than whatever k is. Like here, total number of terms is 6, but we are ending at 5. So just be careful with that. Remember what everything stands for. This is where you start, this is where you end. You know how to find how many terms there are now. And know that the number of terms, okay, in that SN formula, that's what the n here stands for. Okay, so that is it for question 2. And then we will move on to question 3. Okay, so now we're on question 3, and this is what question 3 says. It says, it is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9, and the first term of the first difference is 7. We need to show that b is equal to 4. Okay, so to show that b is equal to 4, first of all, what can really always help you with quadratic patterns is to expand this quadratic pattern just so that you can see what you have. So quadratic patterns, first of all, you would have the quadratic pattern in the first row. Now let's see what they gave us about that quadratic pattern. Now, if you notice, we don't even have the first term of the quadratic pattern. We only have this. Okay, so they only told us the value of clearly a and the value of c, because remember the quadratic pattern is in the form of Tn is equal to an squared plus bn plus c, right? So it means that they gave us the value of a. So a is equal to that invisible 1 that is over there. So we know what A is. A is equal to 1. So A equals 1. Now, the quadratic pattern is supposed to look like this. You're supposed to have your quadratic pattern where you have your first term, your second term, your third term, and so on. Then, if you set the second term minus the first term in the quadratic pattern, you end up with the first term of your first differences, okay? So let me actually write these over here. So that's your quadratic pattern. And then if you said the third term minus the second term in the quadratic pattern, you'd end up with the second term of the first differences. So this would be your first differences that you have over here. So looking carefully at what they just said, they gave us the formula, but it's incomplete because B is not there, and the first term of the first differences. So we have the first term of the first differences, which is this over here. We know that this is 7. Okay, and then of course we don't really know what the constant difference is. Okay, so let's see how we can use this to find out the value of B. So we have A, and we're looking for B. Well, a formula that includes A and B, that's what you're going to have to try and think about. A formula that would include A and B would be that formula over here when you start equating, okay, each row to the certain things they're supposed to be equated to. Like the second difference is supposed to be equal to 2A. This, okay, the first term in that first difference is supposed to be equal to 3A plus B. And this is perfect because you see, we have the value of A, we're looking for B, and we have a number. This is an equation. So we're going to use this in order to find the value of B. So we're going to say, therefore, it means that 3A, when we know that A is 1, 3 times 1, plus B is equal to 7. And so that is just 3. 3 times 1 is 3. So we have 3 plus B is equal to 7. So B is equal to 7. And we're going to take that 3 over and becomes minus 3. And so therefore B is equal to 4. Okay, so that's how we find B. We knew the value of A. We knew that this is supposed to be equal to this. And it includes A and B. And we're able to solve. So just be thinking about the quadratic formula like that. It helps you to really understand what's going on. Okay, moving on to the next question. Okay, and 3.2 says determine the value of the 60th term of this pattern, which is great. This is a way that you can really score marks. So even if you didn't know the value of B, you see, they're saying show that the value of B is 4, so you'd still be able to get these marks. So the 60th term, this would be term 60. So that just means that in place of n, you're just going to substitute 60 into your formula, your general formula. Our general formula is now Tn is equal to n squared. So Tn equals n squared. Now we know the value of B is 4. So that's plus 4n. And then, of course, that constant of plus 9 at the end. And now with this, we can just substitute 60 in place of n. So we're saying term 60, the 60th term, is equal to 60 all squared plus 4 times 60 and then plus 9. So T60 is equal to, let's just put this onto the calculator and see what we get. Okay, when we substitute 60, I get 3,849. So that is term 60. Okay, moving on to the next question. So question 3.3 says, determine the general term of the sequence of the first differences of the quadratic number pattern. Write your answer in the form of TP is equal to MP plus Q. So we just have to find the general formula, okay, of the first differences in that sequence. So the general formula, in order to find this, and this is for 3 marks. So we're going to need the first differences. We're going to need the value of D, okay, that difference. And we're just going to have to simplify it to this form, okay. So to find those first differences, well, first of all, we have 7. We already have the first term. We can just find the second and the third term. To find those terms, though, we're going to have to use this top, okay? So if we can find the first term, the second term, okay, we don't really need the first term. We already have this, so it's okay. We just need the second term, the third term, and the fourth term. That way, we'll be able to use that to find the second and the third term of the first differences. Okay, so let's go ahead and find that. We're just going to use the formula, this formula. So if we substitute in place of n, we're going to substitute 2 because we just want to find term 2. So if we substitute 2, let's see what we get. We get 21. So I'm just going to find those ones first. So first of all, I have the 21 as term 2, of course, of that quadratic pattern. Then to find term 3, I substitute 3. And I have 30 as term 3. Okay, so I didn't know the first term, but it wasn't really necessary because I already had the first term of the first differences. So all I need here is the second term, first of all. So 30 minus 21, we're going to get 9, okay? And then I will just need like a fourth term. But it's really not necessary. With 2 terms, it's enough because you know this is already going to be a linear pattern either ways. Okay, but if we find the fourth term here in the quadratic pattern, it is 41. So if you say 41 minus 30, you're going to get 11, which is your third term in your first differences. So it means your first differences just look like this. It's just 7, 9, and 11, okay? And this keeps going. So with this, we can just go ahead and find this formula. So first of all, we're going to need the difference. The difference, you say 11 minus 9, which is 2. And if you said 9 minus 7, it's also 2. So we can see that that is constant. Okay, so we have this now. Okay, so now that we have that, I can say that the difference is 2. And we can just now find the formula. So the formula of the first difference is, remember, this is an arithmetic pattern. The first difference is an arithmetic pattern. So we have Tn is equal to A plus n minus 1, okay, multiplied by D. So this is going to be, in order to find the formula, I'm going to say Tn is equal to, I need A, which is 7, plus n minus 1 times 2. Then let's just simplify this so that it can be in this format. Because you see, they're being specific. They want it to look simplified like that. So we're going to say Tn is equal to 7, and then we're multiplying this 2 into this bracket. So it's the 2 multiplied by the 2n and the 2 multiplied by the negative 2. But I'm just going to start with the negative 2 because I want the numbers to be together. So if we multiply, we're going to get 2 multiplied by 2n is positive 2n, and 2 times negative 1 is negative 2. So this is Tn is equal to, I'll just put the 2n first so that it is in this format. And then we have 7 minus 2, which is equal to positive 5. Okay, so this is our formula. But then, of course, they do want you to write it like this. So I'm just going to say that Tp is equal to 2p plus 5. Okay, so that's what they want. And that is it. So we know the value of m and we know the value of q. Okay, moving on to the next question. Okay, and now we're on the last question. 3.4 says, which 2 consecutive terms in the quadratic number pattern have a first difference of 157? This question keeps showing up. Okay, it shows up in different ways. So you need to remember how these things work. Okay, they just want to know which 2 consecutive terms. Okay, so 2 terms that come right after each other, consecutive. In the quadratic number pattern, okay, so in that quadratic pattern, have a first difference of this. For you to understand that question, try to use a simpler example. And this is what I mean. So you see, we already have this. We already know what our pattern looks like. I'm going to just take this as it is and put it down there just so that we have this. Okay, so if we have this, we don't have the first term, of course, but it's not really necessary. You can find it if you want to. Now, if we have this and we know the constant difference is 2, this is really what they're saying. They're asking which 2 terms that come right after each other in the quadratic number pattern. Okay, so which terms in this pattern will have a first difference of this? If I try to make this question look simpler, just using what we have here, I could ask you which 2 terms, okay, in this quadratic number pattern have a first difference of 11. Then you would tell me, oh, that is term 3 and term 4, because of course we have a term over here. That's term 1. Okay, so that will be term 3 and term 4. So if I also asked which 2 consecutive terms in the quadratic number pattern have a first difference of 9, you would say term 2 and term 3. So I want you to see the pattern that is going on. The two terms, okay, the two consecutive terms that will have a specific first difference. You saw that in this case, right? It was term 2 and term 3. But in the first difference, that first difference of 9, okay, that is the second term in the first difference. Now the two terms in the quadratic pattern would be the second and the third term. Likewise with this one, I asked which two consecutive terms in the quadratic pattern would have a first difference of 11. You can see that 11, that first difference, is the third term in the first difference. Therefore, this means that the two consecutive terms in the quadratic pattern would be the third term and the fourth term. You see, it's the current term that you're on and then the next term. That's how it's going to work all the time. Okay, so if this is T3 over here in this first difference, the two consecutive terms in the quadratic would be the third term and the fourth term. So all we have to do here is find out which term exactly in the first difference belongs to that specific number they're speaking about. So if we look up here, we see that they ask which two consecutive terms, okay, in that quadratic pattern has a first difference of 157. So let's go to the first difference and find out which term exactly has a value of 157. Okay, so we'll be finding out that. Then we'll be able to find out which two consecutive terms in the quadratic. So to find out which term has this value, we're going to take the Tn formula or the TP formula of this pattern, and we're going to make it equal to this because we're trying to find out exactly which term that is. Okay, so we're saying the value of the term is 157, and we're making this equal to 2p plus 5. Okay, so that we can find its term number. It's the same thing as Tn is equal to 157. Okay, because you're trying to find out what the n value is. What is the term value belonging to this number? Okay, so let's go ahead and just solve for p. You can take 5 over, that will become a minus 5. 157 minus 5 will be 152 is equal to this 2p. Then we can divide both sides of the equation by 2. And so 152 divided by 2. So 50 divided by 2. You can just use a calculator though. Okay, so 100 divided by 250, 20, that's going to be 25 plus 1. So that is 76. Okay, so P is equal to 76. P equals 76, right? So it means that the term here in the first difference, it's the 76th term, 76. So the two terms in the quadratic pattern that's going to have this first difference, okay, of that 157 would be the 76th term and the 77th term. So I want you to always see how that works. So you can answer them by saying, therefore, it will be, you can just read the way the question was asked. They asked which two consecutive terms will have this. Okay, so you can say the 76th and the 77th term. And there we go. So that is the final answer for question 3. And we're done with question 3. Okay, so now we're on question 2. So question 2.1 says, given the geometric series, and we have 1 over 5 plus 1 over 15 plus 1 over 45, and this keeps going. 2.1.1 says, is this a convergent geometric series? And you have to justify your answer with the necessary calculations. So for a series to converge, a geometric series to converge, you need to show that the ratio, the common ratio, is greater than -1 but smaller than 1. So the next thing to do is just to find that common ratio. To find the common ratio, you can just say term 2 divided by term 1 or term 3 divided by term 2. So in this case, term 2 is 1 over 15. I'm going to divide this by 1 over 5. And you see that gives us 1 over 3. So if our ratio is 1 over 3, then truly 1 over 3 is a number that is greater than -1 but smaller than 1. And so therefore this series is convergent. Okay, so we can just conclude that. So that is 2.1.1, and we can move on to the next question. So 2.1.2, they want you to calculate the sum to infinity of the series. Okay, so since the series does converge, you can calculate its sum to infinity. So the sum to infinity formula is just the sum to infinity is equal to a over 1 minus r. Okay, so we're going to go ahead and find a. The a is just our first term, which is 1 over 5. So it just means this is 1 over 5 being divided by 1 minus our constant ratio is 1 over 3. So this is really just 1 over 5 and then divided by 1 minus 1 over 3. That you can see that as like 3 over 3 minus 1 over 3, which is going to be, so if you think about it like 3 over 3, 3 minus 1 is 2 over the denominator stays the same because we're subtracting. So what is 1 over 5 divided by 2 over 3? That gives us 3 over 10. So the answer is just 3 over 10. That is the sum to infinity. So when you sum up the infinite amount of terms that we have in this series, the final answer, it will sum up to 3 over 10. Okay, so we move on to the next question. Okay, and then 2.2, we have an arithmetic and a geometric sequence are combined to form the pattern, which is given by Pn is equal to, so we have x, then 1 over 3, then 2x, then 1 over 9, then 3x, then 1 over 27. Okay, so it's just a combined arithmetic and geometric sequence. The first question is for you to write down the next two terms of the pattern. So of this pattern, okay, since it's alternating between arithmetic and geometric, we're just going to look at it like this. Since this was 3x, notice it keeps increasing by x. That's what the arithmetic pattern keeps doing. We have x, then 2x, then 3x. So it means the next term after this, we will have an arithmetic here, which will be 4x. So we're going to have 4x, and then after that, we're going to have, so we have 1 over 3, then we have 1 over 9, then 1 over 27. So we have x next. Then the geometric that will come after this, notice that these terms, look at the denominators. They will be multiplied, the denominators are being multiplied by 3. So it means that each term is being multiplied by 1 over 3. That would be your ratio. So 1 over 3 then times 1 over 3 will be 1 over 9 times 3. 1 over 3 will be 1 over 27. Then if you say 1 over 27 times 1 over 3, we're going to have 1 over 81. Okay, so we have 1 over 81. That would be the next two terms in this pattern. Okay, then 2.2.2 says, determine the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. Okay, so the odd terms. So by odd terms, they probably mean like this is term 1, but it's actually going to be in terms of p. So we're looking at this as this one is p1, and then this one would be p2. Let me actually just write this out. So we have p1, and this is P2 and P3, P4, and this keeps going with P5 and P6. So by them saying odd terms, they're probably referring to the terms with term numbers that are odd, like 1 is a odd number and 3 is an odd number and 5 is an odd number. And I think what really makes us know that that's definitely what they mean is because they say write down your answers in terms of x. So notice that the odd terms like P1 and P3 and P5, these are the terms that have x in it. That's the arithmetic pattern. So we just need a formula for the arithmetic pattern. So because these are our odd terms, this is the first term of the odd term, and then second term, and then third term. The formula for this pattern, it's actually a really simple formula, but you can find it the usual way. So because it's an arithmetic pattern, so the general formula of arithmetic patterns are Tn is equal to a plus n minus 1 d. Okay, so your first term, a, that is the x. So Tn is equal to, we have x plus n minus 1, and then our difference. So notice the difference that we have. If you say 2x minus x, you get x. 3x minus 2x, you get x or 1x. So our difference is the x. So what's going to happen here is we really just have this. We have x plus, now remember this needs to actually multiply into these two terms here. So we're saying the x times the -1, which will give you a negative x, and then with the x multiplied by that n is going to give you a positive xn. Then these two would cancel and you're just left with xn. So Tn is equal to xn. That would be the formula for the odd terms of this pattern. Okay, so that's that question. Moving on to the next question. So 2.2.3 says calculate the value of P26. So P26. So we need to find out what will the 26th term of this pattern be. Let's think about it like this. Notice that the terms with odd numbers like P1 and P3 and P5 and P7 and P9, all of those would be the arithmetic pattern of this formula. Okay, but also notice now that the even numbers, so P2 and P4 and P6, all of the even terms, okay, would be the geometric pattern. So it means that P26 is definitely in the geometric pattern. So now we just have to find out which term exactly in the geometric pattern is this, because we know that P2 in the geometric pattern is term 1 of your geometric sequence. P4 is term 2 of your geometric sequence. P6 is term 3. So let's actually just put it like this. I'm going to be calling it, so because this is P2, okay, but it is the first term of the geometric pattern, I'm going to call this G1, as in geometric pattern term 1. And then this one, P4, is our second term of our geometric sequence, okay? So I'll call that geometric sequence term 2, so G2. And I can call this one, the P6, that's going to be G3. Notice what's going on here. Where you have P2, that's your G1. Where you have P4, that's your G2. Where you have P6, that's your G3. The term number is going to be half of this term number. So if this is P6, this is G3. That would mean that if we have P26, and let me actually just put that in green, P26 would be G of whatever the half of 26 is. Because you see, they keep halving. Half of 6 is 3. Half of 4 is 2. So it means that this would be G, 26 divided by 2 is 13. So it's the geometric pattern, but the 13th term of your geometric sequence. Okay, so how do we get the 13th term of your geometric sequence? So we can just use the Tn formula for that. The Tn formula of a geometric sequence is Tn is equal to A multiplied by R to the power of n minus 1. And we want specifically this, the 13th term in the geometric pattern. And so that would be P26 of this entire pattern. Okay, so that is going to be term 13 is equal to the A value. What's the first term in your geometric sequence? The first term in the geometric sequence is 1 over 3. That's G1. So we're going to have 1 over 3 multiplied by our ratio. So you can find the ratio. Your geometric pattern is these orange ones. If you take 1 over 9 and divide it by 1 over 3, you're going to get 1 over 3. So R is 1 over 3. So to the power of n, our n value, that's the 13th term. So 13 minus 1. And so let's see what this gives us. Term 13 is equal to, and this is what it gives us. It gives us 1 over, and let me just see, 3. So this is already in 1 million. So it's 1,594,323. Okay, that is the 13th term. But remember, they want you to calculate this P26, so you must answer them like that. So because we know the 13th term in the geometric pattern G13, that's actually P26. So we can write that down. We're saying therefore P26 is equal to that 1 over 1,594,323. So that's our answer. Okay, and I'm not going to round this off because this is a term value. If you round it off, it's not going to be this fraction anymore. And if you round this off, it's going to become 0. And that term value technically is not 0. It's just so small, it looks like 0. Of course, because as you can see, the geometric pattern is converging. The ratio is 1 over 3. So each term after will just get closer and closer to 0. But because of the nature of numbers, it's never really going to become 0. It just grows infinitely smaller. Okay, so moving on to the next question. And then we have the last question in question 2.2.4. For 6 marks, they want you to do this. If sigma, we have sigma the sum from n is equal to 1 all the way to n is equal to 21 of Pn, so that pattern is equal to 33, 3. We need to determine the value of x. Okay, so the thing about this question is you need to remember that Pn, the pattern that is defined by Pn, is made up of 2 types of pattern. So we have a geometric pattern and we have an arithmetic pattern. So in order to find the entire sum of Pn, you need to separately find the sum of the geometric pattern and then the arithmetic pattern, then add it together. And it should be equal to 3.5. And that will cause an equation where you need to solve for x. Okay, so we're going to work on these 2 patterns separately. So let's find the geometric one. So that you don't beat around the bush and you don't look for things that you don't really need, what you can do is write down the formula of the sum of geometric series. Now, I know, yes, this geometric sequence, as we can see, it does converge, but they don't want you to find the sum to infinity. They want you to find the sum of it till 21, but that is of Pn. Okay, so since we need the sum of the geometric and the arithmetic, let's just do it like this. We're going to find the Sn formula of this. So it's going to be Sn is equal to a bracket 1 minus r to the power of n over 1 minus r. Okay, so using this formula, you can also use the other formula. It will work out. So you can use this formula, but I specifically like to use this formula when I see that the ratio is smaller than 1. So looking at this formula, you see the first thing we need a. And a is, of course, the first term. So we need to know what the first term is in the geometric sequence. So in the geometric sequence, and I think I'm just going to be calling this the G sequence. So in the geometric sequence, you see that the first term is 1 over 3. So in that, we have a as 1 over 3. Our ratio, we already found that was 1 over 3. If you take the next term of the G sequence and you divide it by the first term, it's going to give you 1 over 3. So that's the ratio. Constant ratio is also 1 over 3. Then we need to find n. Now, you need to remember n means the last term in your geometric sequence, because we're going to find separately the sum of the entire geometric sequence, okay, in that pattern when they say that this Pn, like the pattern combined, ends at 21 terms. So we need to find the last term in this geometric sequence. It's not 21. What is ending at 21 is the Pn pattern. So this entire pattern combined, that ends at P21. So what we can do is find out where is the geometric pattern ending and where is the arithmetic pattern ending. Okay, so since the last term that we have here, what they ask us for is 21. So that is P21. So if this is P21, let's find out what kind of pattern are we going to have here. So notice how these patterns go. P1, okay, so the ones with odd numbers, 1, 3, 5, those would be your arithmetic patterns. So let me actually just call these ones A. So this is A1, the arithmetic patterns term 1, A2, A3. Okay, so it means that P21, seeing that 21 is an odd number, it means that this is an arithmetic pattern. So this P21 would be A what? So if you try to find that out, notice what's going on here. Here, P1 is A1, P3 is A2, P5 is A3. Now the problem with this is this thing is not constant, because if you notice P5, the number that we have here, 5, it's 2 less than the one that you have here, 3. Okay, so P5 is A3. Now, for you to be able to rely on that and say, okay, so each term we're just going to have, if we have P whatever, we just take 2 terms less. Well, in order for you to rely on that, it also has to be consistent here. See, P3 is A2. That is just one term less. So we can't really rely on that. But what you can rely on, what we know is constant, is the G, okay? So P2 is G1, P4 is G2, P6 is G3. You will always notice that whatever number is here, the one that is going to be here would be half of that. So how about we find out, since this is the last term, P21, the previous term before this would have been P20. And because it's an even number, it is definitely a geometric pattern, because the geometric patterns are the ones with the even numbers P2, P4, P6. So if this is P20, this must mean that this one is G10, because it has to be half of that. That is the only one we can rely on. That keeps being constant. So we want to find out what this is. Okay, so to find out that, this is another thing we can look at. Looking at the first two terms, okay, these are both term ones of the arithmetic and the geometric pattern. So notice the pattern is saying that we first have to have an arithmetic, then a geometric. That would be the first terms, okay, of the arithmetic and geometric. Term 1 of arithmetic and term 1 of geometric. Then we have A2 and G2. Term 2 of arithmetic, term 2 of geometric. Then A3 and G3. Term 3 of the arithmetic and term 3 of the geometric. So if we have G10, then before it we should have had A10, because that's the order it keeps going in. If we want the 10th term of the both patterns, we have to first start with the arithmetic pattern and then the geometric. That's what keeps happening here. We have the arithmetic, then the geometric, and this is the third term of both patterns. Then here we would have the arithmetic and the geometric, and this is the 10th term of both of these terms. So it means that in the geometric pattern, because the geometric one, P20 is the geometric pattern's 10th term, then it means that the last term here, this one, has to be since we have A10 here, this has to be A11. So this one, the arithmetic pattern, is ending at 11 terms, but the geometric pattern is ending at 10 terms. So we know where the terms end now. Okay, so the geometric one, I'll put that n is ending at 10 terms, and the arithmetic n is ending at 11 terms. So we can go ahead and do that now. So n here of the geometric, it's ending at 10 terms, and then of the arithmetic, our n is going to be 11. So I'll just put that there as well. Okay, so now we can find the sum of this part. So remember, we're still going to add them together. Then it will form the P21 terms all up together. Okay, so I'm going to substitute this in. So we have S of 10 terms is equal to, we have 1 over 3 multiplied by 1 minus our constant ratios, 1 over 3 raised to the power of 10. And then close bracket over 1 minus, the bracket really doesn't matter, 1 over 1 over 3. Okay, so put that into your calculator and let's see what we get here. And on the calculator, we get 29,524 over 59,049. Weird number. Okay, now we got the sum of that. Now we need to find the sum of the arithmetic part. So with the arithmetic part, just also remember you also have two formulas that you can choose from. So you can either use this formula or you could use this formula. And honestly, I prefer to use this formula. It looks so much simple and we're going to use that. So with this formula, look at the things you need to have. You need to have n, which we do. We have what the value of n is. It's 11. There are 11 terms in the arithmetic pattern. Then we need to have a. Okay, so we can also find a. A is the first term in our arithmetic pattern. That is x. So we have a as x. And then we need to have L. Okay, so L, the last term in the arithmetic pattern. So let's look at what the last term will be. Remember that the terms ended at P21. And so our last term is A11. So we need to find the 11th term of this. That will not be difficult because look at the order of the way these terms are going. So in the A sequence, notice that A1 is X. In other words, 1X. So it's whatever the term number of that pattern is, of the arithmetic pattern, and then X. Then look at A2, it's 2X. So see the term number of that arithmetic pattern and then X. And then you see A3 is 3X. So it means that if this is A11, the value of this would be 11X. So 11X. Okay, so that would be the last term since they told us that it ends at P21. So we can just say that L is 11X. And now this makes this so much more easy to find. So we're going to go ahead and say we have S of 11 terms is equal to N over 2, which is 11 over 2, open bracket, and we have X as our A plus L, which is 11X. And then we're going to have S of 11 terms is equal to the 11 over 2, X plus 11X, that's going to be 12X. Okay, so this is how you can look at this to simplify this. 12X as a fraction is really 12X over 1. So it's 12X and then it's put over 1. So these are being multiplied. So if the numerator is being multiplied with the numerator and denominator with the denominator, the thing about this is you can multiply the cross like this times this and find your number, and then the denominators multiply and find your number, and then simplify it further because there will be a common factor. Or you could have done this instead. Notice that across, when you look at them across, they can cancel since they're being multiplied, okay? They're actually being multiplied. That's what brackets mean. So I'm going to cancel a 2 here. So I'm saying 2 divided by 2 is 1. And cancel a 2 here by saying 12 divided by 2, we're left with 6. So this is really just the numerators will multiply 11 times 6. That is 66. But remember we have an X. And then this is obviously a 1 left. 1 multiplied by 1 is just 1, but we don't have to put over 1. We can just leave it like this since the numerator already had a value. So it means S11 is 66X. That's what we get when we sum up 11 terms of the arithmetic pattern. Then the last thing we need to do is simply just put these together because altogether, the sum of 10 terms of the geometric pattern and the sum of 11 terms of the arithmetic pattern make up the sum of the 21 terms of this PN pattern. So we're going to add them up together and we know what it's finally equal to. It's equal to this. So we're taking the sum of the 10 terms and adding it to the sum of the 11 terms, and that will be equal to the total number here. The PN is equal to 33,5 because that was what the sum of this pattern was equal to. So that's 33,5. Okay, so we have this number and then plus the sum of 11 terms, which is the 66X. That is equal to 33.5. So this is a linear equation. We just have to solve for X. So to solve for X, to get to X, we're going to take this over. Okay, so take that over. We just have 66X is equal to whatever 33.5 minus this fraction is. Okay, so when we subtract, when we take that over, we get this really weird number. But I'm not going to write this. I'm just going to leave it like this, but I'm not going to round off. I'm saying 33,000. I know it keeps going. And then we need to divide both sides by 66 to solve for X. So I'm taking this answer and I'm dividing it by 66. So on your calculator, you can just say divide by 66. I have to say equal to first. Divided by 66. And so as you can see, this gives us X is equal to 0,5 and then 0, but if you round it off, it's going to just give you 0,5, which 0,5 as a fraction is just a half. So that is our final answer. X is equal to a half. Okay, so that was the last question in 2.2.4. It just takes a lot of concentration and really just thinking carefully. Okay, and question 2 was what? 17 marks, and we move on to question 3. Okay, so now we're on question 3, and question 3 says a quadratic sequence has the following properties. The second difference is 10. The first two terms are equal, i.e., term 1 is equal to term 2. And then term 1 plus term 2 plus term 3 is equal to 28. And so they want us to show that the general term of the sequence is this. So it means that they've given us enough information to be able to find the Tn formula. Okay, so let's just structure this info. Because they said the second difference is 10, let's go ahead and look at what this is going to look like. So remember, this is speaking about a quadratic sequence. The quadratic sequence looks like this. You first have your quadratic sequence on top. Then whatever these are like, you have term 1 here, term 2, term 3, term 4, and just keep going. Then to get the first differences, so let me just call that first differences. You're going to say term 2 minus term 1, and that will give you the first term of the first difference. Then term 3 minus term 2, that will give you the second term of the first difference. Term 4 minus term 3, third term of the first difference. Then that second difference that they're talking about, that second difference, you find that basically by saying T2 minus T1. That will give you that second difference, and it's constant, so I just call it D and D. Okay. Now, in this, we also know something else about this pattern and how it is. We also know that in these, you have to circle out the first terms in each pattern. In the quadratic pattern, the first difference and the constant difference. And we're going to equate all of these numbers, these first numbers, to the following. So it will have that 2a is equal to whatever that second difference is. Then for this one, we say 3a plus b is equal to whatever that is. And then, of course, a plus b plus c is equal to whatever that is. So from this, because we already know the second difference is 10, we can go ahead and say, okay, we know the second difference is already 10. So it means that 2a is equal to 10. And so we'll divide both sides by 2, and we find out that a is 5, just like they have here. Okay, so we have a. Okay, so to be able to find the rest of the things, let's go ahead and see what else they gave us. They said the first two terms are equal, term 1 and term 2. But right now, we don't know what the first two terms are. We don't know what T1 and T2 are. But we can actually create an equation for these two terms. So remember, the general form of a quadratic pattern is Tn is equal to an squared plus bn plus c. So it means that T1 is equal to, in place of n, I'm just going to substitute 1. Okay, so this is a bracket 1 all squared plus b bracket 1 plus c. And so we have T1 actually being equal to 1 squared is 1, 1 times a is a, and then b times 1 is b, and then we just have plus c. That's what T1 is. And because they also spoke about T2, we can also find T2. So term 2 is equal to, so in place of n, we're substituting 2. So that is a bracket 2 all squared plus b bracket 2 plus c. So term 2 is equal to, 2 squared is 4, 4 times a is 4a, and then plus b times 2 is 2b plus c. This is what we have so long for T1 and T2. But we also know what the value of a is now. The value of a is 5. We found that because of that second difference they gave us. So we can put that into here. So it means that term 1 is now equal to 5 plus b plus c. And that term 2 would be equal to 4 multiplied by 5 plus 2b plus c. And so T2 is equal to, that will give you 20 plus 2b plus c. Okay, so apart from this, they also told us that term 1 and term 2 were equal. So if these two are equal, let's go ahead and equate term 1 with term 2, those two equations. So I'm saying, but they told us term 1 is equal to term 2. So we're going to say 5 plus b plus c is equal to, and then term 2 is the 20 plus 2b plus c. So this is what we have. We have this equation. Now, in this equation, if we decide to put the variables on one side and the numbers on one side, this is what's going to happen. Because this b is just a b and we have 2b here, I'm going to take this b over. So what we have here is we have the 2b minus b, and we have the plus c for that one. And I'm going to take this c over, and that gives you a minus c. So the numbers that we will have here, we just have a 5, and then here we had a 20. We can take it over, it becomes minus 20. 5 minus 20 is negative 15, is equal to 2b minus b, that's just b. And you can see that the c minus c would cancel. So that's one thing that we can already see from here. If you ever see positive c and positive c, you can just cancel it out on both sides. So you see, now we have b. So b is found. Okay, since we have b now, how about we just substitute this b into t1 and t2 so that we can also just have that in a more simplified form. So term 1 is equal to 5 plus, and then you have the b, but because b is negative 15, I'll just say 5 minus 15, and then we have plus c. Okay, so this is going to be term 1 is equal to 5 minus 15, negative 10 plus c. That's what term 1 is. And then term 2 is going to be, so term 2 is this 20 plus 2b. When in place of b, we're going to put in negative 15 and then plus c. Okay, so this is going to give us t2 being equal to 20, 2 times negative 15, that is negative 30. And then we have plus c. So term 2 is equal to 20 minus 30, that is negative 10, plus c. Notice they're the exact same thing, and that makes sense because they said that t1 was equal to t2. Okay, so the whole point of this is we need to find c. Just looking at these two, if you equate them, unfortunately, they're not going to help you find c because they're the exact same thing. I know they did say that t1 is equal to t2, but even if you did this, it will not find c. You see, it's exactly the same thing because they have the same term value. And that's probably why they gave us that third information. The third information was this, that t1 plus t2 plus t3 is equal to 28. So let's use that instead. We know that t1 plus t2 plus t3 is equal to 28. We have an equation for t1, we have one for t2, we don't have one for t3. So we can start off by finding an equation for term 3, just like we did with term 1 as well. So we're taking the general form of the quadratic sequences formula, and we're going to substitute in place of that, in place of n, we're going to substitute 3. So we're going to say term 3 is equal to a bracket 3 all squared plus b bracket 3 plus c. And so term 3 is going to be equal to, that's going to give you 9 times a, which is 9a. And then that's going to give you 3b, and that's going to give you plus c. But we know what a is, and we also know what b is. So we can just substitute in place of a and b. The value of a is 5. The value of b is negative 15. So that means that we have t3 being equal to 9. In place of a, we have 5 plus 3. In place of b, we have negative 15 plus c. Okay, so t3 is equal to 9 times 5, that's 45. And then we have negative 45 as well, plus c. Okay, so in this case, term 3 is equal to 45 minus 45, which will cancel, and then you're just left with c. Okay, so term 3 is c. So now let's go ahead and use this equation they gave us, that third equation, or the third information. They said term 1 plus term 2 plus term 3 should be equal to 28. Term 1, the value of term 1 is this negative 10 plus c. So negative 10 plus c. Then we're adding that to plus, and we have negative 10 plus c. But because we have a negative 10 there, I'm not going to say plus. Minus 10 plus c as well. Just see it like this. It's kind of because even if you had to say plus and you put brackets because you're adding by something that has more than one term, if you multiply it in, you would still have a negative 10, you'd still have a positive c. So the plus doesn't really affect it. You only put brackets when you're subtracting. So that's all we have here. Then plus term 3. Term 3 is just c. So plus c is equal to 28. Okay, so we have negative 10 minus 10, which will give us a negative 20. Then we also have a positive c plus c, and then plus another c, which will give us plus 3c. And that is equal to 28. So let's just make c the subject. So 3c is equal to, we have 28, and we're going to take this negative 20 over and becomes a positive 20. So 3c is equal to 28 plus 20, which is 48. And if we say 48 and then divide both sides by 3, so 48 divided by 3, that is 16. So c is equal to 16. And there we go. We got A, B, and C. Okay, and there C is also positive 16. So that is the general formula. So you can go ahead and just simplify this and just write, therefore, Tn is equal to 5n squared and then plus Bn, but B is negative 15. So we have minus 15n and then plus 16. So there we go. Okay, so it's just the thing where you had to use everything they gave you, and that is worth 6 marks. Okay, moving on to the next question. Then 3.2 says, is 216 a term in this sequence? Justify your answer with the necessary calculations. So is 216 one of the terms in the sequence? So the terms in the sequence would be obviously the quadratic sequence. So is it one of these terms that are in the sequence? So to find out if 216 is a term, okay, is one of the term values in the sequence, all we'd have to do is take the general formula that we have. Because we are trying to find out if this is a real term in this sequence, we need to find out which term number it belongs to. So in order to find the term number is n. We need to solve for n. So we're going to take 216 and put it in place of Tn, because we're saying T what, okay, is equal to 216. And that T what really stands for Tn. So when we find n, we can say T whatever that is equal to 216. So in place of Tn, we're going to put 216. Okay, so it's going to be 216 is equal to, and we have 5n squared minus 15n plus 16. And let's go ahead and simplify this. So because n squared, its coefficient is positive, I'm just going to go ahead and take this over. So we have 0 is equal to 5n squared minus 15n, and then we have plus 16 minus 216. And so that is probably negative 200. So if you have 16 minus 216, we get negative 200. So that gives you a minus 200 when we take that over. Okay, now this is a quadratic equation that we have, because you see n squared, n, and a constant. This is a quadratic equation, and it's a trinomial. So we need to solve for n. If you look through all these terms, you will notice that we have a common factor. 5 can go into all these numbers. So we can just go ahead and divide both sides of the equation by 5. 0 divided by 5 is 0, and then is equal to n squared. And then negative 15 divided by 5, that's negative 3n. And then negative 200 divided by 5, that is going to give us negative 40. Okay, so this is what we have now, and we have to factorize this. So open up two brackets, and we're saying what multiplied by what gives you n squared. That's n multiplied by n. What multiplied by what can give us 40, but will also help to give us a 3. So I think the factors 8 and 5 would work, because 8 times 5 is 40. So, but if we make the 8 negative, so negative 8 and positive 5. Because if you say negative 8 plus 5, you're going to get a negative 3 in the middle. Okay, so these are our factors. So it means that n is either equal to, we're going to take the negative 8 over the equal to sign. So it's either equal to 8 or n is equal to a negative 5. But remember, we are working with sequences. Sequences cannot have negative term values. And really the reason why is because they're speaking about positions. This sequences could be their patterns. So it could be a situation like somebody keeps running every day and they keep running 10 kilometers more every day, something like that. So the n really stands for, it could stand for something like the days. So on day 1, this person ran this amount. Day 2, the person ran that amount. We cannot have anything like day negative 5. Okay, that's the reason why we cannot have the term numbers be negative, because they're speaking about positions. So it would mean that I'll cancel that one, and it means that it's actually T8, term 8, that has a value of 216. Okay, so to conclude, is this a term in the sequence? Yes, then you can say 216 is a term in the sequence, and of course, all this calculation would be your reason. Okay, so that is this question. I think that's the last question for question 3. Yes, okay, so that is the last question for question 3. Hello, grade 12s, and welcome to question 2 of this paper. So, in question 2, the first question we have for 2.1 says, the following is an arithmetic sequence. And we have 1 minus p, 2p minus 3, and p plus 5. 2.1.1 says, calculate the value of p. Okay, so the big hint here is that they said this is an arithmetic sequence. And there's something that we know about an arithmetic sequence. So if this is the sequence that we have, every arithmetic sequence, right, would have a difference. And that difference is constant all through. So when I'm trying to find this difference, the way I'll find it is by saying the next term minus the previous term, because this is arithmetic. So that minus that, and that's going to be the p plus 5. Now you see we're subtracting by something that has 2 terms. So you need to protect this with brackets. So 2p minus 3. And then we're also going to find the difference here. That minus that, second term minus first term. So that is 2p minus 3 minus, again, bracket 1 minus p. So this is the difference, and that is also the difference. But because it's arithmetic, the difference needs to be constant all through. So it means that these are equal to each other, so we can equate them. So this is our equation, and it will help us to solve for p. Okay, so let's simplify. We have 2p minus 3. If we distribute, that gives you negative 1, and plus p is equal to p plus 5, and that will give you negative 2p plus 3. Okay, so just simplify. I actually prefer simplifying things with the p's first on the hand sides that they are. Okay, so on the left hand side, that would give us 3p, and that gives us negative 4. Okay, it's equal to, and then here p minus 2p, well, that gives you a negative p. So let me just start with the numbers. 5 plus 3 is 8, so that's 8, and minus p. Now we can take the p's over. So that is 3p, and this comes over and becomes a positive p. 3p plus p gives you 4p. So we have 4p here is equal to, we still have the 8 here. And if the negative 4 comes over and becomes a positive 4, 8 plus 4 is 12. And then we can divide both sides by the 4 to get rid of that to solve for p. So therefore, p is finally equal to 3. And there we go. So that is the solution for the first question. And we move on to the next question. Okay, so 2.1.2 now says, write down the value of, and the first one, we need to find the value of the first term of the sequence. Okay, so since we know p, we can find the first term. The first term, t1, is this. It's 1 minus p. So if t1 is equal to 1 minus p, then, okay, this is a, so we don't forget. So then you just substitute p. So that's 1 minus 3, which is negative 2. So that is the value of t1. And then b says we need to find the common difference. Okay, so there's not much work we need to do here because we already found p. So do you remember when we said t2 minus t1, right, would give you a common difference? That is a common difference. And t3 minus t2 also gives you a common difference. So all we have to do is take a simplified version of the common difference. So remember, that is when you didn't take anything over yet. So that was a common difference. When we simplified it, it got to this point. Okay, we didn't take anything over at this point. But then this one looks easier, so I'd rather use this one. So this is actually the value of d if you just substitute p, okay? Because that minus that, and then you just simplify that. So that is d. So okay, just go ahead and tell them that d is equal to that 8 minus p. So 8 minus p, but we know what p is, 8 minus 3. So d is finally equal to 5. And there we go. So that is t1, and that is the common difference. Okay, moving on to the next question. Question 2.1.3 says, Explain why none of the numbers in this arithmetic sequence are perfect squares. Okay, so why are none of the numbers in this arithmetic sequence perfect squares? Let's go ahead and just expand that arithmetic sequence. So we know the first term is -2 and the constant difference is 5. So we just keep adding 5 to get the next term, right? So if you add 5 here, -2 plus 5, you're going to get 3. And then again add 5, then we get 8. And then keep adding 5. Let me just write the next term. So again plus 5, we're going to get 13. And then again we get 18, then 23, then 28. But do you notice now, I've actually done this question before. It looks like they're recycling a question because I remember this, but I just don't remember exactly where it was. I'm going to look for that quickly. Okay, I didn't really find it, but I know I've done this question before. I can remember this exact question. Okay, so we have this, and then of course, if you keep going, you're going to end up with 33 and then 38. So the question is, you need to explain why none of the numbers in this arithmetic sequence are perfect squares. And I remember how that question was phrased. It actually asked, you need to, well, it wasn't asking, it was just asking you to prove that none of the numbers would be a perfect square. So, but this one, we just have to explain why. Okay, so let's look at this. Let's actually focus on what exactly perfect square numbers look like. If you have a perfect square, right, those numbers would work like this. If you take 1 squared, you get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And then 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100, right? And let's just end at, I'm just trying to just see exactly what these type of numbers look like, and then let's just compare them to this so that we can understand why none of this would ever be a perfect square. So 11 squared is 121, and then 12 squared is 144, 13 squared is 169, and I think here at this point it's fine. Let's go ahead and look at these, right? What do you notice about these numbers? -2, 3, 8, 13, 18, 23, 28. Do you notice that all of these numbers, of course, except for -2, right? All of these numbers, they end either with a 3 or with an 8. See? 3, 8, 3, 8, 3, 8. And that will just keep happening throughout this sequence. So that's what happens, right? So let's actually go ahead and look at perfect square numbers and find out why exactly none of this would ever be a perfect square, because we can see that these numbers keep ending in a 3 or an 8. Well, with perfect square numbers, we can also just look at the numbers that they also end in. So perfect square numbers, they end with 1. You can have a perfect square number ending with 1. And we can also see that same thing happening here. That ends with 1. That also ends with 1. Okay, so 1 is one of the things that perfect square numbers end in. Do they end with 2? No, but we don't even have to consider 2 really. I guess we just have to focus on whether we can ever have a perfect square number that ends with a 3 or ends with an 8. Okay, so the next type of number that will end with, let's try 3. Do you see any perfect square here that ends with a 3? No. And if you keep going on, even if you said 14 squared and 15 squared, they will never end with a 3. And again, what other numbers do they end with? So do they end with 4? Yes, they do end with 4. So perfect square numbers end with 1. They end with 4 as well. See, that ends with a 4. That also ends with a 4. If you keep going, you will also find more perfect square numbers that end with 4. Okay, so they end with 1. They end with 4. What else do they end with? I also see they end with 5 as well. See, 5 ends with 5 there. If you kept going and you said 15 squared, then you get 225. And that also ends with 5. So perfect square numbers also end with 5. And do they end with 6? Yes, we have there 36. Okay, if you keep going, I think about like 14 squared ends with 6 as well. because 4 times 4 is 16. So they definitely also end with 6. Yes, we only see 1 6 here, but if you try 14 squared, it will also give you something that ends with 6. I know that because when you say 14 squared, I know that if you square 4, you get 16. So that ends with 6. So definitely 14 squared will also end in 6. Do they ever end with a 7? No, you won't really find a perfect square number ending with 7. So do we have perfect square numbers that end in with an 8? No, you will never find a perfect square number ending with 8. So that doesn't work. But you do find ones that end with 9. So that's 9, that's 9, that's also 9. Okay, so you get ones that end with 9. And then, of course, I would say 0 as well, which I should have put here because I'm just trying to put it in order. And also 0. And of course, this is because of numbers like 100 and 400. Okay, so those type of numbers. So these are the numbers that perfect square numbers end with. And as you can see, these ones, okay, they end with either a 3 or an 8, except of course for the -2. But -2 is not even a perfect square either. Okay, so our answer for this is the reason why none of the numbers, okay, in this arithmetic pattern is going to end with a perfect square is simply because perfect square numbers end with these, while these numbers in this pattern will always end either with a 3 or with an 8. Of course, that's excluding the first term. Okay, so my answer for this is because perfect square numbers end in these numbers that we spoke about, while all the terms in the pattern, excluding the first term, ends in a 3 or 8, okay? Because that one ends with a 2. So that is the answer to that question. That is worth 2 marks. This is a recycled question. They have already asked this question before. I've seen this question. So you see, past exam papers are very important to do, but make sure that you have used maybe a textbook or something to go through your theory first, and then start working on exercises and then past exam papers. So in maths, just make sure you focus on practicing. That is very important. Okay, so that is it for that question. Moving on to the next question. And the next question we have 2.2 saying, the following sequence of numbers form a quadratic sequence. Okay, so that's a quadratic sequence. And 2.2.1 says, the first differences of the above sequence also form a sequence. Okay, think about what kind of sequence that forms. The first difference of a quadratic sequence will always form an arithmetic sequence. Okay, so that's what it forms. Then they want you to determine an expression for the general term of the first differences. Okay, so this one is relatively simple. It's not really a complicated one. So they're just telling you that you have this sequence, right? This is a quadratic sequence. And all they're saying is, when you find the first difference, when you find the differences of this sequence, you're going to end up with another sequence. Now we know that when you find the first difference, it's going to be an arithmetic sequence. And you just need to find the general formula for that first difference, for that arithmetic sequence. That's all. Okay, so let's just go ahead and find that. We're going to say this term minus that term. So it's always the next term minus the previous term. So that's -11 minus -6. You know that that's going to become a plus, okay? So that's -11 plus 6. It's like saying 6 minus 11. And that's going to give us a -5 that we'll have first. Keep moving. And then we have -6 minus, of course, -3, which becomes a +3. So that's 3 minus 6, which is -3. Then -3 minus -2, which is really -3 plus 2. -3 plus 2 gives you -1. And then lastly, -2 minus -3. So -2 and becomes +3. So that is +1. Okay. So this is the sequence that they're referring to. That is your first differences. And you will notice that this is well, you don't even have to notice. We know that if this is quadratic, this is arithmetic. So we just have to find the formula for this. The formula of an arithmetic pattern is Tn is equal to A plus n minus 1 multiplied by D. So the first term is 1, as you can see. And your difference, you're just going to find by saying next term minus the previous term. But this one looks easier. So what's -1 minus 1? It is -2. So that's your difference. Well, I'm sure we're supposed to leave it somewhere here. So I'll just do that. Is equal to -2. Okay, so Tn is finally equal to 1 plus n minus 1 times -2. And then I guess you can simplify this if you want to. So I'm going to go further and simplify this. So this is Tn is equal to, and we can distribute. That is going to be 1, and then you're going to distribute that into here and here. So that gives you when you multiply, -2n, and when you multiply to the -1, it gives you a +2, which is really just Tn is equal to -2n, and 1 plus 2 is +3, and there we go. So that is the formula they were referring to. Okay, moving on to the next question. Okay, so the next question, 2.2.2, says, calculate the first difference between the 35th and the 36th term of the quadratic sequence. They keep bringing this question over and over again. Okay, they just keep representing it in different ways. So I want you to understand something about this. Remember, this is referring to the quadratic pattern. They want to find out what exactly is the difference between the 35th term, term 35, and term 36. What exactly, which term is going to be here? So you need to calculate the first difference there. What is the value of that? Okay, so please note that this is only for 1 mark. It's a very simple step, okay? It's not something where you have to go start calculating a lot of things. It's really not that at all. Think about it like this. Okay, if you have a quadratic pattern, and let's say I have T1, T2, and T3. Okay, if I wanted to know what term exactly would be between the third and the second term in this quadratic pattern, which term would this be? In your first difference, of course. In your first difference, this would be term what? Well, if you say term 2 minus term 1, you'll get term 1 of your first difference. And if you say term 3 minus term 2, you'll get term 2 of your first difference. So the term between term 3 and term 2 in your quadratic pattern will be term 2. Look at the pattern going on. If you're trying to find the first difference term between two terms in your quadratic pattern, if this one says 3 and this one is term 2, then it's always going to be the second one's term. Okay, so what I mean by that is we have a 2 here and we're going to also have a 2 here. So think about it like that here. If you have term 36 here and term 35, which term in the first difference would be right between the 36th and the 35th term? It will be the 35th term in the first difference. That's just how it's going to always work. Okay, because you will notice that your first differences, they would have one less term than the amount of terms in your quadratic pattern. So this is actually really simple. That's why it wasn't something that you had to like over stress about. I didn't even need this diagram. All you have to think about is finding term 35 in your first difference. And we already have the formula of the first difference. So we're just going to substitute that. So it means that this is term 35 is equal to, and I'm substituting, it's -2 multiplied by 35 plus 3, because that is our term number, term 35. And that will be our answer. So go ahead and find that answer, and that's your answer. And that first difference is -67. And there we go. That is the answer to that. Moving on to the next question. The next question, 2.2.3, determine an expression for the nth term of the quadratic sequence. Again, they're being very, very simple and straightforward. So we just have to find the quadratic pattern's formula. Okay, let me bring that quadratic pattern down. So we already have this. We have the first difference, and we already know what the second constant difference is. It was -2. We found that already from here. Okay, the second constant difference, that minus that is -2. We found that. So we're just going to go ahead and find the Tn formula. Remember that the formula for your quadratic pattern, the general formula of a quadratic number pattern is Tn equals an squared plus bn plus c. So we just need to find A, B, and C. To find A, or to find all of them, we're only going to use the first term of each of the patterns that we have here of the quadratic first difference and the second constant difference. So to find, let me actually just move this to the side. Okay, so to find this, the A, you're going to equate this first term here to 2a. And then to find the b, you equate this number to 3a plus b. And to find this one, you equate it to a plus b plus c. Okay, so that's what we have there. So we're going to go ahead and tell them that 2a is equal to negative 2. Solve for a, and we'll divide both sides by 2. Therefore, a is equal to negative 1. And then to find b, we're going to say 3a plus b, but we already know what a is. It's negative 1. So 3 times negative 1 plus b is equal to our 1 over there. Okay, then we know b is equal to, then we have 1, and 3 times negative 1 is negative 3, right? And you take in that negative 3 over and becomes a positive 3. So 1 plus 3 is 4. And then we have c as well. I'm just going to go ahead and substitute. So that's a plus b plus c. We already know a, it's negative 1. We know b is 4. And we don't know c yet. And it should be equal to this number over here, which is negative 3. So it's equal to negative 3. Let's just go ahead and add. So c is equal to, we still have negative 3. If you say 4 minus 1, because that's really what it is, 4 minus 1 is 3. Take your 3 over, your 3 becomes negative 3. C is equal to negative 6. So there we go. We just have substituted into this equation. Tn is equal to negative, okay, since it's negative 1, just call it negative n squared. And we have plus 4n and then minus 6. And that is our formula. Simple like that. And we move on to the next question. Okay, and the last question for question 2, 2.2.4 says, show that the sequence of numbers will never contain a positive term. So in a nutshell, they want you to show them that the sequence will always, all the terms in the sequence will always be negative. That's all, really. Okay, so that's really all they say. Negative terms. That's all we're going to always have. Okay, because this is a quadratic pattern, right? When we already have the formula of the pattern, I can say that there are two ways of really proving this, okay? And I'll show you the two ways just so that it is both there, okay? The one way is a little more graphical. You just have to use like a diagram to explain it. You wouldn't need to draw the diagram maybe in your answer, but I will use a diagram just to explain what I mean by that. So let me go ahead and explain two methods of doing this. So the first method would be really just looking at the arithmetic part of this formula. And the reason we are using this is because we're trying to show them that all the terms in the sequence are going to be negative, right? So because this is going to control your term values, we're going to use that. Okay, if you substitute an n value, you get a specific term value. If you substitute another n value, you're going to get another term value. So that controls the term. So we're going to use that in both of these methods. Okay, so the first method, we're focusing on really just let's call it the arithmetic of it. We're looking at the way the numbers look and what creates a positive number and what creates a negative number. That's really what we're going to look at here. So in the first method, I need to show them that it's always going to be negative terms. So I can take advantage of the fact that this is a quadratic expression that we have. For you to find out the kind of results, okay, the type of numbers you're going to get if you substitute n values into a quadratic expression will be, the best way to actually find out that would be to manipulate this. And we call that, or to simplify this, we call that really completing the square. So we're really just rewriting this in a way that we would be able to see the nature of the result of this expression. So completing the square would be this. So we take Tn is equal to, and we say negative n squared plus 4n minus 6. The first thing we're going to do here is, so we're really just putting it in turning point format, really. Okay, turning point format is very helpful because it helps you to figure out exactly what the nature of the terms would be. So we're completing the square. You need to first of all ensure that the coefficient of n squared is a positive 1. Right now it's a negative 1, so we're going to take that out as a common factor. So we're taking that negative out and we'll be left with n squared, and then here you're left with negative 4n and positive 6. Okay, this is what we have now. Then after taking that out and ensuring that the n squared has a positive coefficient of 1, you are going to take now the coefficient of n, and you're going to half that. So you're going to multiply that by a half. And of course, when we do that, we get -2. And you're going to square -2. Now, because we are dealing with this as an expression and not an equation, what you're going to do with this -2 is you're going to add and subtract -2 to this expression. The idea behind that is you're not changing the value of the expression, you're just changing the way it looks so you can better simplify it. So we're saying this is equal to negative, and I'm going to use big brackets now because I can see that I have brackets here. So I have n squared minus 4n, and I'm going to go ahead and add the -2 all squared, and then subtract it so that this way I'm not changing the value of the expression. So minus -2 all squared. And then I still have my plus 6, of course, and close bracket. Okay, then at this point, we're just simplifying. We have our negative outside, open a bracket. And what we're going to do is we're going to pull, because this has a squared and that has a square, we're going to put the n and the -2 into one bracket. So we're putting them like this, and we're saying that they're both squared. And what we have there is n and the -2. Okay, then after doing that, we're going to just rewrite what we have. You see, this is all that is left. You can simplify that as a single number. That is fine. So negative, and we have, so that's minus, -2 squared is 4. So minus 4 we have there, then plus 6. 6 minus 4 is positive 2. Okay, so this is what we have here. Then lastly, you see these big brackets, they shouldn't be there. You need to simplify that out. So what we're going to do is take our negative and distribute it into our terms here. Notice please that we have two terms, this term and this term. So when you distribute that, this multiplies just to this bracket, not inside the bracket. So really all you have there is our final answer, Tn is equal to, the negative goes in front of that, negative n minus 2 squared, and then the negative multiplies into the positive 2 as well, and that becomes a -2. So this is what our expression looks like. And now we can actually look at this and determine the nature of this expression, meaning what kind of values will this expression have? Okay, so given that this is the formula for a pattern, right? You know the way patterns work. The n values of patterns, okay, the term numbers, they can never be negative. You cannot have term -2, for example. It's always going to be positive numbers. So term 1 and term 2 and term 3. So they're integers first of all, and they're always positive. So I know that I'm already putting these premises here. I know that n needs to be greater than 0 and n needs to be integers. Okay, so n is an element of integers. I'm just stating that. I know it's obvious, but I'm just going to put it there as well. So now we just need to show them that these terms will always be negative. For me to show them that the terms will always be negative, I'm just showing them that this expression will always have a negative value. How do you prove that an expression or a number is negative? How you prove a number is negative? Negative numbers are a result of a positive multiplied by a negative. So if I can show that there is a positive number that's been multiplied to a negative, then it's going to show that, okay, that is negative. So how I'm going to do this is I can just go ahead and take this expression as it is, and I'm going to examine it like this. Let's start with the part that is squared. You see, n minus 2 squared will always be greater than 0, or it could also be equal to 0. That's in the case where maybe n is equal to 2, right? So the 2 minus 2 would be 0, 0 squared would still be 0. So the expression will always be either greater or equal to 0, that part. But then, so this is already showing that this is positive or equal to 0. But then what happens is we have a negative in front of that. So if this will always be positive, it means that this, because you put a negative in front of it, it will always be negative. So it's either going to be less than 0 or equal to 0. I also have to consider that as well, because that could be equal to 2. So that is always going to be equal to 0 or negative. So what happens then when you subtract by 2, by something that is already either 0 or negative? It's going to become even more negative, because if it was equal to 0, if this expression, because we substituted a number here, was equal to 0, and then you subtracted by 2, so that's this part over here, then you subtracted by 2, it will make this -2. And then every other expression that you get will also be negative, okay? Because it's either going to be less than 0 or equal to 0, okay? So it means now that if you wrote the expression like this, let me just say negative n minus 2 all squared, right, minus 2, it's always going to be negative, so less than 0. And this would really prove that. So it would mean that Tn is always negative. So that is just using the nature of the expression. Okay, that proves that that will always be negative. Okay, so that, I'll say that as one way of proving that. Now, the second way of proving this would be kind of thinking about this as a function, okay, as a graph. This is a quadratic expression. Because it's a quadratic expression, it means that we can represent it as a parabola. Now, let's think about the type of parabola it's going to form. So when we have our axis, so this our y-axis and our x-axis. First of all, let's just understand this. You see the values that will be on your x-axis. Those would be your term numbers. So like term 1, term 2, term 3, and so on, right? And then the numbers, so just say those are terms. The numbers that you'll have on your y-axis, those would be your term values. That is the result of substituting a term number into your expression. So I could also add numbers here as well. So let's just go ahead and say, let's say negative 1, negative 2, negative 3, negative 4, okay, and just 1 and 2. So what happens here is we're going to go ahead and draw this graph, but we're not going to overthink it because there's really just one point that we need on this graph to be able to see the kind of terms this will always have. And that term specifically that I'm referring to is going to be your turning point. You see, if your parabola is positive, it's going to look like that. And this is the turning point. The turning point is very powerful in telling you the type of values you're going to keep having for this. A positive parabola will always have whatever number that is, whatever y value that is, right? And everything above it, every y value greater than it. So in this situation, if these numbers were positive, of course, you would see that, okay, that will always have positive values. So if we look at that with this graph, let's go ahead and find that turning point or the maximum or minimum value. Because this is a concave down parabola, it's going to have a maximum, meaning this is the highest that the graph can go. Of course, the lowest of the graph would be like negative infinity because this graph will keep shooting down forever. So we can go ahead and find that turning point or the maximum of this parabola. And we can use the formula x is equal to negative b over 2a to find that. I'll just call it n because we are working with terms here. So negative b, you can see that the b value here is 4. So we have negative 4 over 2 and a is negative 1. So times negative 1. So that's really just negative 4 over negative 2. Which is positive 2. So that's what the term number at the maximum is going to be. That is this. That is positive 2, meaning our maximum is going to happen where x is equal to positive 2. But what we actually need is the y value of this. The y value of this we'll find by substituting that x value into your Patton's formula. Okay, so Tn. So what happens at where t is equal to 2, which would substitute like that. And we'll find out that T2 is actually equal to negative 2. So you see, the maximum is at negative 2. So here, this is what it means about it. Let me actually just tell them that the maximum is negative 2. And why this is actually very important to prove that these terms will always be negative. You see, if your maximum is at negative 2, it's 2 and negative 2, it's here. Remember that this is a concave down parabola. So it's going to look like this. Then you go like that and like that. Do you see that? Remember the y values tell you the results. They really just tell you what exactly your term values are going to be. For example, when n is equal to 1, your y value or your term number is going to be maybe something like negative 3. It may not be exactly that. Of course, it's just an example. And then where n is equal to 2, your y value is negative 2. Do you see that none of these y values of this graph will ever be positive? Because your positive numbers are here. There's no graph here. So it will never have a positive value. And we can already see that. So that's why the maximum is very important in proving what kind of term values you're going to have in a parabola, of course. So what I would just add to this is, because the maximum is equal to -2, and we know that the a value of our parabola or our formula is negative, we would know that this will never have a positive value. Rather, the terms will always be negative. So terms will always be negative. Always be negative. And that's how we would actually prove that. Okay, so there's actually two ways. You can visualize it and think about the nature of the terms, looking at it as a graph. Or you could actually just think about it based on the nature of the expression, okay, and what the values of the expression are going to be when you substitute n. Okay, so that is it for this question 2. Then we move on to question 3. We are on question 3 of this paper, and question 3 says 3.1. Given Sn is equal to 4n squared plus 1, we need to determine term 6. Again, recycled questions. They keep recycling questions. This one has come up before. So, and this is really something that's actually in a textbook. The Kevin Smith textbook, grade 12, there's a question like this. It's an example, really. It's just to teach you how to work on questions like this. So I know that you see Sn is equal to, and you see something that is quadratic. All you have to focus on is the fact that this is Sn. It doesn't matter whether this is quadratic or not, because it's not even the Tn formula. Okay, it's just Sn, and Sn stands for the sum of terms. So let me give you a quick illustrative example of how this is going to work. So we can think about this like this. You see, if I was referring to the sum of two terms, it means that I'm speaking about term 1 plus term 2. Okay. And if I said the sum of 3 terms, it means I'm speaking about term 1 plus term 2 plus term 3. And that will be the sum of 3 terms. I can actually use this information to find term 3. Here's how we're going to do that. To find term 3, do you see that if you take the sum of the 3 terms, all of this, and you subtract it by the sum of 2 terms, all of that, look what's going to happen. So remember, we're saying S3 minus S2. What's going to happen is everything that repeats here will cancel, because we're saying this entire thing minus this. So T1 would subtract with T1, and T2 would subtract with T2. And what are you left with? Term 3. So that's actually what you can always do to find a term value if you're given the formula for the sum of the series, regardless of whatever series it is, whether it's arithmetic or geometric, you can actually do this. Okay, so even if I asked you, okay, how would we find, let's say, the 11th term? You would find the 11th term by taking the sum of 11 terms minus the sum of 10 terms. You'll be left with the 11th term. Okay, so that is really the reason why, because those same ones, they cancel since they are the same thing. Okay, so with that being said, we can easily find the 6th term since we know the sum of the terms here. It means that term 6 would be found by saying the sum of 6 terms minus the sum of 5 terms. So let's go ahead and do that. So that's all really we have to find. So I'm just going to put it in like that. So sum of 6 terms, let's substitute 6 into our sum formula. So that is 4 times our 6 all squared plus 1. And we're going to subtract that by that. But you see, they have 2 terms. So I'm just going to protect it with brackets. So that is 4 multiplied by 5 all squared and then plus 1. And you just have to actually find that. And that's your answer. Okay, so just to ensure that we do get marks if they separately want to see what exactly the sum of 6 terms is and the sum of 5 terms, I'm just going to do it like that. So the sum of 6 terms is 143 minus, and if you change that to a 5, sum of 5 terms is 99. So 143 minus 99 is going to get you to your answer, which is just the sum of 6 terms is 44. And that is our answer for that question. Okay, moving on to the next question. Okay, then question 3.2 says, for which values of x will the following series converge? So let's understand what should happen for a series to converge. Okay, so we know that for series to converge, a geometric series, of course, then your ratio needs to be either greater than -1 but less than 1. Okay, and the idea behind converging series is when a series converges, you look at the terms. Okay, I'll give you an example of a converging series. Something like 1 plus a half plus 1/4 plus 1/8 plus 1/16. What is actually happening to this series is that as we get to the next term, each consecutive term, right, gets closer and closer to a particular number. In this case, that number is 0, okay? But it will never actually become 0. And the idea behind that is, think about it like, let's say you have a cake. No, let's actually use something more simple. Let's say a slice of bread. And you cut that bread. So this is one whole. So we're just recording what this slice of bread is going to be, the fraction of it, as we cut it into half each time. So first it started off as a whole. If you cut it in half, you end up with just 1/2. If you cut it in half, you end up with a quarter. If you cut that quarter in half, you end up with an 8. If you cut that 8 in half, you end up with 1/16. But tell me, if you keep cutting this bread, will you eventually get nothing? Would you get no bread? No, that's not possible because you're not a magician and you cannot make things disappear. It will not become 0. It will never become 0. It may be the tiniest bit of bread, but there's still something that exists. Okay, and that's really what this is going to keep doing. It gets closer and closer to 0. That's what a series does when it converges. Okay, so I always wanted to just explain that. I know I always just gave you the formula and never really went into it, so I just decided to explain it in this video. Okay, so that's really what a converging series does. And all we're really just trying to find out is the values of x for which this is going to converge. So we know that the ratio needs to be greater than -1 but less than 1. So the next thing we would need to do to actually find out what exactly the x value should be for the series to converge is we would have to find that ratio. What exactly is that ratio? Because this series is converging, we know it's a geometric series, first of all. And with a geometric series, to find the ratio, you always say the next term divided by the previous term, okay? It's not arithmetic, so we don't subtract. So next term divided by the previous term. So this one is quite simple. If you take the next term, term 3, that is 4x minus 3 cubed over, and if you take term 2, it's 4x minus 3 squared. See, these are actually quite simple to simplify. It's like x to the power of 3 divided by x to the power of 2. Okay, what happens is if the bases are the same and you're dividing, you subtract your exponents. So you end up with x to the power of 3 minus 2, which is 1. So really what I'm saying is the same thing is here on top and the same thing is on the bottom. So their exponents just get divided. And that's why we know that r is actually equal to 4x minus 3 to the power of 1, but you can just leave it like that because it's just 1 as an exponent. So that's our ratio. So we're going to substitute that into our inequality. And so we're really just saying, let me just continue here. We're saying that 4x minus 3 as our ratio must be greater than -1, but less than 1. And you're just going to solve for this inequality. So I like to call this a double inequality. It's really just two inequalities that have been put together as one. So what we're going to do is we need to solve for the x. The -3 is stopping us from doing that right now. So we're going to take it over. But because this is a double inequality, it's two inequalities really, you need to take it over on both sides. Okay, so we're going to have -1 and the 3 comes over and becomes a +3. We still have our sign. We have 4x here and then we have a 1 here. The 3 comes over, that -3 comes over and becomes a +3. So 3 minus 1 is 2 and 1 plus 3 is 4. Then we need to get rid of the 4. Again, it's a double inequality, so you're just going to do the same on the both sides. So what we're doing is actually dividing both sides by 4 to get rid of that 4. And we're going to get that x is going to be 2 over 4, is 1/2. and 4 over 4 is 1. So that is actually the values of x for which the series will converge. If x is greater than a half but less than 1, your series here will converge. Okay, grade 12s, I just want to add something. For this answer, I know that in the memo you would have probably seen that they said that r should not be equal to 0. Okay, so for r to be not equal to 0, if r was equal to 0, we're just looking at it like this. So let's just say we had 3 terms in a geometric pattern. So term 1, term 2, and term 3. So I'm just showing you why r cannot be equal to 0. In this case, if it is geometric, you have to find the ratio, right? Because we're really just trying to focus on the ratio. So if these are our 3 terms, and we're trying to find the ratio, we'll say term 3 divided by term 2. And if it really is the ratio, it should be constant. So this should be exactly equal to term 2 divided by term 1. It should be constant. Now, if your ratio really is equal to 0, once you divide, it's equal to 0, then that would imply that either term 3 is equal to 0, then you said 0 divided by whatever value term 2 was, and then you got 0, or it should be that term 2 was equal to 0, and then you divided by whatever term 1 was, and then you got 0. But you can see how that is not possible, because if you're already saying that term 2 is equal to 0 here, and to find the ratio here, you must say term 3 divided by term 2. Well, term 2 is 0. So if you divide by 0, what happens? You're going to end up getting an undefined value. And that's the reason why we cannot let the ratio be equal to 0 in a geometric pattern. So it's something that we don't really state a lot, but it is a fact. You can't let r be equal to 0. Now, the only reason we're including this in this question is because we're specifically trying to find the x value for which the series converges. So we want to make sure we don't take a value that will make our ratio undefined. So we cannot accept any of that. So remember, it is the ratio we're referring to. It shouldn't be equal to 0. Since this is our ratio in terms of x, we're saying that 4x minus 3 must not be equal to 0. And if 4x minus 3 must not be equal to 0, we'll just solve for what x should not be here. That's 4x should not be equal to, take your negative 3 over, and then divide both sides by 4. So it really just means that x should not be equal to 3 over 4. Okay, and we have to actually state that. So yes, we do this, but we do say where x is not equal to 3 over 4, so that we don't include that in our answer. So if you're looking at your answer on a number line, you have a half and you have 1. We're saying that x needs to be greater than a half, but less than 1. Yet it must not be equal to 3 over 4, because 3 over 4 would lie in between a half and 1. It's somewhere in between here. Okay, so that is the reason we have to include that there, just because we're actually solving for x. So if you didn't include it, it's still fine. They will not penalize you for that. Okay, so that is that. Okay, so question 3.3, we have calculate the value of the sum of this series, starting where k is equal to 3, ending at 5 of this. Okay, so I would have looked at this and said, I think this is geometric because of this, but I can't say that anymore because it has k on the denominator as well. Okay, so that changes everything. That's not geometric anymore. We could go on a whole journey of finding out what exactly this is and what kind of series it is. But let's actually just focus on the fact that they only ask you to calculate the sum of the series starting where k equals 3 and ending at 5. Okay, so you can actually go ahead and expand this, because where k is equal to 3, we'll find that. Where k is equal to 4, we'll find that. And where k is equal to 5. It's just 3 terms. So you can expand and find and actually just sum it up. So where k is equal to 3, let's substitute. If you have k being equal to 3, so we have negative 1 to the power of 3 multiplied by 2 over 3. Okay, so what we're going to get there is, well, that still stays negative 1. Okay, so negative 1 to the power of 3 is negative 1 times 2 over 3. So that will give you negative 2 over 3. That's that one. Then where k is equal to 4, that's negative 1 to the power of 4 multiplied by 2 over 4. And 2 over 4 times negative 1 to the power of 4, that gives you 1. That's 1 times the same thing. So we're really just adding 2 over 4. And then where k is equal to 5, so we'll have, and I should have actually just written these down separately. So let me just say that's the answer, that's 2 over 4. And then negative 1 to the power of 5. So I get the idea. It becomes negative, positive whole time. And then we have 2 over 5. And then this is just going to be negative 1 again because it's raised to an odd number. And that is just 2 over 5. So that's negative 2 over 5. And we just have to add these up together. So the sum of that series is going to be found by saying, if you like, you can rewrite that whole thing. It's just found by saying negative 2 over 3 plus 2 over 4 minus 2 over 5. That's all. Okay. And then you just add it up, and that is going to be your answer. So if you didn't use a calculator, you would have to ensure that all the denominators are the same. So then you will find the lowest common multiple of them and then add them up. But if you just use the calculator, your answer is just negative 17 over 30. And that is your answer. Okay, so that is the last question in question 3. Okay, so first question, we have 2.1.1, which says we have 7 plus 12 plus 17, and this keeps going. And it's an arithmetic sequence. So they just want us to find, the first question is, we just have to find the value of T91. Do not be extra. Don't go ahead and find the whole pattern's general formula. Just stick to this question. They want you to find T91. Well, this is an arithmetic pattern. So the Tn pattern is Tn is equal to A plus n minus 1 times D. And all I'm going to do is literally just substitute. So T what? They want you to find T91, term 91, is equal to A. What does A stand for? Well, A is always your first term. So that is 7 plus, what is n again? N does not change. It's still 91. So 91 minus 1. And then what is our difference? And now we can just easily see the difference. If you say 17 minus 12, that gives you 5. And you can also double check by saying 12 minus 7. That also gives you 5. So you can also see now that D is equal to 5. And you know that A is equal to 7. So, and times 5. And you're just going to put that onto the calculator, or you can calculate it manually, but it's best to trust the calculator in an exam. And then we just find our answer. Also, if you want to put it properly on the calculator, make sure you put brackets around that because the calculator will not understand otherwise. So 457 is our answer. Okay, moving on to the next question. The next question says calculate S of 91. S91. The sum of 91 terms. Interesting because they asked us to calculate the value of term 91. So since they want us to find the sum of 91 terms, remember that they already told us to find T91. So this is the last term. So we're going to use this formula, 2.1.3. We're just going to use Sn is equal to n over 2 multiplied by A plus L because we already have the first term and we have the last term. So S91 is equal to 91 over 2. A is 7 plus the last term is 457. We found that. And you can just go ahead and substitute that and let's see what we get. And we get this number 21112. Okay, 21112. And that is the sum of 91 terms. Moving on to the next question. The next question says we need to calculate the value of n for which Tn would be equal to 517. So it's really just saying there's this term, right, that has a value of 517 and you need to find the term. And they really placed it in they put it in a very simple way. Sorry, I noticed I said 2.1.3. This is 2.1.2. Okay, so for 2.1.3, what we're just going to do is find n if Tn is equal to 517. So Tn, we know our formula now. It's A plus, but we already know what A is. It's 7 plus n minus 1 times D, which we know is 5. All we're going to do is, in place of Tn, substitute 517. It's equal to 7 plus n minus 1 times 5. So I like to simplify it this way, where I'm going to take the 7 over because I can see that there are two separate terms here. That's the first term, second term. So take 7 over. 517 minus 7 is 510. And then now this, you see this is 2 terms being multiplied by 1 term. You can rewrite this as 5 bracket n minus 1. I'm not going to distribute because it just takes longer. I feel like it takes longer. Then I'm just going to get rid of the 5 by dividing both hand sides by 5. 500 divided by 5 is 100. 10 divided by 5 is 2. So we have 102 is equal to n minus 1. Then you're just going to take the 1 over. And when you take the 1 over the equal to sign, that's just going to give you a plus 1. So 102 plus 1 is 103. And that is our value of n. Okay, moving on to the next question. Next question 2.2. Okay, so the next question says the following information is given about a quadratic number pattern. So this is the information. Term 1 is equal to 3. Okay, great. So we have a quadratic pattern and they're saying term 1 is equal to 3. And this is how you should put things, structure them down. As they're telling you the things, be writing it down so that you don't get intimidated by the question. Okay, so I'm just saying term 1 is 3. Okay, that's my first term in my quadratic pattern. Then they say term 2 minus term 1 is 9. Well, they told us term 1. And so if they're saying term 2 minus term 1 is 9, then that means I can easily find this term 2 they're talking about because I know what term 1 is. So term 2 minus term 1 is 3, is 9, right? So that's term 2 minus 3 is 9. So if I take this over, this negative 3 over, term 2 is equal to 9 plus 3, which is 12. So I know what term 2 is 12. And I'm also just going to really take into account that they specifically say term 2 minus term 1. Term 2 minus term 1 is 9. Okay, so that's the information we have so long. Then they also say, what else do they say? They tell us, and T3 minus T2 is equal to 21. T3 minus T2, again, another thing like that. T3 minus T2 is equal to 21. So I can also use this information to find T3, possibly, yeah? So T3 minus T2 is 21, but I know what T2 is now. T2 is 12, so minus 12 is equal to 21. Take negative 12 over, then it means that T3 is actually equal to 21 plus 12, and so that will give you 33. So T3 is 33. That's what we have. Okay, so this is what our pattern looks like. Okay, quadratic, and these are the differences, the first differences. The first question is for us to find or to show that T5 is equal to 111. So let's see how we can find that. We have T3, right? We just need to find T5. That doesn't seem so bad because this is a quadratic. So in order to find T5, why don't we just first of all find that constant difference, because we know it's going to be constant, right? Because there's T4, then there's T5. We just have to get to here. Okay, so 21 minus 9, what's that going to be? 21 minus 9, that's 8. 20 minus 8 is 12, so 12. And so now that we have this 12, what can we go ahead and do? We're just going to say that because we know this is the constant difference, second constant difference, okay? It's always going to be constant or really just the same. So here I'm also going to have a 12. So to find now the third term of the first difference, I would say 21 plus 12, which is 33 also, okay? Weirdly enough, it's also 33. Now to find the fourth term, I would just say T3, right, plus the 33, which would be 66. Then to find the fifth term, I'm going to do the exact same thing all over again. So I know that the constant difference is constant, so I will have a 12. So 33 plus 12, that is 45. Then 66 plus 45, 60 plus 40 is 100, 6 plus 5 is 11, so 111. There we go. And that's how I would find that. Okay, so there. This is going to be our proof that that's how we found what that is. Of course, with your equations, but I didn't really see a need of putting the equations down. It may be necessary, but it's only for 2 marks, so they probably just want to see that really. Okay, so T5 is therefore equal to 111. Okay, so that is 2.1.1. Moving on to the next question. The next question, 2.2.2. They say show that the general term of the quadratic pattern is this. You just have to find the general term. We already have all of this simplified. So all you're going to do here is, you see the second constant difference, you're going to make that equal to 2a. Okay, that's first term, of course, right? So, and then we're going to look at the first term in this row, and you're going to make that equal to 3a plus b. And then the third term in this row, you're going to make that equal to a plus b plus c. That's all. Okay, so let's start from the bottom. You always start from the bottom. So 2a is equal to 12. And then if you divide both sides by 2, a is going to be equal to 6. So there we already have that 6. Then they also tell us we have to, well, we're just trying to find b. So 3a, but I know what a is. It's 6 plus b is equal to 9. Okay, so b is equal to 3 times 6 is 18. So we still have 9 here. This becomes an 18. It comes over and becomes a negative 18. B is equal to 9 minus 18, negative 9, because it's double of 18. 9 is double of 18. And then to find C, A plus B plus C. So A is 6, B is negative 9, so minus 9, plus C, and then that's equal to that number 3. So let's just go ahead and simplify this. So I'm saying that C is equal to, I still have the 3, but 6 minus 9 is equal to negative 3. If you take negative 3 over, it becomes a positive 3. So C is equal to positive 6. And there we go. Okay, so there you have A, B, and C. So it means that Tn truly is equal to 6n squared minus 9n plus 6. Okay, moving on to the next question. Okay, so the next question is 2.2.3. And 2.2.3 says, we need to show that the pattern is increasing for all where n is an element of natural numbers. Remember, natural numbers are numbers that start from 1, and they're not fractions, they're not decimals, they're not surds, they're just whole numbers starting from 1, okay, so all the way to infinity, of course, right? So we need to show that this pattern is increasing. Well, if you think about how a pattern, or really thinking about an increasing pattern, this is a parabola. We already have the formula for the parabola, right? Because it's a quadratic equation, a quadratic pattern that forms a parabola. And as you can see, do you see that the first term is positive? So first of all, since the first term is positive, I'm already saying since a is greater than 0, right? We have a parabola that is concave up, or a smiley face parabola, right? We have that type of parabola. And so we need to now find out for which, not really for which values. We're not finding out anything. We're just showing them. We're showing them that the pattern is going to increase where n is an element of natural numbers. So we already know n can't be negative. Well, the only way for you to find this is to actually find really, because when you're looking at a parabola and when it's increasing, so I'm looking at a parabola like this, and to find out where this parabola is increasing, I would have to find the turning point of this parabola. If I can find the turning point, because here's the axis of symmetry of this. If I find the turning point, do you see that if you look on the left, right, you see what this parabola is doing here? You always read graphs reading from left, going all the way to right. So this graph is actually decreasing, moving from left to right. Where it starts to increase is here. So to show them that it's increasing, I need to find out exactly what this value is, okay? The n value, or the x value of that turning point is. And it's going to be a specific number that will probably be maybe positive. It has to be positive, or 0. But I would be able to see that after this point, this graph is going to move up just because of the shape of it, really. So really, I'm just going to find out what exactly that x value of the turning point is. And then after that point, we know that this thing is going to just increase. I feel like this question is more of a substitute for that question that they would ask when they would say determine the value of n for which this would be a minimum, the expression will be a minimum or maximum. I think this is a substitute for that kind of question. Okay, so this is what we have. I'm just going to find that x value of the turning point. You can use two methods. You can use calculus, derive this, and set it equal to 0. Or you can use the equation of the axis of symmetry, which is x is equal to negative b over 2a, right? And so negative b, what is our b value here? So this is still in the form of an squared plus bn plus c. So b is negative 9 over 2 times a is 6. So that's what we have there. Okay, so what is negative 9 over, well, that's going to be positive 9. 2 times 6 is 12. And you can see that these two have 3 in common. So if you simplify that, 9 divided by 3 is 3. 12 divided by 3 is 4. So we have 3 over 4. Okay, so 3 over 4 is a improper fraction, but that's okay because the question is really just you need to show them that the pattern is going to increase. Well, we know that since a is greater than 0 and this is the turning point, or really the x value of the turning point, right? So if that's the x value of the turning point, 3 over 4, right? Then everything after 3 over 4, do you see that this graph is going to increase for that? And because it is a pattern, we are going to be using natural numbers really, okay? You will not use negative numbers for the n values of a pattern. So since this is already a positive number, it's always going to be increasing, okay? So we can just conclude and say that Tn is equal to 6n squared minus 9n plus 6, of course, will be increasing where n is, of course, greater than 3 over 4, right? And n is an element of natural numbers. That's what's going to happen generally, and it's always going to increase like that because we have a positive number here. Okay, so that is the last question of question 2. So we move on to question 3. Okay, so now we're on question 3 and 3.1. We have a series. So it's 3 plus 6 plus 12, and it's going till n terms. And they tell us that it's geometric. Okay, so in this pattern, the first question that we are given is we need to write down the general term of the series. Okay, so it is a geometric pattern. In order to find the general term, all you need is the value of a, which we can say is 3, and the value of r, which we can find by saying term 2 divided by term 1, which is going to be 6 over 3 is 2. You can also confirm this by saying term 3 divided by term 2. 12 divided by 6 is also 2. So we have a and r. We can just say Tn is equal to a, which is 3, multiplied by r, which is 2, raised to the power of n minus 1, and that is our formula. Okay, moving on to the next question. 3.1.2, they want us to calculate the value of k such that this, where we have the sum beginning from p being equal to 1, right, ending at k, which is great, ending at k, and I'm glad that we're starting at 1, where we have 3 over 2 multiplied by 2 to the power of p is equal to this. Okay, do you see that the ratio here as well is also 2, right? They did not they will not go ahead and just introduce a brand new equation all of a sudden. You see that this is a followed question. Okay, it comes after that. And we can also see that here we have 2 as the ratio, here we also have 2. The only thing they did here with this p, I'm noticing this became a 3 over 2 because you see this 2 is raised to the power of n, which you can see as the p, right? And it has a minus 1. If you separate it, it's 2 to the power of p times 2 to the power of negative 1. It's kind of like just seeing, oh, okay, this is negative. So because it's negative, the law of exponents says, if this thing is negative and I want to make that exponent positive, I'm just going to take it from where it currently is, right? If it's on the numerator, I will move it to the denominator. Right now, it's on the numerator. Every number and variable on their own, if they're not as a fraction, they're on the numerator. So all they did was they just pulled that to the bottom. And that's probably what's going on there. So that explains that 2 to the power of p over the 2. Just the 3 was a coefficient, so it just ended up being like that. And so they just put the 3 to be over the 2. It would still mean the same thing, really. Okay, so it's not a new, all I'm just trying to say here, it's not a new pattern, it's the same pattern. They just modified the way it looks. Okay, so in this question, we just have to find the value of k. So let's us just carefully see what they're speaking about. Please do also check other questions with sigma in it, because it can be confusing sometimes, but this one is quite straightforward though. Remember that in sigma notation, this is where you start, this is where you end. But if you want to find how many terms there are in this series, you need to count them like this. To find out the number of terms, you must say the top number minus the bottom number, right? Plus 1. The reason for this rule is because some patterns don't necessarily start at 1. Sometimes they can start at 0 or 2. And so to make sure that you do find out the amount of terms there are in the series, you use this formula, okay? But you see that in this one, there's no confusion. P is equal to 1. We have nothing to worry about. We can easily just find k, okay? To find k, you're just going to have to find out where exactly the term ends. The value of k is literally how many terms there are in this series, because p starts at 1. Okay, so I'm just going to use the sum formula. Since I know the sum of the series, okay, the sum of the series is the sum of n terms, because I don't know the amount of n yet, or k terms, is equal to 98301, right? I, however, know the first term. The first term is 3. Okay, I also know the value of r. So this is, sorry, it's a 2, right? I know all of these already, so I can go ahead and just find the value of k. And this is how I'm going to find the value of k. Okay, so in this equation, and really what I was trying to show you in that first part is, you see the value of k is literally going to be whatever your value of n is here. Okay, there's no confusion, because p is starting at 1. So for example, let's say I said k was 10, right? Remember that n specifically stands for the number of terms. K is just where you end off, right? So if you think about it like that, how many terms would there be here if k was equal to 10? There would be 10 terms. There's no confusion in this one because p started from 1. So whenever you see that whatever the starting value here is 1, then the value that you have here is going to be where you end, first of all, but it's also going to be the amount of terms that you have. So there's no confusion with this one. K is n. You can substitute k in place of that, which I'm going to do. So Sn is, so let me just go ahead and put this down. This is 98301 is equal to, and our a value is 3. We're multiplying by 2 raised to the power of n, which I'm going to call k. Okay. And then we have minus 1 all over, and then r is 2 again, minus 1. Okay, so we just have to simplify this. It's just arithmetic, that's all. So when simplifying this, we're just going to say 2 minus 1 is 1. So you have 98301 is equal to, since this is 1, anything over 1 is just going to stay exactly the same, right? So this is what we have. Then I can get rid of the 3 by dividing both sides by 3. So if we divide both sides by 3, let's see what we get here. Here, we're going to get 32,767. And this is equal to 2 to the power of k still, minus 1. Then if you take the 1 over, it becomes a positive 1, making this 32,768 is equal to 2 to the power of n. Then this, because this is an exponential, you can use log or you can use exponential equations. So I know that since this is an exponential equation, since we have an exponent there, I'm just going to make the bases the same. So I'm going to put this as a base of 2 by saying 32768 is equal to, and I'm going to just say shift and press the factorize button, fact. See that degrees and 3 commas. And it gives me 2 to the power of 15. So it means this is 2 to the power of 15. And it's equal to 2 to the power of n. by the law of exponents, if you have the same basis in an equation, you can make the exponents equal. So it means that n, or rather k, why did I start writing it as n? K is equal to 15. Okay, and that is our answer. There's no confusion with that one because it started at p is equal to 1. Okay, moving on to the next question. So the next question is 3.2, and this is what 3.2 says. It says that a geometric sequence and an arithmetic sequence have the same first term. You see, the minute they start saying stuff like this, I don't even read the rest of the question. I just start writing down because I don't like to get intimidated by the question. Sometimes you scare yourself before you even work on the question. So to not scare yourself, you have to calm down and analyze what's going on. As they are saying what's going on, be writing it down, be representing it in a way that you will understand. So I heard a geometric sequence and an arithmetic sequence have the same first term. So this is what I'm going to do. I'm saying I have a geometric sequence and I have an arithmetic sequence. That's what I'm doing now. Okay, two sequences. And they're saying that they have the same first term. So if this first term's name is A, that first term's name is also A. It's exactly the same thing. Then the next thing they say is this. The common ratio of the geometric sequence is 1 over 3. So this is of the geometric. The common ratio, R, is 1 over 3. Then they say the common difference of the arithmetic sequence is 3. That's D is equal to 3. Okay, so that's what we have so long. Then this is what they're saying. The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. Let's break that down. So, the sum of the 22 terms of an arithmetic sequence. So, here we have the sum of 22 terms. That's what we're speaking about, right? Sum of 22 terms of an arithmetic sequence is 734 more, right, than whatever the sum to infinity of the geometric sequence is. So there's the sum to infinity of the geometric sequence, but this sum of 22 terms is 734 more than that. That's why I'm adding. So 734 plus the sum to infinity, okay, of that geometric sequence. So that means here we have a geometric sequence, sum to infinity. Right? We're going to find the sum to infinity here, and then they're telling us that the sum of 22 terms is this amount more than the sum to infinity. So something that we can do here is I can just say, okay, fine. Why don't I just let the sum to infinity, and I'll call that x. I'll just call that x. X is equal to this, right? So it means that, or let me say sum to infinity is equal to x. Then I just have to find what exactly the sum of 22 terms is. I know that this is 734 plus the sum to infinity, which I've called x. Okay, so you see now we have two equations, the sum to infinity and the sum of 22 terms, and they both include x. I've just decided to call that sum to infinity x. Okay, so this is technically not an equation, I'm just naming this. Okay, so the question is calculate the value of the first term. The first term is the value of A. So that's what we have to find. And they told us that A is exactly the same. So we're just going to have to use what they've given us. In the geometric sequence, they told us information about the sum to infinity. So we're going to go ahead and try and find the sum to infinity. Remember, that sum to infinity, I'm calling that x. So that sum to infinity, we calculate by saying A over 1 minus r, and so that sum to infinity, which I'm calling x, is equal to A. We don't know what A is, but A is exactly the same here, over 1 minus 1 over 3. And so 1 over 3, 1 minus 1 over 3 is 2 over 3, so that's A over 2 over 3. And if you simplify this, and let me actually simplify it here because you can't really do this on the calculator, it's the same thing as saying A divided by 2 over 3. So if you're dividing by a fraction, you're going to have to leave this exactly as it is, and you're going to tip n times. So you're going to tip this, swap the numerator and denominator, and then turn that into a times or multiply. So numerator times numerator, remember this is on the numerator, right? Numerator times numerator, that's 3a. Denominator times denominator, that's 2. So that's actually what the sum to infinity is, or that's what x is. Found that part. Okay, that's the sum to infinity of this geometric sequence, if as long as we don't have a, of course. Then we have to find the sum of 22 terms. So let's go ahead and find the sum of 22 terms. The sum of 22 terms of this, since they gave us d, we're going to have to use that sum formula that includes d, which is Sn is equal to n over 2, bracket 2a plus n minus 1 multiplied by d. And so we're saying the sum of 22 terms is equal to 22 over 2 multiplied by 2 times a. We don't know what a is, so I'm leaving that as 2a multiplied by 22 minus 1 multiplied by d, which they told us is 3. Okay, so this is what we have, right? Now I can fill in place of s of 22. I know that this is equal to 734 plus x. So I'm going to just replace that. 734 plus x, which is equal to 22 divided by 2 is 11. And then we're multiplying. We have 2a. This is going to multiply together. So 22 minus 1 is 21 times 3. 21 times 3 is 63. So that's plus 63. And it's positive because we have a plus here, which I forgot. And then this is what we have. Then I can just distribute that. So 734 plus x is equal to, and I have 11 times 2, which is 22a. 11 times 63. Okay, let me see what that is. And that is positive 693. And then look at this. You see, this is an equation. Here we have x, and we also have x here. What you can just do is to solve for a, we can just make x the subject in both. Okay, x is already the subject here, just make it the subject here. Or you could have just taken this and substituted into the equation. You would have still gotten to the answer. Okay, but I'm just going to make x the subject. So I'm saying x is equal to 22a plus 693 minus 734. So what's 693 minus 734? That is negative 41. So x is equal to, we have 22a minus 41. Okay, so I have a formula for x on both sides. So I'm just going to equate my formulas for x. So I can just say that x is equal to x. So here, let me put this one because this has a bigger value. So 22a minus 41 is equal to, the other x is 3a over 2, which you can really just see as 3 over 2a. See, you can rewrite it like that. And so this is going to be equal to, and we're going to have 22a, and we're taking this over because it's an a, so it becomes minus 3 over 2a. It's equal to, take the number over because like terms together, positive 41. What is 22 over 2? Okay, you can use a calculator, but I'm just going to be like 44 over 2. And so 44 minus 3 is 41. So 41 over 2a is equal to 41. And then we're just going to divide both sides by 41 over 2. Divide by 41 over 2. And so you can again use a calculator, but a here would be equal to numerator will cancel with denominator, tip and times. So 2. Okay, so a is going to be equal to 2. You can use a calculator. You will get to the answer still. And there, so that's our answer. The first term is 2. First term is 2. And that's our answer in question 3. Okay, grade 12. So we're on question 2. And 2.1 says, consider the geometric series where 4, 2, 1, a half. So as you can see, they're being cut into 2 the whole time. So 4 divided by 2 is 2 and 2 divided by 2 is 1. So since that is happening, they're really just being multiplied by a half each time. So 2.1.1 says, does the series converge? Justify your answer. So does this converge? Well, for a series to converge, your ratio needs to be greater than -1, but less than 1. Okay, so that is just the answer in like a equation sense. We can go into a more detailed explanation on that, but I think maybe I'll speak more about that in another video and what it really means for a series to converge. So remember what I said the ratio is. So that's really all you have to do here. Find the ratio. So the ratio you could find by saying the second term divided by the first term. And that gives us a half. So we know that a half is greater than -1, but it is smaller than 1. And so therefore the series does converge. Okay, so that is 2.1.1. Moving on to the next question. The next question, they want us to find or calculate the sum to infinity. So you just need the formula. The sum to infinity is equal to a over 1 minus r. So our a value here is our first term, which is 4. So that is 4 over 1 minus our r is a half. And then if we calculate this, it's really just 4 over 1 minus a half is a half. If you say 4 divided by a half, you're going to get 8, and that is your answer. Okay, moving on to the next question, 2.2. Okay, so question 2.2 says, given, and we have a case of sigma here. So sigma just means sum. Given the sum, starting where p is equal to k and ending at 10, of a series with this formula, 3 to the power of p minus 1, given that sum, okay, the sum of that series is equal to 29,520, we need to calculate the value of k. Okay, so this one is a little different because they put k here instead of on here. So it's just something that's a little different, but let's just try to look at it the way we would normally look at a sigma question. So they want you to find k, no problem. Since this is sigma, it's speaking about the sum of a series. And this is the sum of what type of series? Well, you have 3 to the power of p minus 1. And as you can see, your variable is on your exponent. So it means that this is a geometric series. Okay, so now that we know it's a geometric series, let's also just understand a few things about this. When you have the sum, the number that they have here is the value that you're going to start with. Meaning, in order to get your first term, you would take the value that they gave you here and you would substitute it in place of your variable in your formula, right? And then the number here is where you're going to end at. Again, you'll take that 10 and substitute it into there to get your last term in this series. So since they're still asking us to find the value of k and we know it's sigma, let us look at the formula we have here. Since our formula is 3 to the power of p minus 1. Okay, so this is the Tn formula, or let's call it the Tp formula since p is our variable here. So since our formula is this, let's compare it to the original, the general formula of a geometric series. And that formula looks like this. Tn is equal to a multiplied by r raised to the power of n minus 1. Okay, so if that is the case, let us just see. Do you see that you have p minus 1 here and n minus 1? So that's a good thing because now it means that they're really in the same format. And now, based on that, we can actually find out what r is. But here's the thing. If we can see that, okay, this is r, clearly, why can't we say a should be 1? Since that's the coefficient of the 3 here. Okay, there's an invisible 1 there, technically. Now, the reason you can't say that is because with sigma, they tell you where to start, okay? They tell you p is equal to a specific number, and by default, that has to be your a value. That has to be your first term, okay? So let's not make that mistake and call that 1. So what we can do here is, since we know what r is, let's actually focus on the main goal. The main goal is to use the sum formula to find k. Because this is sigma, okay? It's the sum of the series. So the sum formula, since we know r is 3, I'm just going to say that r is equal to 3. So since we know that, so you see r will not change. There's no confusion in that. As long as it is the thing with the exponent and it is in the same format, then that is r. So our sum formula is Sn is equal to a multiplied by r to the power of n minus 1 all over r minus 1, okay? And let's just figure out everything we need to find here. So in order to find k, we need to know what n is, we need to know what a is, and we need to know what r is going to be as well. Now n, I always mention this, I've mentioned this a lot. N, please note, n does not stand for the number that you end at. Many a times it will be the number that you end at, and that's only in situations where, let's say, p is equal to 1. And then in this situation, right, n would literally just be 10 because there are 10 terms. From term 1, from p equals 1, 2, 3, all the way to 10, there will be 10 terms. But once they change this, it's a little different, okay? So how I want you to see n is the number of terms, but how you find it is simply by saying you take the top, or let me actually stop calling it the top. Let's say you take the number that you end at and you subtract it by the number that you start at and you add 1. That's how you find n. So with our calculation of n, it's going to be n is equal to the number we end at is 10 minus the number we're starting at is k, and then plus 1. And so if you simplify this, this is n is equal to 10 plus 1 is 11, so it's 11 minus k. And we're going to leave that as n. That is our value for n. So we have n. Do we have a? Not yet. Well, we have to find a. Remember, a is your first term. It doesn't mean you substitute 1 in place of your variable in your term formula. Okay, you don't substitute 1 in this case. What you're going to do is this. Because they say p is equal to k, they didn't even tell you where you start at. We need to find out that. Since this is where we start at, to find term 1, which is a, so t1 is a, to find that, you're going to have to say, use your formula, you say 3 to the power of, and in place of p, since they told us we are starting at k, we need to substitute k to find our first term for this particular series. So I'll substitute in place of that k and then minus 1. That's all I have there. And I'm going to treat that as my first term because it is my first term since I don't know what k is. Okay, so we have r, we have a, and we have n, and we are ready to start. So let's go ahead. So we have the sum of how many terms? This is the sum of n, we know is 11 minus k. So I'll call that s of 11 minus k is equal to, our a value is 3 to the power of k minus 1. This is just a case where you just have to trust the process and trust that you actually have found each of the values that you needed to find correctly. And then r is 3. So 3 to the power of, well, we know n is 11 minus k minus 1 all over r minus 1, which is 3 minus 1. Okay, then s of 11 minus k, or really the sum of this series that we're speaking about, is 29,520. So we're going to put that there. 29,520 is equal to, and let's go, we have 3 to the power of k minus 1. And then we have, well, I guess we can just multiply those already. So when you're multiplying, since it's 2 terms inside, it's going to distribute like that. And so 3, they have the same base. So you're going to add the exponents, keep the base the same, and add the exponents. If you say k minus 1 plus 11 minus k, you don't need brackets because we're adding. So what's going to happen is you're going to have your k and your k cancel, because they will simplify to 0. And then 11 minus 1 is 10. So we have 3 to the power of 10 there. And then this multiplied by negative 1 will just stay negative 3 to the power of k minus 1. Okay, so that there's no confusion there. Remember, the negative is outside. And it's actually this base of 3 being raised to the power of k minus 1. And we have that over 3 minus 1 is 2. Okay, so this is what we have so long. As you can see, k is nicely on its own. We just have to find our way to get to it. So the first thing that is stopping us from getting into k would be this 2. So let's go ahead and get rid of the 2. Since here you're dividing by 2, to get rid of the 2, you need to multiply by 2. But you have to do so on both sides since this is an equation. So what do we have when we say 29,520 multiplied by 2? That gives us 59,040. Okay, and then we have is equal to, and this is 3 to the power of 10 minus 3 to the power of k minus 1. Okay, so this is what we have so long. Let's keep going. Now, what do we have to do next? Well, the thing is, I see that this is negative, and I don't like the thing being negative when it includes the variable we're looking for. So what I'm going to do is I'm going to take that over. Okay, so when I take this over, it becomes positive 3 raised to the power of k minus 1 is equal to, and I'm going to simplify this 3 to the power of 10. So 3 to the power of 10 on the calculator is, we have 59,049. Okay, and what I'm going to do with this 59,040, I'm going to take that one over. So it becomes negative 59,040. Okay, then we have 3 to the power of k minus 1. As you can see, 59,000 and 59,000 will cancel. 49 minus 40 is 9. So we have 9 there. And so 3 to the power of k minus 1 is equal to, make the bases the same since it's an exponential equation. It's 3 to the power of 2 is 9. And now that the bases are the same, we can therefore say that k minus 1 is equal to 2. And therefore, k is equal to, take that negative 1 over, k is equal to 3. And that is our answer for k. You can go ahead and test it out. You can go ahead and take k is equal to 3 and put it there. And then find your first term, second, and third term. Then find the sum of that series, making sure that n, you find n by saying top or the end minus the start plus 1. And then you actually find that you will get this number. Okay, so k is equal to 3. And that is it for question 2. And let's move on to question 3. Question 3, we have 3.1. They say consider the quadratic number pattern, which is 3, 7, and 12. So 3.1.1, you have to show that the general term of this number pattern is given by this equation. Okay, so they already told us it is a quadratic pattern. So firstly, we'll just have to find the first difference. So the first difference, you can go ahead and say 12 minus 7, which gives you 5, and then 7 minus 3, which gives you 4. And then find the second constant difference. That will be 5 minus 4, which gives you 1. So now that we have that, you're going to equate these to the following. So the first one, the second difference, you equate it to 2a. Then this first number here in the first difference, you equate that to 3a plus b. And then that first number in the quadratic, you equate it to a plus b plus c. Okay, so how we find that, we just say 2a is equal to 1. And then to solve for a, divide both sides by 2. And so it means that a is just equal to a half. Okay, so as you can see, we actually do have a half there as well. And then we have 3a plus b, but we already know what a is. So that's 3 times 1 over 2 plus b is equal to 4. And then 3 times 1 over 2 is 3 over 2. But I'll just start here. Say b is equal to 4. I still have 4. So that becomes 3 over 2. And if you take it over, it becomes negative 3 over 2. Okay, so quick way to calculate this is you can just make 4 have a denominator of 2. So 4 as a denominator of 2 is 8 over 2 because 8 divided by 2 is 4. So b is equal to, the numerator subtract, the denominator stay the same. So 8 minus 3 is 5 over 2. So there we also have b as 5 over 2. Then to find c, you're just going to say a plus b plus c. So that is 1 over 2 plus b is 5 over 2. C we don't know yet is equal to 3. Then this is going to be, as you can see, the denominators are the same. So that's 6 over 2 and 6 over 2 is 3. So 3 plus c is equal to 3. There's 3 on both sides. You can cancel, or it's like taking 3 over. So that becomes 3 minus 3, which is 0. So c is actually just equal to 0. And so the Tn pattern, the general form is Tn is equal to an squared plus bn plus c. And so this means that we're going to have Tn is equal to our a value is 1 over 2n squared plus 5 over 2n and then plus 0, which is really nothing. So that is your answer. Okay, so there we have shown that, and that is for 3 marks. Moving on to the next question. Okay, grade 12s, we are finally on 3.1.2, and it says, what number must be added to Tn minus 1 so that Tn is equal to 13,527? Okay, let's think about that. So in order for us to find this, let's actually understand what exactly they mean by Tn minus 1. So for you to understand what they mean by Tn minus 1, you need to understand what Tn means. Tn refers to the last term. Okay, when they're speaking about find the value of Tn, is usually the last term in that pattern. So we're saying if we have a term Tn and the value of it is 13,527. So where is this going to lie? Well, I want you to see that they say n minus 1, meaning the position minus 1. And so if they say Tn minus 1 and we're subtracting 1 from the position, it means we're really just going 1 position backwards. That's Tn minus 1. So if this is the last term, this is your second last term they're referring to. Okay, so how does this now make sense with the question? The question is saying what number should be added to this so that this can actually have this value. So if we're looking at that, they're really asking you what number should be added to this one so that we get this. Do you see now that they're actually asking you for a first difference value? Because for you to get this, you take this one and you add a first difference value and you will get that. So it will be better if we just get our pattern from above here, and this will make more sense with the pattern. Okay, so this is our pattern we have, and we can see that in order to get the next term, for example, in the third term, you have to add a first difference of 5 to get that next term. Likewise, in order to get this number, you're going to have to add a first difference value to this Tn minus 1, right, in order to get that. So ultimately, they're really asking you, because they say what number must be added to that. They're really just asking you for this value here. What value do we have between the last term and the second last term? That's all we need to find. Okay, so to find that, it's actually not going to be so complicated, because all we can first of all do is, since we know this is Tn is equal to this, how about we find out what position number this is? What term number has a value of 13,527? Let's go ahead and find that first. So to find that, you're going to use your Tn formula. Since we knew that Tn is equal to a half n squared plus 5 over 2n, right? So to find the position where Tn is equal to 13,527, you just replace Tn with 13,527, okay? And rewrite that, of course. Then we can just take this over. So this is 0 is equal to a half n squared plus 5 over 2n, and then minus 13,527. Okay, so this is a quadratic equation, and it can probably be factorized, but I see that there's an issue here because of the 2's that we have on the denominator. So what we can do is get rid of those. And so to get rid of a denominator of 2, it's really just being divided by 2. So you'd have to multiply by 2. So what we're going to do is multiply by 2 on this side and on the left-hand side, because it's an equation. So that's going to give us 0 times 2, which is 0, is equal to, and when they multiply, the 2 times a half, the denominators cancel, and you just be left with your n squared. The 2 times the 5 over 2n, the denominators cancel, you're left with 5n. And then the 2 times that, so we just have to calculate that. And you see that when we calculate that, it's going to be negative still, so 27,054. Okay, so now that we have this, we can factorize or pretend to factorize. So open up 2 brackets and say this is n times n to give us n squared. And let's find the factors here. So you can go ahead and use the quadratic formula. That's what I'm going to do. I'm going to substitute this into the quadratic formula on my calculator. Okay, and the first solution I get, remember that is the solution, meaning the value of n is 162. And so if this is a solution, then it means that your value of n is actually supposed to be, or your factor, sorry, is n minus 162, because it's like taking 162 over. Then we change that plus to a minus, and we get negative 167. Remember, that is your solution. So n is equal to negative 167, and so it means that your factor is n plus 167. Okay, so just already from this, you can see that the negative 1, we cannot accept that because terms are never negative. Terms are positions, okay, like position 1 and 2. They kind of work like things like days. They count on, they move, and they're not negative. So it's like day 1, day 2, but you cannot get day negative 5, okay? So n is equal to 162. That means that T162 or term 162 actually has a value of this 13,527 that they were referring to. That's the Tn. Okay, we know what that is now. That is that term 162 with 13,527. Okay, so how can we use this to get to where we want to be? This is what we want. We want the value of this. If this is term 162, so now we know, okay, this is actually term 162. Then that would mean that this Tn minus 1, the second last term, would be term 161. And so what term would this be? Well, you can remember this by looking at this. For example, you see, look at the third term and the second term. The arithmetic value, okay, the arithmetic term between the third and the second term is the second term in the arithmetic pattern. There's your first, there's your second. So that's an easy way to see that. If you have between term 3 and term 2 in your quadratic, then we will have term 2 as the number between these two terms. So if this is term 162 and this is term 161, then what term is this? This is term 161. Okay, so if we know the term now, and I think we should just be updating them and letting them know. So I first of all tell them that it means that Tn minus 1 is equal to 161. And now we know that the term that gets added is the 161st term. So to find its value, you're just going to have to substitute term 161 into the formula of your arithmetic pattern. And we can easily find that formula by using its Tn formula. So Tn is equal to A plus n minus 1 times D. And we're just going to substitute what we need to substitute in order to find that. Okay, so now that we have this, we're going to just say this is term 161 is equal to our A value in our arithmetic pattern is 4. Okay, so we're going to say it's 4 plus n is 161 and then minus 1, of course, and then our difference, okay, our constant difference was 1. So, and then we just have 1 there. Okay. Okay, then the answer here, you can just say, you see 1 times anything stays the same. So it's really just 4 plus 161 minus 1, which is 160. And as you can see, that's going to give you 164. Okay, so it means that the value, the number that was added to Tn minus 1, to that value was that 164. Now we know what that value is. It's 164 that was added to this in order for you to get that over there. And then I'm just concluding. So the number that was added is 164. Okay, so that is it for question 3.1.2. And we finally move on to the next question. Okay, so 3.2 says, given an arithmetic sequence with term 1 being equal to 8 and term 2 being equal to 11. So we have 3.2.1, calculate the value of n if Tn is equal to 41. Okay, so they've given us enough information. Please remember that T1 is also the same thing as A. And we know that this is an arithmetic sequence. So we just have to find n if Tn is equal to 41. So I'm going to treat T1 as A, and I also have that information. So I guess we can use that to find D. So our formula for an arithmetic pattern is Tn is equal to A plus n minus 1 times D. And so I know Tn is equal to, and I have my A value as 8. So that's 8 plus n minus 1 times D. But I can just go ahead and substitute T2, which is probably what I should have already done. So I'm going to say T2, okay, let's just rather put it in here. T2 is equal to 8 plus 2 minus 1 times D. And now we know the value of T2 is actually 11, okay? So T2 has a term value of 11. So it's equal to 8 plus 2 minus 1 is 1. 1 times D is still D. And then to solve for D, you leave D here and say 11 minus 8, which gives you 3. So we now know what this is. D is just equal to 3. And so since we know what D is, we can go ahead and find what they asked us to find. They asked us to find the value of n if Tn is equal to 41. Okay, so what term has the value of 41? So Tn equals, and we're going to say we have now 8 plus n minus 1 times 3. Okay, now Tn, we already know what that is. It's 41. They told us that. So we'll say 41 equals, and you can go ahead and start by taking 8 over first. So if you say 41 minus 8, you're going to get 33, which is equal to, you see that these two are being multiplied. Since this is the first, it's just one term, right? You can put it in front. So it's 3 times n minus 1. Then you can get rid of the 3 by dividing both hand sides by 3. And then 33 divided by 3 is 11. And we have n minus 1. If you take the negative 1 over, that's 11 plus 1 is n. And so therefore n is equal to 12. So now we know what that is. We know that n is 12, and that is our answer for that question. Okay, moving on to the next question. Okay, so 3.2.2 says, a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. So of that one. So they say for the new sequence, we have P8 this time being equal to 1 and P11 being equal to 2. So this is P8 and P11. Okay, and so forth. Write down the value of P41. Okay, so since they said using the term position and term value of the given arithmetic sequence, let's look at the old one first. Okay, so we look at the old one, okay, the old sequence, and we'll also compare it to the new sequence. So the old sequence that we had, this one, what they told us was that T1 was 8 and T2 was 11. So if T1 is 8, T2 is 11, then the new one, let's just call it new sequence. The new sequence, they're telling us that this is what they have here. Instead of T, they have P, and they have P8 being 1 and P11 being 2. Okay, do you see something similar with these? Do you see that what they actually were saying, they mentioned that the term positions and the term values, right? They use that of the given arithmetic sequence. Do you see that they just swap places? T1 now has a value of 1 in your new sequence, and P8 has a value or had a value of 8. They really just swap the position number with the values. Okay, so that's actually what's going on here. And it's interesting that they ask you for P41, because you see here that they asked us what n was if Tn is 41. Okay, so in that case, since we know that T12, right, is equal to 41, since we can see that these ones are swapping, if T12 is 41, then P41 must be 12. Okay, and this would really work like this especially because this is an arithmetic sequence. And the thing about arithmetic sequences is they would still be consistent with their difference, okay? The common difference in these two patterns may not be the same. True, that they will not be the same, but the common difference is still going to be exactly the same. Like if you go from P8, right, and you go to P9, and P10 and P11, you'll notice that the common difference would stay exactly the same. And so because of that consistency, it will help to actually swap these like that. Okay, so for this one, P41 is just 12. Okay, so I'll just tell them, therefore it means P41 is equal to 12. And that's probably why it's 1 mark. So they wanted you to see that. They just swapped it. Okay, we move on to the next question. Okay, so the last question is calculate the value of the first term in the new arithmetic sequence, and the new one. So they want us to find A in the new arithmetic sequence, and it's for 4 marks. So it's really just calculations we have to do. Let's just use what we know about the old arithmetic sequence. Now, unfortunately, we don't know what the first term is because they're asking us what the first term is. However, we know that in the new sequence, we have P8 being equal to 1 and P11 being equal to 2. So from this, despite the fact that these two terms, they don't really come directly after each other, okay? But there's something that I mentioned in that previous question now. You see, the thing about these terms is, yes, they don't come right after each other, but we know there's a P9, we know there's a P10. And the consistency between them is that you're going to notice that what you keep adding or subtracting to get to the next term is going to be exactly the same. So why don't we just call that D? I'm going to say that we're adding D. So we're going to go from P8 and add a D and get to P9, right? And then from P9, add D and get to P10. And P10, add again D and get to P11. So it means that from P8, which has a value of 1, you just have to add how many sets of differences? 3. 3 differences to get to P11, which has a value of 2. And we can use this formula to find the value of D. So that means 3D is equal to, we have 2, and we're going to take 1 over, which becomes a 1. 2 minus 1 is 1. And then divide both sides by 3. And so we know now, okay, D is equal to 1 over 3. Okay, we have enough information now. So we have enough information to finally find the value of A. So since that's the first term, of course. So to find the first term, you can just use the Tn formula. Tn formula is Tn is equal to A plus n minus 1 times D. So we don't have A, that's what we're looking for. We have D, and we just need something to be filled in for Tn and n. To do that, we can just use one of the terms we have already. So to be safe, well, you can use anyone, it's going to be fine. But let's just say we decided to use P11, okay? You can use anyone in this case because there's no P1. So it's fine. So P11 is 2, and I'm going to use that. And I call this Tn, but I should call it Pn since it's this formula we're talking about. Since we know that P11 is equal to 2, we're going to substitute this into this formula. So we're saying that P11 is equal to, we don't know what A is, and we have plus, our n value is 11 minus 1, and our D value is 1 over 3. And then we have P11, which is 2, is equal to A plus 11 minus 1 is 10, and then times 1 over 3, of course. 10 times 1 over 3 is just 10 over 3. And so to find A on its own, just A, you're just going to take your 10 over 3 over. So 2 minus 10 over 3 is equal to your A value. Okay, so 2 minus 10 over 3, I don't like to reuse calculators too much. So I'm just going to change 2 so that it has a denominator of 3, and I can change 2 into 6 over 3, because 6 divided by 3 is 2. And so 6 minus 10 is negative 4. So it means that A is finally equal to negative 4 over, and the denominator stays the same. And that is the value of A. Okay, we are now on question 2. So this is the sequences and series part of this paper. And we have question 2.1, which says the first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. Okay, a lot of information they're given. And they want us to calculate the sum of the series, which contains 20 terms. Okay, let's go ahead and start off with this question. So in the information, you see that they're giving us that the first term of this series is 7. When they tell you the first term of an arithmetic or a geometric, you can call that A. So they told us that A is equal to 7. And then the common difference of the series is 5. So we know the D value. So D is equal to 5. And we have to basically find the sum of 20 terms. Okay, so it's the sum of series formula for an arithmetic, but it's the one with D because that's what they gave you. So we're going to say Sn is equal to, and you have the formula in your formula sheet. So here it is. And then we're just going to substitute. So S of 20 terms is equal to, in place of N, that is 20 over 2 multiplied by 2, and A7 plus N, which is 20 minus 1, and then times 5, which is D. And then you can just punch that into your calculator and find the answer. And you see that that is equal to 1090. Okay, that is it for that question. Moving on to the next question. The next question, 2.1.2, says the original arithmetic series is extended to 75 terms. We should write that down. So we have what they told us to find was the sum of 20 terms, right? But they're saying that this arithmetic series that we have, it is extended to 75 terms. So it goes all the way to 75 terms, so T75. Then the sum of these 75 terms is 14,400. That's also very important. I'm just going to try to find a way to just like put them all together. So the sum of it, let's just say, we calculate the entire sum, and then that would give us that 14,400. Then they say, using sigma notation, write down an equation for the sum of the terms added to the original series. So we need to write it in sigma notation first of all, but it needs to be the sum of the terms that have been added to the original series. You know that the original series, right? Where they spoke about this, they said we ended at term 20. So 20 terms. So the original series had 20 terms, which should be probably here. And then they are now saying that this gets extended. So you need to write an equation for the sum of terms that have been added. If there were originally 20 terms and you knew that the sum of those 20 terms that we found was 1090, so if we know that this is the sum of the 20 terms, how do we know what was added, okay, to get the total sum of 75 terms? Well, we would actually have to find the remaining part of this part that we have not expressed. And we can find out how many terms there are here. So if the original series had 20 terms, then it got extended to 75 terms. The remaining series that you have, the amount of terms that you have here would be 55 terms, okay? So because 20 terms plus 55 terms would give you the total of 75 terms. So what they're asking us to express in sigma notation is an equation for these 55 terms. Let's go ahead and do that. So you see with sigma notation, you need to have the Tn formula because you know you have sum and then you have the Tn formula over here. So let's actually find that first. So Tn is equal to, and we're going to use this pattern that we have. That's what we have and we will use that. So we have to find the Tn formula. Okay, so Tn is equal to, let's go ahead and find it. So we already know A, we know what D is. So Tn is equal to A, which is 7, plus n minus 1 times D, which is 5. So that's what we have over here. Okay, now that we have this, I guess we can just simplify it a little. So 7 plus, and let's distribute. So times and multiplies. So that's positive 5n minus 5. And if you simplify this, this is 5n, and 7 minus 5 is positive 2. So this is our Tn formula. Now let's go ahead and write it in sigma notation. So this is the final part. We're just going to say this is the sum, right, of the series that has this formula. So 5n plus 2, right? And then we need to tell them what that series is equal to, what the sum of it is equal to. And here's where you have to do a calculation. You see that we already had the sum of the first 20 terms, right? And we also have the sum of the first 75 terms. But we're trying to focus on the sum of these 55 terms. So how much would that be? What would be the sum of the 55 terms? Well, you could say the sum of the 75 terms minus the sum of the 20 terms. And that would give you the sum of the 55 terms. Okay, and that's the number we get when we take the sum of the 75 terms minus the sum of the 20 terms. We know that these, right, when you add them, their sum is going to be 13,310. Now, I don't want to call it S of 55 terms because technically it's not S of 55 terms. And here I'll explain why. So I know that the sum of it gives us 13,310. The reason I don't want to call it S of 55 is because if you say S of 55, you're saying the sum of the first 55 terms. These are not the first 55 terms. These terms start here after the 20 because the sum of the 20 is from term 1, then term 2, term 3, all the way to term 20. So these terms start at term 21. Okay. And so that's why I don't want to call it that. And I think that explanation already covers this part. So here is how we're going to write this. Remember that you need to tell them where your sum starts, your terms start. We are going to start because we're using n here. N is equal to, you cannot start at 1. Again, this is not the sum of the first 55 terms. It's the sum of these 55 terms. And it starts at term 21. So n needs to start at 21 and end at what? So that it's a total of 55 terms. It must start at 21 and end at 75. So you end at 75. And here we can actually confirm that these are indeed 55 terms. To find the number of terms, you say the top minus the bottom plus 1. That's the formula. So 75 minus 21 plus 1 is indeed 55. So that is going to be our equation in sigma notation. Okay, so that is it for 2.1.2. Moving on to the next question. Okay, we are on question 2.2 and it says, the sequence of the first differences of a quadratic pattern is 1, 3, and 5. So that's the first differences specifically of a quadratic pattern. And then they say if term 99 of this quadratic pattern is 9,632, calculate the value of term 98. Okay, so let's lay down everything they have told us. So first of all, they're telling us the first difference of a quadratic pattern. Here's how these are structured. So remember the quadratic pattern, you will have your first term, second term, and just for the sake that they gave us 3 terms, let's just include 4 terms here. So we have 4 terms. And in these 4 terms that we have, they told us that the first difference of these terms are 1, 3, and 5. Okay, so here's what we can actually take out of that. So how we will get these is simply by saying this term 2 in your quadratic minus term 1, and that's what's going to give you the 1. And then term 3 minus term 2, that's what's going to give you the 3. And term 4 minus term 3 will give you the 5. That's how we have those. Okay, so here is what they're actually telling us. They told us that if term 99, okay, so term 99 is, let me just leave that in green. Term 99 is 9632. We need to find the value of term 98. Okay, why don't we just see the relationship between how term 98 relates with term 99? Do you see that in order to actually get term 99, you're going to have to say term 98 plus a specific first difference, and then it will give you term 99. So that means that you need to find out what first difference was added to term 98 to get term 99. So that's our goal now. Now, to find this, you can actually think about it like this. We're trying to find out what term in the first difference, which term in the first difference is between term 98 and term 99. You can look at it here. For example, look at this. You see 3. 3 is the second term in your first difference. It lies between the second and the third term in the quadratic pattern. Likewise with this 5. 5 is the third term in your first difference. It lies between the third and the fourth term in your quadratic pattern. So if this lies between term 98 and 99, then that means that this is term 98 of your first difference. Okay, so here now we know. All we have to do is find out the value of term 98 of our first difference. We can easily do that because we have 3 terms in our first difference. And the first difference is an arithmetic pattern. So the formula of an arithmetic pattern is Tn is equal to A plus n minus 1 times D. And then term 98 is equal to, and we're saying A, which is 1. Okay, that's the first term in your first difference. Plus 98 again minus 1, and then multiply by D. What's the difference? Oh, to find the difference, you just say term 2 minus term 1. And as you can see, that actually just gives us 2. 3 minus 1 is 2, so 2. Okay, so let's go ahead and punch that in and find out what exactly term 98 is on our calculator. Okay, and we get 195. Okay, so we know what that is. And finally, to find out what term 98 in your quadratic pattern is, because we don't have any other information, we don't even have its formula, we can just say, since term 98 plus this number 195, right? Since that is going to give you this number 9632, then how would you get term 98? Just move backwards. So you're starting from term 99. Because you added when you were going this way, you must subtract when you're going backwards. So term 98 is going to be found by saying 9632 minus 195. Minus 195. And that's going to give you term 98. Sorry about that. Okay, that gives us 9,437. So there we go. Term 98 of the quadratic pattern is that number. You can also just make that clear because you know you have a 98 there, but that's for the first difference. Okay, so there we go. I concluded with that. Okay, so that is it for that question. Moving on to the next question. Okay, and then 2.2.2 says, if it is further given that the third term of the quadratic pattern is 32, so quadratic pattern's third term, determine the general term Tn of the quadratic pattern. Okay, if you don't really know what they mean, then just take your pattern again and then just substitute what they were referring to. And then we'll be able to see the bigger picture here. So this is already what we had. And they told us that the third term of the quadratic pattern is 32. So the third term is 32. And you have to now use this information to find the Tn formula. Okay, so let's see. You know that to find the Tn formula, all you need is the first term in the quadratic, first difference, and second difference. The only thing missing is this. So how do we get the first term in the quadratic? Well, we can just work backwards like we did with the term 99. To get the next term, because these are positive, when you're going forward, you're adding them. So when you're going backwards, you're subtracting them. So to get term 2, you say 32 minus 3, and it'll give you term 2. So I don't really see any need for calculation, but yeah, sure. Term 2 is 32 minus 3, and then we'll just put that down, which would be 29. So we have there 29. And then how do you find term 1? You would say 29 minus 1, which gives you 28. So there, term 1 is equal to 29 minus 1, which is 28. Okay, now that we have these, we can finally find that. So remember just to equate them to what they should be equal to. This is 2a is equal to, this is 3a plus b is equal to that, and this is a plus b plus c. Okay, let's go ahead and find this. So 2a is equal to 2. And then solve for a. That means that a is equal to 1 because we divide both sides by 2. And now that we have a, 3a plus b is equal to 1. But we already know what a is. It's 1. Okay, so that's actually b is equal to 1. And then we have 3 times 1 is 3. Take it over, it's minus 3. So b is actually negative 2. And then c, we have a and b. So we're saying a, which is 1, plus b, which is negative 2, plus c is equal to 28. And then just solve here. So c is equal to 28, and then 1 minus 2 is negative 1. If you take negative 1 over, it becomes positive 1. So that's 28 plus 1, which is 29. So our Tn formula is Tn is equal to, so an squared, but a is 1, so it's n squared, plus bn, but that's negative 2, so negative 2n, and then plus c, which is 29. And that is our Tn formula. Okay, so that was the last question for question 2. And moving on to question 3. Okay, we are on question 3. Question 3 says, a circle with a radius 6 centimeters is drawn. Okay, so we have the circle with radius 6 centimeters. I think it's better to draw it here. Okay, and then they tell us that a second smaller circle is drawn through the center of the first circle and also touches the first circle internally. Let's actually just speak about what that means. You see, they told you that you have a circle. That's that bigger one, right? And then there's another smaller circle drawn. And the radius of this circle is 6. So here's the thing about it. Because the second circle passes the center of the bigger circle, right? And it also touches its circumference. You look at the bigger circle, from the center to the circumference is the radius. And they told us that that was 6 centimeters. That would mean that in reference to this second circle, that radius is actually a diameter, because it's going from one part of the circumference to the other part and it passes its center. Okay. And then the same thing happens with this other smaller circle. See that this other smaller circle, what would be the radius of the second circle? See, from the center to the circumference, what would be that radius is actually the diameter of this smaller third circle. Okay, so you can see what keeps happening. It's just like circles being drawn inside circles, and they're really just going to keep on being cut in half. Okay, and then they tell us a third circle is drawn through the center of the second circle and touches the second circle internally. Same thing. So the process of drawing circles continues and forms a geometric pattern. Okay, the question is, write down the radius of the third circle. Okay, let's expand this pattern, because it is a pattern. It's a pattern of the radiuses of these circles. So the first circle, let's look at the first circle, the bigger circle. We already know that the first circle's radius, and I'll call that term 1. I actually wanted to call it radius 1, but I don't want to confuse the odd with ratio. So term 1, the bigger circle, its radius is 6. We can see that. Then what happens with the radius of the second circle? The second circle's radius is going to be half of this, because you see the second circle? This 6 centimeters is its diameter. So its radius is half of it, which is 3. So that's going to be 3. And therefore, this would mean that the third circle, term 3, so this circle, its radius is going to be, so as you can see, this is the diameter of it, of this bigger circle, but it's the radius of the second circle. So half of it would be the radius of this third circle. So you're really going to take that radius that you have and you cut it in 2. In other words, multiplied by a half. So 3 times a half is 3 over 2. And that is your answer. So the radius of the third circle, is 3 over 2 centimeters, because they're in centimeters. Okay, there we go. I don't think we really need a calculation there. Okay, moving on to 3.2. 3.2 says calculate the sum of the areas of the first 10 circles. Okay, so they specifically want areas. How do you find the area of a circle? The area of a circle is found by saying pi r squared, which is perfect because right now we have a pattern telling us the radiuses or radii of these circles. So let's go ahead and expand what this pattern is going to look like first of all. Let's look at what the area of the first circle will look like. Remember that the radius of the first circle is 6. So to get that, T1 is going to be pi, and then radius is 6 squared. There we go. So that is term 1. That's what it's going to look like there. Then the second circle, the area of the second circle would be, again, pi, and then the radius of that one is 3. Okay, and they said the sum, so I'm going to add. So this is a series, so squared. Okay, radius squared. And then the third one is going to be pi, and then the radius is 3/2, so 3/2 squared. And this keeps going. And they want us to find the sum of the first 10 circles. Okay, so till term 10. You don't have to go find out what exactly term 10 is. This is the sum of these. So to find the sum of this series, we can just focus on finding the key things. You need to find the value of A. The first term in this series is pi times 6 squared. And then you need to find the value of R. What is the ratio? Okay, you could have thought about it, but you can also just say term 2 divided by term 1. And so that would be the pi times 3 squared divided by pi times 6 squared. Well, your pi's cancel, and then numbers really. And then 3 squared divided by 6 squared, that's going to give you a quarter. Here's why I say, because it's 3/6 squared. Okay, that gives you a half. Half squared is a quarter. So that gives you a quarter. So you see, we have all the information we need to find that. So they asked for the sum of these areas. So let's use the sum formula. So here's our sum formula, and we're just going to substitute. So we are saying the sum of 10 terms, right? 10 circles is equal to our A value is pi times 6 squared, and then multiply by our ratio is 1/4. And we raise it to the power of n, which is 10. And then we have -1 all over and r minus 1. So that's 1/4 minus 1. And then we just plug that into the calculator, and let's see what we get. And we get a decimal, so which is understandable because it's the area, and these radiuses, they start becoming fractions. So here we have 150 point, and we're going to round off to 2 decimal places. You see that 6 was going to round up and cause the 9 to become a 1. So that rounds to the 7. So that becomes 8. So we can leave it as 80. And this is the area. So we're going to leave it as centimeters squared. That would be the sum of those 10 circles. Okay, that is it for 3.2. And then we move on to 3.3. Question 3.3 says, which circle has a diameter of 3/128 centimeters? Okay, which circle has a diameter? You see, with this, we already have the radiuses of these circles. I don't want to work with the radius because the thing is, you're going to have to still remember, okay, the radius is twice the diameter is twice the radius, and I don't want to have to remember that. So let's form a new, and it's for 4 marks, so we can do this. Let's form a new pattern with the diameters of each circle. Okay, so a lot of patterns that we use here from the same information. So these ones are the diameters that we're going to have. So first diameter of the first circle. Remember that the radius of the first circle is 6. So the diameter of this first circle is double of this, 12. And then of the second one, it's just going to be half of it. Still the same pattern going on. That's going to be half of that. And then the third one is going to be half of that. So this is going to be 6, and this is going to be 3. Okay, you could have also just doubled it from here. See, double of that is 6, double of that is 3. Okay, so these are the diameters, and we need to find out which diameter, okay, of circle what, so Tn, is equal to 3/128. This is just a Tn question. But remember that this series sequence, okay, this is a geometric. So let's go ahead and write the general form of a geometric. sequence, the formula of that is a times r to the power of n minus 1, right? And we know what Tn is because we need to find out which term, which circle is this. Okay, circle number what? This is circle number 1, circle 2, and so on. So let's find that. It's going to be 3 over 128 is equal to, our A value is 12. Our R, it will not change. Still the same thing. We're just looking at the different aspects of these circles, the diameters instead. So it's still going to be a half. You can check. 6 divided by 12 is a half. So the power of n minus 1. And they just want us to solve for n in this equation. So we're looking at this and we're trying to get to n. The first thing that is stopping us from getting to n, apart from everything here, is the 12. So we need to get rid of 12 by dividing both hand sides by 12. So divide by 12. Now, of course, here you can say on your calculator 3 over 128 and actually use the division, okay, division sign. And when I do that, I get 1 over 512. And this is equal to, so this part now we're going to have, that cancels, and you're left with 1 over 2 raised to the power of n minus 1. Now, this is actually just an exponential equation because the thing you're looking for is in the exponent. So you're going to have to make your bases the same. So how do we make 1 over 1,512 a base of a half? Well, 512 can actually be a base of 2. See, if you say 512 and you say shift fact, you see that that gives you 2 to the power of 9. So it means that you have 1 over 2 to the power of 9. But here's the thing about 1. 1 can be expressed as 1 to the power of 9 and it will still stay 1. So that means that we can actually write this fraction as 1 over 2 all to the power of 9 is equal to then 1 over 2 to the power of n minus 1. And now the bases are the same. So equate the exponents. 9 is equal to, I'm just going to write it as n minus 1 is equal to 9. And then solve for n, or just take your negative 1 over, and that becomes 9 plus 1, which is 10. So that's what we get. N is equal to 10. So what this means is, which circle has a diameter of this? This is circle number 10. Okay, or the 10th circle. The 10th circle. Okay, so that is it for patterns. It really was not that bad. It's okay. And I'll see you guys in the function section of this paper.